My name is Andreas, and in this video we'll build an AI music generation SaaS. On the homepage, users can play songs made public by other users. Here is an example of 2 AI generated songs.
In the heart of the city, engines roar, steel beats awake.
Generating a song can be done by going to the create page and inputting a prompt for what the song should be about. Here is a lo-fi song, for example. When songs are created, they are added to a queue, and over on the right we can see the status of these songs. We can hit refresh to check the processing status and publish the songs when they are ready. Published songs can be found and listened to by other users as well. Instead of a single prompt, you can also create songs by providing the lyrics yourself and then picking the styles of the song. You can also pick the styles of the song yourself and then have an AI write the lyrics if you want to. And if you only want the beat of a song, you can just turn on instrumental mode. The model we use to generate songs with is called Step, and it was released end of May 2025. We'll be self-hosting the model completely for free. When a song is generated, it is added to a queue and processed in the background with Inngest. We can check the status of all songs being processed in the Inngest dashboard. We will use serverless GPUs running on Modal to host the music generation, thumbnail generation, and a large language model, and in this dashboard we can check the status of each request. When users have generated songs, they are also able to search the list of songs. Users can also rename their songs, and this is then the name shown to other users if they make the songs public. As you can see in this example, public songs can be liked, and we also track how many times every song has been listened to. We will use our self-hosted large language model to categorize songs into categories such as reggae, country rock, or soul. We'll implement a credit-based system where each song generated costs 1 credit. Using Polar.sh, users will be able to buy more credits by selecting one of 3 packs. We are going to use BetterAuth for authentication, and this integrates well with Polar.sh, so both of these components will be relatively simple to implement. After a purchase, the credits will be added to the account. Users are able to sign up, sign in, change their password, and more. And I'll be using BetterAuth UI to abstract away a lot of authentication logic. A new user starts with 100 credits. I'll be using Neon for the development and production database throughout the entire video, and I'll also use it to deploy the SaaS for free. The entire application will of course also be responsive and work on both mobile, medium, and desktop devices. Now let's get started with the video. Alright, as you saw in the intro, there are 3 different generation options, so I'll just walk you through what these are just before we move on to how they actually work, just so we have a little bit of understanding of what is actually possible with this system. So the first thing the user can do is the user can use something called a symbol mode. So in this mode, the user is just going to input a description of a song, and then both the prompt for how the song style should be, so if it is a rock song, a pop song, etc., will be determined based on the description, but the lyrics will also automatically be generated to fit the description of the song. So the user just fills in a simple input box, and then both the prompt and also the lyrics are going to be automatically generated using a large language model. The second option is going to be a custom mode, where the user automatically has the lyrics generated for them. So here the user is going to custom define the style of the song. So the user is going to input a prompt that defines the style of the song. So the user can, for example, input rap, lo-fi, rock, for example, if they want a mix of those 3 genres. And then for the lyrics, the user is just going to describe the actual lyrics, but then LLM is then going to write the lyrics for the track. So this is if the user would like to customize the specific style of the song with comma-separated tags like this, but then the user do not really want to write all of the lyrics themselves. The next thing the user can then do is that if they want to both define the style of the song themselves, but also want to write the lyrics themselves, they obviously also can do that. So this is going to be just a custom mode with manual lyrics. So they'll input a prompt for the song style, just as you saw up here with rap, lo-fi, for example. But they'll also input the lyrics manually, and thereby have full control over what the singer sings in the song. And then down here, this is not actually a generation mode, it is more an option that you can attach to any of these. So in any of the different options up here, you can check a checkbox that says instrumental, and then if there is this instrumental box checked on, it'll then just ignore all lyrics basically, and then only create the beat. So basically, for any of the above, instrumental mode can be toggled. So in simple mode, no lyrics are going to be generated by the LLM. That step is just going to be skipped up here. And then if it is custom mode, if you, for example, inputted a written or described lyrics, they're just going to be completely ignored, and then you'll only receive the beat back whenever you run inference. So these right here are the 3 options that the user has when generating a song, And now we can hop into the different parts of the system. And the first one I'm going to talk about is how we're going to generate the thumbnails, as you also saw in the intro. And to do this, we'll use something called a diffusion model. So we'll go into Hugging Face and then find a diffusion model. And then a stable diffusion model is basically just a model used to generate photos, or at least that is one of its use cases. So we'll use a stable diffusion model that is pre-trained by some researchers to generate thumbnails for the generated songs. And the one we're going to use is the one right here, stabilityai / and then it's going to be stable diffusion sdxl-turbo. And a model like this is very well integrated with Hugging Face, meaning that there are some libraries created by the Hugging Face team, which we can use to then quickly integrate with the model and actually get it up and running. So that is what we're going to do. Let me just talk to you a little bit about the flow whenever we receive a request from the front end. So whenever we receive a request, we both have to generate the thumbnail, but then also generate the song itself. So this is only the thumbnail generating step that you'll see right here. So first you should know that we're going to host the backend on serverless GPUs. So instead of spinning up a machine such as an EC2 instance that is just going to continuously run serving our program, we'll create a program that runs on a serverless cloud service. So this means whenever we get a request, it'll start up a machine for us, do the work that we defined, and then it'll close down the machine again. And then if you get multiple requests quickly in a row, it'll then be able to keep the machine open to prevent these cold starts that you might see with serverless machines. So first of all, if we take a look at the flow, this is going to be what happens whenever we get a request in a cold machine. So whenever we get a request to our serverless endpoint, we're at least going to load the AI models into memory. So this blue box right here is going to run once if the serverless endpoint is cold. That is, if nobody has called the serverless endpoint in a while. So whenever the user first of all clicks generate a sound, what will happen is that our Next.js application will send a request over to our Modal backend. Modal is where we will host our serverless endpoint. So first of all, the serverless backend is going to receive the request from the front end. Then our backend in Modal will check whether the stability AI model is already downloaded down to the image. If it is not downloaded, it is going to download the model. But if it is already downloaded, it is going to load the model into memory. This way it is only going to download the model the first time that it is not detected in the system, and otherwise just load it into memory if that is the only thing required. So this is just going to run on a server, on a cold serverless endpoint, and then whenever this is run, or if the serverless endpoint is warm, this is then going to be run in every single request basically. So what happens is that this model which we'll use, so the stable diffusion model, is going to be a text to image model. So this means that we'll need to create a prompt for the model to actually generate the image. And the prompt which we'll use is going to consist of these style tags which will be generated or supplied to the endpoint. So up here in the 3 different modes, if the user just inputs a description of the song like this, then the song style or this prompt is going to be automatically generated. The user can then also define these himself right there, also down here in the second custom mode. So in that case, we'll just take those directly and then pass them into the stable diffusion prompt. So now we have the actual prompt. So we'll take the style tags, for example, it could be pop and then hip hop like this. And then we'll combine this with another string that says album cover art right here. And then ultimately we'll get a prompt that looks like this: pop, rock, indie, for example, if that is what the user described, comma, album cover art. And then the stable diffusion model is going to figure something out and then create an image that looks like this, just as a cover art basically. So this is how we create the prompt. Next we pass this into the actual model and then we run image generation inference with the AI model. And the generated image is then going to be saved to the local disk with a UUID as a name. So that's just going to be something that looks like this, and then just a random number that is very unique basically. We can then take that file that we just saved to the disk, upload it to an S3 bucket. So that is just an online file storage system on AWS. And then after having uploaded it, we can then delete the file again from the disk because now it is in the S3 bucket. So we don't really need it anymore on our local system. So we'll take the image and just clean it up. So this is going to be the pretty simple flow which we'll use specifically for generating the thumbnails. And then next we can go ahead and talk about how we can use large language models for generating the lyrics, for example up in simple mode right here, or in custom mode 2 down here with automatic lyric generation. And we'll of course use a large language model for this. And the one we'll use is one called Qwen2, developed by Alibaba. It is a 7 billion parameter large language model, and we'll use it for a couple of different things. We'll use it to generate a prompt for the model if a song is just described, so if the user didn't describe this prompt themselves. So for example, if the user is in custom mode, the user will have to generate this prompt, define this prompt themselves. but then they could also just describe a song, like I explained. And then the large language model is then going to generate the prompt for them. So for example, if the user says a soft lo-fi song, that is just a textual description of a song, then the model is going to generate something like soft, lo-fi, piano, calm, 50 beats per minute, and then this will be perfect for passing into the music generation model whenever we need to use this in the next step. So a large language model like this, I will just want you to imagine ChatGPT, for example. You just pass in a prompt, and then you can ask it to do something with the prompt, and then it'll output some text which we can then use. So this is just a model which we can self-host, and it is very simple to self-host with Hugging Face as well. So the first case for using this model was then creating the actual prompt which we'll use to describe the style of the song. The second use case is going to be generating the lyrics if lyrics are described. So in both up here, all the way up, both in simple mode right here where the user just provides a description of the song, but also the custom mode with automatic lyrics. We'll have to actually generate the lyrics because the user didn't want to write all of these lyrics himself, which I totally understand. So instead of writing the lyrics manually, the large language model can do it for them, so we can just generate the lyrics for them, given a description of what the lyrics should contain. So that is going to be the second prompt, which we can pass into this large language model. And then lastly, we'll also use a large language model to generate tags/categories that can be used to categorize songs into specific categories. So for example, if you generate a rock song and then your prompt up here contains something about rock, then it might generate the tag rock for your song. And we'll then return this back to the front-end application. This means that whenever you go to the dashboard and want to look at all the published songs, all the songs will be categorized by rock, for example, hip-hop, etc. So we just needed a standardized method to actually find out what category a song belongs to, and therefore this large language model is great for doing this because we can pass in the prompt and also the lyrics if we want to, and then have it generate a specific tag or category for that song, which we can categorize it into back in the front end. And I also wrote the same down here. So if a song is published, we'll want to show the songs in categories, for example, all hip hop songs or rock songs. So based on the prompt and lyrics, the large language model can generate tags for the song, which we can use to do exactly this. So let's talk about how we actually do this, so the flow of actually doing this. So first of all, we have the same case as we had up here. Whenever we have a cold serverless endpoint, so a serverless machine, a computer that has not yet been started because it is serverless, we'll then have to start up the machine and then load the AI models into memory. So this is going to be the exact same down here as it was up here, just with another model. So up here, whenever we make an inference request to the serverless endpoint, it'll have to start up the machine, figure out if the model is downloaded. So this is going to be the large language model. It will need to download the checkpoint, so the parameters. And if it was already downloaded, it'll just load it straight into memory such that we can use it down here. Good. So down here, we have the exact same setup. If we hit the serverless endpoint and it is cold, we'll just load the AI models into memory. Otherwise, we have these three options right here. And these three options correspond to the options I showed up in the start. So we have a simple mode where the user is able to just pass in a description and then the song is going to be generated from this description. So the user is just going to input a description of a song in this case. Then we'll take that description of a song, insert it into an existing template that says, hey, LLM, you'll need to generate some style tags for a song matching this description right now, and then give that comma separated list to me. So that is going to be the first prompt which we'll pass into the large language model. And then the second thing we'll do is we'll also need to generate the lyrics. So we'll again take the song description, insert it into a template where the template then describes, hey, you'll need to take this song description and then write some lyrics for that song. And then we'll actually prompt the LLM for those lyrics. And then if we have an instrumental song, so if the instrumental flag is set, we'll just skip this entire step to both save the actual step of generating lyrics and also because we don't really need the lyrics because it is instrumental anyways. What we can then do is we can take the output of these two LLM queries, or the two LLM outputs, and then we can use those as inputs for the music generation model, which is going to take a style of a song as the first parameter, and then also the lyrics for the song as the second parameter. So that is how we're going to use a large language model if we have the first option where you only pass in a simple description. The second option is that you pass in a simple description of the lyrics, but that you define the song style yourself. So the user is going to input the song style. This could be rock, for example, and then also hip hop, and then the model is going to try and create a song that is a mix of these two genres. So I'll just go back. And then the user is also going to input a description of the lyrics, and then the large language model is going to handle creating the actual lyrics. So the first thing we're going to do is just insert this song description of the lyrics into the same template as we used over here, and then prompt the large language model for the actual lyrics. And then if we have an instrumental flag set to true, we'll then skip this entire step. And then we can run inference with the music generation model, just like we did down here. Because now we have the two parameters which we'll need to actually run the inference. Next, if the user just wants to generate and also want to manually write the lyrics, we won't really need to use the large language model for anything. So in this case, the user is just going to input both the song style, so the comma separated tags, and also the manually written lyrics. And in this case, we actually have both things that we need to run inference down here. So we can just run inference with the music generation model directly without using the large language model at all. So as you can see, a large language model for this SaaS application is basically just a way to support the user in case the user do not want to actually find out all the different tags of a song, or if the user don't want to write all of the lyrics themselves. Because as you might consider, if the user had to always supply the written lyrics for a song, the user would have probably just gone to ChatGPT anyways and then got ChatGPT to write both maybe the song style but also the lyrics for the song before passing them into our SaaS anyways. So we might as well just help the user out a little bit and make the life simpler for the user, and then integrate a large language model directly into our backend such that this can be done automatically for the user. Then the last AI model which we're going to use for the project is going to be the music generation model itself. And the music generation model which we'll use is going to be called ACE-STEP. It is a pretty new music generation model where you're able to pass in some things such as the tags for the song and also the lyrics, and then it is going to generate a song from that. It is both transformer and diffusion based. It is actually called diffusion transformers, and we'll take a look at how the architecture works down here just briefly. But basically what it does is that it starts with noise, and then it gradually refines this noise into some music over a series of steps, and you then define how many steps you would like to go through or how clear the music should actually become. So down here we can take a look at briefly how the architecture works, just so you have a little bit of an understanding of how the model works without actually knowing how to build the model from scratch yourself. So this is a diagram from the paper over the model architecture from this ACE-STEP paper over here. And the first thing I would like you to notice is the inputs over here. So the inputs for the model is going to be a couple of things. We're going to have the tags, so that is going to be the style tags, the lyrics for the song, and then during training they also train on the isolated vocals from the song, and of course also the audio of generated songs, the audio of just normal songs, such that the model could learn how to generate songs from these inputs up here. So the first input that we're going to supply the model is going to be the style of the song. This is going to be a list of comma separated tags such as R&B, rock, pop, the beats per minute, or that the song should be joyful. And these tags right here are used to control the type of song that should be generated. So during training, the songs and samples were annotated with these tags such that the model could learn what, for example, a hip-hop song is. So whenever you trained this model on songs, then all the different hip-hop songs were annotated with maybe hip-hop and then a specific beat per minute. And this means that the model learns to associate hip-hop with a hip-hop song. The second thing the model was then also trained on as the input was the lyrics of the song. So whenever you give the model a song when training it, you also give it the lyrics of that song. So during training, songs were transcribed to get the lyrics, and then during inference, we can then tell the model what lyrics we want in the generated song such that the model can produce the singing. Because as you can probably imagine, if the model like this sees maybe 100,000 different songs, and then also the specific lyrics for each of those songs, we'll then be able to give the model the lyrics only, as well as the tags of course. And then the model can actually generate a song with those lyrics because it has seen so many different songs with their associated lyrics. Now the last input of the model was then also the vocals. So let's say you have a song, then you transcribe the song to get the lyrics of the song. You also describe the style of the song like this. And lastly, you can then also isolate the vocals from the song such that the beat and also the person singing are two separate tracks. So the researchers, by including also the isolated vocal tracks, could teach the model to separate the vocals from the full audio to actually teach the model that these are two separate things. And this allows the model to do pretty cool stuff now that you can also do. So for example, the model has other features such as editing lyrics, and this requires knowing how to separate vocals from the full audio, because you can't really just edit the vocals if they're just part of the full audio basically. Luckily, during inference, we don't really need to supply the vocals. We only need to supply the style of the song and then also the lyrics of the song, or a specific tag if we would like to make the song instrumental. The vocals and then also the song, as you see down here, are only things that were used for training. Cool, so let's talk about what happens to these inputs whenever they are passed into the model. So each of these different inputs go through something called encoders, as you see right here. So the tags goes through something called an MT5 encoder, the lyrics goes through something called a lyric encoder, and the vocals a singer encoder. So the first encoder we're going to talk about is going to be the one for the tags. So the one right here turns tags or text, so the text that you see right here, into numerical embeddings. And numerical embeddings are just vectors that capture meaning and relationships between data. So for example, the following list of tags right here could also be represented as a bunch or a list of numbers like this. So 0.2 minus 0.1, etc. blah, 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 blah. So all of these numbers could then represent the text up here. And the numbers could then also represent the text better than the text represents itself actually. And that is the power of these numerical embeddings. So first, in this encoder, the tags over here are then tokenized, so they are turned into small tokens, and then they are passed through a pre-trained transformer, meaning this MT5 transformer right here is a transformer that has been trained on a bunch of different text, and the transformer has then learned to capture things such as relationships between different words in the text, and this is then better than just inputting the text directly. So basically, this transformer down here captures semantic meaning. So this means that, for example, if you have a lot of different lines, you might try to express something that the model just don't see by itself if it just reads. But a transformer like this that has seen a bunch of other text before is able to read between the lines and then extract what you actually mean from the text that you input. So this is why I say that it captures semantic meaning better than just inputting the text directly. So it can read between the lines and also understand references better between different things in the text. So this basically just means that we extract as much meaning as we can from the different tags before we pass it into the the diffusion transformer down here. And because we extract as much meaning as possible from the tags, it'll increase the chance of the diffusion's output matching the text prompt intent, which is ultimately what we would like to do. And then also this MT5 transformer down here has seen a lot of different languages, so semantically identical sentences will produce embeddings that are similar in meaning. So if you say rock in English, for example, then it might produce an embedding that is similar to an embedding that was created if you say rock in Chinese, for example. So we're also able to support more languages. If we just took this MT5 encoder and removed it completely, so we just took the tags and then turned them into numbers, and then took these tags and put them directly into this transformer down here, what would happen is that the model down here would have to learn what is an R even, what is rock even, what is a word, and what is a sentence even if you input a sentence. Because this model just starts out with random parameters, so it doesn't really know anything. Then it has to learn what rock means, so what a word is. If you input a sentence, it'll have to learn what a sentence is, and also what a specific letter actually is. But because we use an encoder like this, the encoder is able to extract all of these different things. The encoder already knows what a word is, what a sentence is, and also what a letter is, because it has seen so much text already. It is pre-trained. And therefore, this linear diffusion transformer down here is going to have to learn way less than it would if we had not used this pre-trained transformer up here. So that is also one of the benefits of putting in an intermediate transformer between your input and then what you actually want to train down here. The next thing is then going to be the encoder over here. That is going to be a lyrics encoder. As you see, there are a couple of different symbols. There is a freezing symbol and then also a fire symbol. The ice symbol up here means that it is frozen, so it will not be trained, it is just going to be used. And the fire symbol means that during training of this entire model, this specific component of the model is then also trainable, so its parameters is going to be updated during the training cycles. So whenever you pass in the lyrics of a song, they pass through this lyrics encoder. So embeddings are generated from lyrics. So again, we have these numerical embeddings. Those are just lists of numbers, vectors basically. And that is what this lyric encoder does. Then non-Roman languages such as Chinese, Korean, where the letters look different than they do in Europe and the US, are then turned into phonemes. So phonemes is just a notation of how a sound actually sounds. And then this is then tokenized before ran through the actual encoder. And then if you have a Roman language such as English or French or Danish, for example, these languages are just tokenized raw. So this, I suppose, the researchers just did to be able to support multiple different languages. And then during training, as you see with the fire symbol, the parameters are optimized. So it'll learn to align lyrics with actual audio. So during training, this layer is going to see songs and also their lyrics, and then it'll learn to fit lyrics into songs. So this way, during inference, it'll be able to generate singing in songs just given the lyrics, and that is what we're going to use it for. The last encoder is going to take the vocals and then turn them into numerical embeddings. So this means that it'll take 10-second vocal segments and turn those into embeddings representing the speaker's vocal identity. This means how the speaker's voice actually sound. So my voice will produce a specific numerical embedding, and then your voice will produce another one. And what this means is that it can help enable features such as voice cloning. The researchers though has decided not to publish this singer encoder just to not allow people to clone musicians' voice, for example, and then just publish music under another person's name just by cloning their voice. And I totally understand why they probably did this. So this also means that we won't really be able to just do zero-shot voice cloning, but I just know that this is another encoder, and then you also now know what it does. Good. So these were the 3 inputs, and then there are also their corresponding encoders. Let's talk about another input that was used during training. So the 4th input during training was the actual audio. So whenever you train the model, you give it the actual song. You also give the vocals, lyrics, and the tags for that song. What then happens is that the model is able to learn the correlation between the actual song and then also the inputs up here. So the model actually works with compressed audio. So whenever you give it an audio file during training like this, it compresses the audio 8-fold, so it does 8x compression. So whenever you compress audio like this, the model will work quicker because it has to work with less data. So basically, a compressed latent representation is a compact, lower dimensional version of the audio, which is created by the encoder right here. It then captures key features such as the melody, rhythm, and also timbre. And because the model then only has to process 1/8 of the data, it'll then make a music processing and generation more efficient in the future. So the actual audio right here that was used during training is also ran through a separate encoder. That is what I'm trying to tell you. And then all of these different inputs are then passed through the actual linear diffusion transformer, which is what is trained to actually be able to generate songs during inference. So what we do whenever we train this model is that you train this specific linear diffusion transformer to synthesize audio from tags, lyrics, and also vocals. And then the actual inner workings of this diffusion transformer is way more complex than just the simple explanation of the encoders up here. As you can see over here, it contains more inner components. And there is a lot of research about why you should put these components in the order that they actually are. But this is the main part that is trained during the training of the actual model, and also what actually generates the songs whenever it is used during inference. So this was a very brief walkthrough of the actual architecture. I also have a little bit more explanation down here if you are more interested. So first of all, this diffusion transformer is both a stable diffusion model, but also a transformer at the same time. So it has a transformer backbone. And a backbone basically means that it is the main neural network architecture that is doing the heavy lifting. And because it is a transformer that is the backbone, as you can see over here, it is an attention-based architecture. So it has attention, as you see right there, and then also feed forward as you see with the blue box right here. And transformers specifically are great at capturing long-range dependencies, which I'll also go over down here. So this basically means that it can keep the entire existing songs in memory whenever it generates the next part of the song. So transformers is actually also what is used in ChatGPT, for example. So GPT stands for Generative Pre-trained Transformer. So whenever you use ChatGPT, it is able to look at your entire prompt that you just gave it and then predict the next tokens, aka the next words that comes after your prompt. But whenever we talk about music, it is then able to generate the next part of the song. So because it can handle these long-range dependencies, it is able to make music that is coherent over multiple minutes, because multiple minutes of data is a lot of data basically. So it means that the model is able to figure out what the chorus is, and then also that it should be generated after the verse and not just only verses or only choruses. And then without being able to actually handle these long-range dependencies, it might not have clear sections for the verse, chorus, build-up, drop, etc. It might just only do chorus or a mix of all of these at the same time, which would not at all sound like a song, but more like just a mix of random sounds basically. So where ChatGPT is able to predict the next word that comes after another sequence of words, so you give it a prompt and then it is able to predict the words coming after the prompt, aka answer your question. When we work with diffusion transformers like this, the model then starts with a bunch of noise over here, and then it wants to take this noise and then turn it into a useful MEL spectrogram, aka a representation of audio that actually matches what you asked for. And then at each different time step, the transformer then learns to predict or remove some of this noise to make it into some audio that we actually like to listen to. So we basically go from noisy random mil spectrograms that just contains a bunch of noise as you see right here, and then through a series of time steps, the transformer predicts what changes to make to this mil spectrogram to change it into something that we actually find useful. And then lastly, whenever we have a mil spectrogram that looks clean, it can then be converted into a VAV format, which is just a sound format which we can write to a file and then also listen to. So down here again, for each step, the transformer looks at the current state of the noisy latent mil spectrogram. So that is each one of these images. It is basically just a compressed mil spectrogram. It then also looks at the lyrics and the prompt, and then also the singer embedding. So the singer embedding up here. It'll then take a look at this, and then it'll use its self-attention mechanism to understand the entire structure of the spectrogram. And then it is going to use cross-attention to use these inputs to then turn it from the noise into what we asked for. So it is going to predict how each patch of the spectrogram should be changed or adjusted to make these patches less noisy and then more meaningful. So we turn it from noise to this. And then we take this prediction and then we slightly update the latent, aka this mil spectrogram, reducing the noise. And then we can't make too big of a changes every time, which is why we have this series of time steps, because we might overshoot, just like we would if we took just a normal neural network and then set the learning rate too high. And then whenever this entire process has been done, it just repeats itself for the next step until we come out with a clean mil spectrogram. So now that we know a little bit about how the model actually works, we don't know everything obviously, but this is just to give you an introduction to how these kinds of models work. We can hop into the next part over here. That is going to be the generation flow and also how the model works and what kind of components we use within our system. So basically what happens is that first the user inputs a prompt for generating a song. So this is just whenever the user fills out the input fields in the dashboard and then clicks create a new song. These inputs is then the lyrics and then the style of the song, or both, or a description of them if that is what the user wants to. Then whenever the user has inputted this, we then take the request that the user just made and add this to a queue, because we can't obviously process every single user's song generation request at exactly the same time. It is going to be added to a queue. Then when it is this user's turn to have his song created, a backend endpoint is going to be called with the generation parameters. These parameters are just the input prompts and that the user defined whenever he clicked create song. In this backend endpoint, we'll then generate both a song and also a thumbnail, and then we'll upload both to an S3 bucket on AWS. We'll then send a response back to the front end containing the S3 keys that we just created, the S3 keys to the items which we just uploaded to the S3 bucket. And this is where we can store the thumbnail and also the song, or at least the references to these in the database. And then we can say this user up here that clicked create now owns the following song and also the following thumbnail. The dashboard is then able to see these S3 keys in the database, and then we'll be able to display both the thumbnail and then also play the song whenever you click play. So this is the basic generation flow of how we create a song from whenever the user clicks generate to whenever the song is visible and playable in the dashboard. I've reached out to 3 different sponsors for this video, which are tools that I would basically just use myself just to create this flow and get the entire software as a service application up and running entirely for free. So as I told you before, we have a couple of different components that are required for the system. The first one is going to be the queue. For the queue, you can use something like AWS SQS if you would like to. It is very manually to set up though, so I just prefer to use a development tool such as Inngest. This is completely free to use until your application becomes pretty big. Then the next one is going to be the database. So you are going to need some kind of database to store each different user and also what thumbnail and S3 keys to the actual songs the user owns. So Neon is a great option for this because we can host multiple different free databases and get the entire application up and running completely for free. The next one is going to be serverless GPUs. So we aren't able to just run these AI models on Vercel or Next.js deployments. We're going to need some actual GPU power to be able to run all of these AI models. So what I'll use and what I usually just use is just Modal, because we can define our endpoints and then how these AI models should work whenever we call these endpoints. And then we just pick a GPU, which the AI models is going to run on. And then it is also serverless Modal, so this means you only pay for the actual seconds that you use of compute. And they also have a very generous free tier, such that you'll be able to run this entire SaaS for free, at least to get started and complete this video. So these are the 3 sponsors I reached out to for this video, just so you're aware that these are actually sponsors, although these are actually the companies that I would use myself if I were to just build the SaaS out myself and get it up and running as quick as possible. Cool, so let's talk a little bit more in depth about these different components from the system and how we can set them up and get the SaaS to work. So first of all, we'll use Inngest as the queue system. So I've before created SaaS products where I used AWS SQS for queues, but I really hated that, and that's why I found another company such as Inngest, because it's just much easier to work with. So basically what we'll do is we'll define a series of steps and then also a name for the queue. So we can then send events to this queue, and then each event is going to trigger these series of steps which we just defined. And as you can probably imagine, each one of these steps is just one part of generating an entire song. And what I mean by a step is that each step contains some code. So for example, this could be update some place in the database to say that this video is currently processing, or deduct some credits for a user, for example, or call the Modal backend. These are all different steps that contain some code. And if each one of these steps fail, they are just automatically independently retried. So for example, if we try to call the Modal backend and that step fails, it'll just retry that step without affecting any of the other code or steps. So this is a pretty cool benefit as well. Then also one thing that we definitely need is being able to offload the long fetch requests to the Modal hardware. That is a pretty neat feature that that Inngest actually recently built. So we're able to offload these long fetch requests to the Modal, and it's actually endpoint like this. And the reason we would like to do this is because it will reduce the serverless function usage and avoid timeouts. So up here, we have 2 different applications. We have our Next.js application. That is where the user can input his prompt for generating a song. And this is also where we define the different steps for our queue. That is the first part. And then we also have the Modal backend. So when the user clicks create and this is added to the queue, the Next.js application is then going to call the Modal backend. And because we run some AI inference, it might take maybe a minute, maybe half a minute or so before this request is finished and then returns a response back. And this Next.js application will just be stuck over here waiting for this Modal backend AI inference to finish before it can then update the database. So to not just keep the entire Next.js application stale and just waiting for nothing basically, what we'll do is we'll take all this waiting time and then offload this over to the Inngest hardware. And this way we won't have to let the Next.js application wait unnecessarily. This both avoids timeouts because there is a set limit for how long these serverless functions can run in Next.js applications. I think it's a half a minute or something, maybe a minute on the free tier, and then you can get up to maybe 5 minutes if you pay for Next.js Pro Enterprise. But this still isn't a lot if you have an inference endpoint or an AI model that just runs for a long time, because some of these AI models actually do. So this is super neat and something we're definitely going to need for this application. So let's talk a little bit more about how we can structure this queue system and how the application works. So first of all, the user clicks generate, and then whenever the user clicks generate, an event is inserted into the queue, and the queue is what I've marked by this blue line of 9 different events right here. And then each one of these events are inserted whenever a user clicks generate, will contain the prompt. So this could be pop and R&B if the user wants a song like that, and then also some lyrics. So in this case, the user has inputted some lyrics manually, and then the instrumental flag is set to false. So now we have a queue that says, okay, for the next song we're going to generate a song with these parameters right here, and then attach that song to the user, meaning the user owns this song. So basically, each one of these is just a single request for generating a song made by some user within our system. And then we can set up some parameters for deciding how many of these events can be handled at the same time. For example, if you didn't have a queue, you would have to support maybe 1,000 different users clicking generate at the same time, but maybe that is not feasible for a system. So that is why we have a queue. It also allows us to do things such as throttling. So maybe we can only let the user have a single video generated at the same time, or maybe we can only let 10 users generate a video at the same time. These are different options which we can set up when we have a structure such as a queue, which makes our system more scalable because we can handle more users at the same time. So whenever we set these different rules up, the queue will know how to dispatch these events. So let's just say that this event, the last event over here, is consumed. Whenever it is consumed, it is going to trigger a ingest function in the Next.js backend, and this is what contains a bunch of steps like I explained before. So steps could, for example, be calling the backend, the Modal backend over here, also deducting credits from the user, or setting the song status to processed. And then this calling of the backend step, that is the error you see right here, is what might take a while because we're doing AI inference over here. And then this ingest function will then wait for this entire thing to finish before it returns a response. So this error right here marks ingest function calls Modal backend that hosts the AI model. Then the Modal backend will render the song, or generate the song is probably a more appropriate word, and then upload that song and also the thumbnail to an S3 bucket. Then this Modal backend is going to return the S3 keys, that is the location in the buckets where the song and also the thumbnail is stored. And the reason that they are returned is such that they can be stored in the database over here. And then whenever this event right here has been consumed, then there is space for the next event to be consumed depending on how we have set up the rule for the queue. And then specifically for our use case, what I'm going to do is limiting the concurrency to 1, meaning 1 event can be processed at a time per user. So 10 users, for example, will be able to have a song generated at the same time. But if a user clicks generate 5 times super quickly in a row, then only one of these videos will be generated at a time, just to keep the system from being completely spammed with all the different users' requests. So this is the queue which we're going to use to separate the requests from the actual processing of the videos. The next thing which we're going to talk about is the serverless backend over here. So what we'll do is we'll use Modal to run these AI models. So as I explained before, we can't just use Vercel for running these AI models, because even though we use Vercel to host the application, the Vercel runtime don't really have any GPUs available. It also runs Node.js, meaning Typescript or JavaScript. And since a lot of these AI models run with Python, it's not very optimal to do anything AI related with Typescript or JavaScript usually. And if we decided to do anything long running, we might also hit this point of the serverless function timeout. So if a AI inference, for example, takes more than 30 seconds, I think it is, then the serverless endpoint might just time out, and then we won't get any response. So when we use a cloud service such as Modal, it just allows us to create serverless endpoints in Python. And luckily with Modal, we can pick the GPU ourselves, which is pretty cool. And then they have a very nice free tier for GPU usage. I think it's $30 a month that you can just use to just test out the platform and run run application that uses GPUs. And then you only pay per second of the program running after that. Also, a super nice feature that I use because I have a Mac, so I don't have a GPU available on my computer, is that I don't really need a GPU on my local machine anymore to develop AI programs, because I don't need to test them locally. I can just test them super quickly on the Modal platform, and I'll show you exactly how whenever we develop the application. Also, for the SaaS applications that I've previously built, I've always used serverless for almost everything, and it's really nice for startups because since you don't pay for a machine running all the time, you can save quite a lot of money. And that's just because you pay per second of the program running instead of just a machine running at all times. This also means that scaling is handled by the serverless platform such as Modal. So instead of you having to start up a new instance on EC2, if you get a lot of users, for example, Modal is just going to handle and manage all scaling for you, because that is built in whenever you use serverless solutions. So let's just talk about how it works whenever we develop our program. So what we'll do is we'll code our program, the backend, and then we'll run this command Modal run. This will push the code directly to Modal. And then up here in the Modal cloud, Modal is automatically going to build the Docker image and then run the Docker image with the GPU which we specified. Then it is going to take this output, return it back to our terminal so we can see the execution output of the program. So as you can probably also imagine, no code is really executed on our local machine, only the code that pushes the code to Modal up here. And that is really what I mean when I say that we don't need a GPU on a local machine to develop AI programs, because everything just runs in the cloud from the start. And then because we know that the program works fine up here, we can also just run the command Modal deploy. That is going to just deploy the endpoint which we just built and tested over here. So the deployment is super easy as well. Cool. So this is the alternative that I started using instead of just using EC2 instances, both because they are super annoying to work with, but also because they cost a lot of money. And if I used EC2 instances, you probably wouldn't be able to follow along, because then all of these services would all of a sudden start costing money. Now, for the next component of the system I would like to talk about, I'm going to talk a little bit about the database. So I'm going to use Neon for the database in this project. One of the reasons I wanted to work with Neon is because they have a free plan that allows you to just deploy and host the entire SaaS completely for free. This means you can just deploy the entire application without spending your money until you actually grow. And one of the features that we're going to use in this video is that we're going to actually have a development database that we can use from the start whenever we develop the application, instead of having to rely on SQLite, for example. So we can use a feature called branching. So we'll create 2 different branches, one for development and then one for production. And then the development branch is just going to be a complete copy of the production database that we can do any modifications to over here without affecting the production database at all. So we're able to just build for Postgres straight away, and then we don't really have to use SQLite like I've done in some of my other videos, just to change this out for Postgres whenever we actually want to deploy it. So what we'll do over here is that we'll have a development flow that looks like this. We'll have a production database, and then whenever we start developing, we'll make a copy of the production database called the development database. And then whenever we run the code locally, we'll just have our Next.js server connecting to this development database over here. And then everything that happens in our Next.js application, so if we create a video, for example, or create a user, that is going to be happening in the development database. But then whenever we deploy our application, it is going to run on Vercel over here. And Vercel is set up such that it interacts with the production database. So we'll basically have 2 completely separate environments, which is very good practice because these shouldn't really have anything to do with each other. Cool, so before we actually start coding, I just want to talk about one more thing over here. So if you hop over to this section, Auth and payments, in this project I'll try something called BetterAuth. So I've looked into this solution a little bit lately, and what it does is that basically it simplifies authentication a bit compared to Next.auth, which I have previously used. And also it integrates very well into our stack, Next.js and Prisma. And then also I found that if I use BetterAuth, there is a library called BetterAuth UI that can be used to just basically replace all Auth UI, which we would otherwise manually have to create. So BetterAuth UI just provides a bunch of React components for login cards, for example, sign out things, or even React components for managing the user profile. And usually I just write out these things myself, such as the login page, for example, but I think it is a much cleaner approach just to use something like BetterAuth UI if I'm able to, just because it simplifies my code a lot. So those are the 2 reasons basically which I'll use to justify going with BetterAuth for this following project. And then also I'll try another payment service. I'll use Polar for this video, and the reason is that Polar supports BetterAuth very well. So they recently just made an integration between Polar and BetterAuth, meaning that if you set up BetterAuth, you're able to just set up payments very quickly, just because Polar and BetterAuth integrate so well with each other. So basically, whereas we before had to keep track of things such as creating Stripe customers in our own database, creating Stripe customers in the Stripe database whenever we create a customer in our own database as well. This is basically handled automatically by the BetterAuth and Polar integration. And then also we don't need to manually store Stripe customer IDs in our database. That is also handled automatically by this following integration. So all this boilerplate code, which we usually had to do all the time, can be saved. And that just improves the development experience a lot, I found. So that is why we'll test out Polar and also BetterAuth for the following video. Also, I also found that Polar is available in countries that Stripe is not, India for example, so that might help even more people follow along with this video. One thing I found though is that Polar is less mature compared to Stripe. There's less documentation and also less help to get out of the internet, but generally it is simple to work with for the kind of payments which we'll set up for this video, so it should be completely fine. I also wrote down here that whenever you use Stripe and Next.auth, you have to integrate everything manually because these are 2 completely different things. So this integration part right here is then what is partly abstracted away because of the Polar BetterAuth integration. So I'm pretty excited to try this out. Also, it's usually just better to keep things simple in my code base, or at least I found that, just because whenever you go back to the code base, it can really be a lot if you have a bunch of different code you have to look at. So just keeping things simple is usually just a pretty good thing. Now that we have covered the theory, I'll open up Visual Studio Code and get started with the code. I have opened up Visual Studio Code, and that is the code editor which we'll use for this project. Before we start doing anything, what I'll just do is hop into my extensions just so you can see whatever I have. So down here for Python I have AutoPep 8. Let me just scroll down. I also have iSorts, Pylance, Python and Python Debugger and TensorBoard. So these are just the ones I work with. You don't necessarily have to install them all. Maybe Python. It is just if anything looks different in my UI compared to yours, maybe this is why. Okay, so the first thing I would like to do is create a new folder where we can start our project. So I'll say open folder, then hop under my documents, YouTube, and then in here I'll create a new folder called music generator and create this. In here I'll just open it up, and then I would like to say Backend, as a new folder, Backend like this. Inside Backend I'll just create a main.py, and I'll just create a requirements.txt as well, just for installing Python requirements. What I'll then do is just hop into File and then open folder, and then I'll just hop into the Backend folder and open this up just so it is roots. Then what we can do is we can click Command Shift P and then say create environment. We can pick venv and we can select our Python version. I'll select 3.12 for this and just press OK. If you do not have Python, I would advise you to hop into the Python website like this, then hop under downloads. I think I'll just do this, and then see if I can find a specific version. So going down, you should be able to find a Python version 3.12. So right here, and then just go ahead and download that specific release to your machine. I usually don't use the newest Python version, like this one for example, whenever I work with AI, because sometimes the AI packages need a little bit of time just to catch up with the newest Python versions. So what I usually do is pick 3.12 or 3.11 like this. Good. So with that out of the way, we should be able to hop back in here and then see that the following environment has been selected, like this. If I then open up a new integrated terminal and then search for Python, or just put in Python, we can see that Python 3.12 have been initiated, so that works perfectly fine. What I'll then just do is allow us to be able to execute code whenever we develop. So I'll just set up Modal quickly. So I'll go into serverless backend right here. So Modal is what we use whenever we want to run our programs with the AI models. So we can say Modal run in the terminal. So we'll just hop into Modal documentation like this, and then go to reference. I think it's guide, Then we would like to say pip install Modal first of all, like that. And then while that is installing, we can hop back and we see we can find Modal setup as well. Then we'll just do that. And then it should give us a link. So if I take this right here, then hop over here and then paste it in. And then I can say continue with GitHub, or at least that is what I usually do. Then I'll just go ahead and log in quickly. So now I'm logged in and I'll just press authorize. And then hopping back into the terminal here, we should be able to see that it authorized and then it created a token in the following path right there. So what this does is that it basically just connects our local terminal to our profile here in the Modal dashboard, such that anything we run actually runs on our account, which we created here on Modal just now. If I then say Modal right here in the terminal, we should be able to see that it works just fine and we can run things on Modal if we would like to. So basically what we can do with Modal is that we can define a program inside main.py right here. Then we can say Modal run main.py, and then the program is going to run in the cloud instead of on our local machine, as I explained in the theory. So if I just search for Modal pricing, we'll just see the GPUs available. So over here we can see the GPUs available for the program to run on. So whenever we say Modal run main.py, instead of it running on a local computer with no GPU in my case, I can say that it has to run on a computer with an L4DS GPU available. So I can basically test out AI models without having one available on my computer. And that is why I like it so much. Good. So now let's hop back and start developing our program. First, I'll create a new Modal app. So I'll just close this down and then I'll say app is equal to Modal. And we'll just need to import Modal. So we'll just go ahead and do this and then say import Modal. So we'll say app is equal to modal.app and we'll call this music generator like that. And what this will do is that it is going to create a new app in here in the dashboard whenever we run the program. And then we can define the actual Docker image or the contents of this app basically. So I'll say image is equal to, I'll open up a new parentheses and then I'll say modal.image and we can say Debian Slim like this. And behind the scenes, I quickly just restarted my Visual Studio Code just because, as you saw, it was white right here and right here before. So we didn't really get any types or class inference, which is very important whenever you code. So I just restarted Visual Studio Code and that fixed that problem. So first of all, modal.image.debian slim. If you know anything about Docker images, you might recognize this. Otherwise, a Docker image is just a lightweight standalone package that really contains everything you need to run an application. So that is both the code, which will define this file, but also the runtime, libraries, and dependencies. So this right here is the operating system of the Docker image, but we'll also define dependencies for this operating system and also dependencies for the specific code. So Modal, which we're going to use, just uses a Docker-like image to define the environment for our functions. So we're able to install requirements from the requirements.txt, for example, and also requirements to our system by saying apt install if we would like to. And then each one of the Modal functions that are going to run will run in a Docker container created from the specific image which we define right here. So after picking the operating system, we can go ahead and say .apt install, and we would like to install Git into the operating system. After installing the system dependencies, we can go ahead and install the Python dependencies from requirements.txt. So we can say pip install from requirements and then pass in requirements.txt, so the path to the requirements.txt folder, which is just in the root. Then we can say .run commands to actually run some commands within the system. And then if I hop into here and then search for ace step, this is the model which we're going to use. So remember from the Excalibur, I talked about the specific model which we'll use down here. That is going to be a step. So that is the GitHub repository of that model. Let me just zoom in a little bit. So this is just a music generation model where you can pass in a couple of properties and then it'll generate a song for you. There is a bunch of text here about its features, etc. But what we'll basically do is we'll clone down the repository like this. So we have the code and then we can run the code from our Docker container. So first I'll just copy this right here. And then inside run commands, I'll paste this in. Then I'll say git clone and then the entire ace-step repository. And we would like to clone it to TMP, so temporary ace step like this. So we'll clone the repository down to our local machine. So the the container inside this folder. After this, I would like to run another command. So the way we can do this is we can take these commands and then pass them into an array like this. Then I would like to say change directory. So we'll then hop into TMP ace step. So we'll jump right into the directory which we just cloned this GitHub repository into. After doing this change of directory, we'll say pip install dot. So we'll take the requirements.txt file that is inside the existing repository. So if you just hop back in here, scroll up, we should see a requirements.txt right there. So we'll need to install all of these, and as you see, there is a bunch of requirements with different versions. So we'll just let ace-step handle all of these requirements, and we'll just install the requirements.txt file for it to work. So that is what we do with this command right here. We say pip install at the current directory. Cool. So that is the command we're going to run to clone down the code. We'll need to run this music generation model. Good. After this, I would like to run a couple of more things. I would like to set an environment variable. This environment variable should be called hf home, the Hugging Face home. So this is the environment variable that will set the cache directory for the Hugging Face models and datasets which we'll use. So we're going to use some models through Hugging Face, and then these model files are going to be cached to this specific directory right here. And we'll then also attach a modal volume to those directories. So we'll say /cache/Hugging Face. So this right here is a specific directory inside our container. This is where Hugging Face is going to cache everything. So basically whenever we use a model for the first time, it is going to download a model checkpoint, which it needs to run the actual model. And then because we don't want to download this model checkpoint every time an inference endpoint in this main.py is hit, it is cached inside this directory right here. And then what we can do is we can attach a volume from Modal. And the volume is basically an external file system which you attach to the running container, just such that it is able to store things not inside the container, but in an outside place that we can then attach to multiple different functions. This means that whenever we download the model files, it'll be available in all future function runs, so we don't need to download it every single time. So that is why we define this right here, because that is where we're going to mount an external volume to. Then I would like to do one more thing. I'll just create a new file. I'll call this prompts.py. In here, we'll define some of the templates which we'll use to run through the large language model. And because there is going to be a lot of text in some of these prompts, instead of having all that text lying around inside this main.py function, main.py file, I'll just define a specific file for that, just so we can have all the text for the prompts in here. So the way we can import a external file like this is just by saying .add and then local Python source like this, and then we'll just put in prompts, and then this will make sure the modal image is then going to make sure that prompts.py is included into the image whenever we spin up a container of the type of this image. Cool. So now that we have defined the basic image, we can go ahead and define the volumes. And as I explained before, a volume is an external file system which you can attach to your running container, such that you're able to download things down to that, or also access data from an external volume. This means that you can share downloaded model checkpoints if you would like to between different containers, so you don't have to download them to every single container. So going up under storage right here, you should be able to see the different kinds of storage options you have available with Modal. And then if you hop on the volumes, you should be able to see that you can store files that are read more than they're written, like model weights and database dumps. And we'll basically just store model weights in this volume, so that is exactly what we'll use it for. Cool. So now let's go ahead and define these actual volumes. So first I would like to define a volume for the checkpoint for this A-step model file. So I'll say model volume is equal to modal.volume.fromName, and then this one should be called A's step models. And if it is not there, because currently we didn't really create any volumes over here, we only just looked at them and there's no volume basically. So we'll create one if it is not there. So I'll say create if missing, set that to true. So that is the first one. The second one is going to be another one called the Quen Hugging Face Cache. So this is the volume which we'll use to store the large language model. So we'll say Hugging Face volume like that, and that should be good enough for the two volumes. Lastly, we can just go ahead and create a secrets in here. So I'll say create new secrets, and I'll just call this AWS secrets, or maybe just music gen secrets like that. And then we'll just put in one called test and test right here. So these are basically environment variables that are injected into the container whenever we run it in runtime. So we can just go ahead and copy this name, click done. And then whenever this is done, we should be able to access it over here in the code. Cool. So now we can see that we can say modal.secret.fromName, and then we can define the one we would like to import, and that is then injected into the code such that we're able to access it like this. So that is exactly what we would like to. This means that instead of just hard coding AWS secrets, for example, inside our code, we can just define them inside the secrets, making them unavailable to read, but available to actually access through this os.environment variable. Cool. So now we can go ahead and say AWS secrets, or we can say music gen secrets is equal to modal.secret like that .from name, and we can pass in the actual name like this. Then just to test things out, I would like to define a function. So I'll just say define function test, and then I'll just say print hello. And I would like to also just print, if we import OS up here, I would like to also just print out our test environment variable. So I'll say prints, and then it was os.environ like this. And then we can put in the key we would like to index. So that is going to be test. And then we need to make this a modal.function like that, where we just, I think it's like this actually. And then it's not modal, it is app. Cool. And then we just need to inject our secrets right here. So just going back to our secrets, we should be able to see how to use it. So we'll just take this line and copy it in. And then we can make a local entry point that actually runs this code. So to do this, we'll just say define main, and then we'll say function tests dot, and we can then say local to run it locally, or we can say dot remote to run it on the cloud. So if we say local and then say modal run main.py, then this code is going to, this code right here is going to run on a local machine. And that is not what we're interested in, because this right here is not available on a local machine even. We would like to run it in the cloud just to test that we have a connection open to Modal. So now we just say .remote. And lastly, we just need to say app.local entry point. And if we then run this code, this should be enough to run this and just see hello and also test print it out in the terminal. One thing you need to notice though is that whenever we run this for the first time, it is going to need to build this entire image, meaning it'll need to set up the operating system, install Git, hop into requirements.txt and install everything we might need in here. It'll also clone this down and say pip install inside of this one as well. It'll also add this prompts.py. So all of these things will take a little bit of time, but luckily we only need to wait for all of these things to execute the first time we run it, because all of this is cached inside the Modal Cloud platform. So unless you actually go in and change any of these lines or hop into requirements.txt and change the contents of that, all of this is going to be cached. So it might take 5 minutes first time we run it, but afterwards it should start up instantly. Cool, so now we can go ahead and test it out. I'll open it up in my integrated terminal and then say Modal run main.py. And then if we hop over here, we should be able to hop on the apps and then see something spin up as well. So we see this function test, and then back over here, we can see that it actually executes straight away without doing any of this up here. And the reason is I just forgot to put in image is equal to image right here. So unless you put in image is equal to image, or at least the image name you defined up here, it won't run with this as the base image. So for example, in here, we clone this down and make a step available. So this means that you'll need to actually define the image right here to have a step available, because otherwise there's no connection between the image and the actual function you run. Anyways, what you see down here is you see some blue text, and the blue text is what is running in the cloud. So even though this prints out in your local terminal, it isn't actually running on your computer, which is pretty cool. We also are able to see the value of the environment variable, which we created in the dashboard test. So that also seems to work just fine. So now that I've defined image is equal to image, let's just try and run it again. So I'll say modal run main.py, and then we'll just let this run. So we can see that it says from base, copy, and then it starts doing all of this, which is basically just building an image from scratch. So in a couple of minutes when this is done, I'll just come back and then we can see what happened. So a couple of minutes later, it ran through all of these different steps, which is basically just setting up the entire, or building the entire Docker image. And then whenever we run this again, it'll run the Docker image as a container. So what we'll do is, if we say modal run main.py, all of these steps should be cached. So it should just print out hello and test quickly after starting it, like I did right there. So the caching seems to be working just fine as well. The cool thing is that now we can define code in here, which will then run in the cloud. And then whenever we run it with modal run main.py, we can run it in the cloud. And then the cool thing is that if we put in GPU and then say H100, for example, then this code right here, if I just do this, is going to run on an H100 and have that available, which is pretty cool. So I'll just wait for this to finish, and it finished right there. So this code, even though it is very unnecessary, actually ran on an H100, meaning that we could, in theory, just put in an AI model right here and just run inference with that, and then the H100 GPU would be available for it to use. We can now get started with the actual code. So what I'll do is I'll just take this and remove it, and then say class music gen server. And then I'll put in first a def load model, and I'll say self, and I'll just say pass in here for now. And then over this, we are going to put in a decorator app.cls for class. Then we can specify the image is equal to image to use the defined base image up here that we just defined. And then under this, I would like to put in a GPU. For GPU, I would like to use the L40S. So hopping in here, searching for modal pricing, we can see the different GPUs. So the L40S is about $2 per hour of usage. And then because you have $30 per month of free credits, you should be able to use it for about 15 hours per month, which is quite a lot of runtime. You definitely won't run out of time just by playing around with it. Cool. Next, we can attach our two volumes up here to the specific paths as well. So first I would like to say volumes, then we can pass in a dictionary like this, and then first we specify the path we would like to attach a volume to. So I would like to say models, and models right here is the path which will make sure that the ACE step model downloads its checkpoints to. Then I'll say model volume. So we'll attach this volume right here called ACE step models to the following path. Then we can also define the /.cache /Hugging Face. So if I just do a search and replace here, we can see that it is the same as the Hugging Face home. And that is because we would like to store our Hugging Face models, or at least Hugging Face caches, in this place right here. And this should then point to Hugging Face volume, meaning everything that we put inside this folder will then also be duplicated into the volume right here. And this means that whenever we attach a volume to another running container, all of these cached items are then available again. So next we'll just put in the secrets. We'll just put in an array and then just pass this in. We can then also just define something called a scale down window. So remember that this is serverless, and then whenever you start up a new container, whenever you receive a request basically, then this load model function is going to be ran. And this load function model is going to take all the different model files from the volumes, or model checkpoints, and then load them into the GPU memory. And this operation of loading into the GPU memory might take a while. So if you receive two requests right after each other, I would like to avoid having to do this and just let the entire container stay warm for a little bit longer. So what I'll do is I'll define this scale down window of 15 seconds. This means that whenever we receive a request and the models are loaded into memory, even though the request then finishes, it'll stay warm for 15 seconds more, meaning that if we receive another request within those 15 seconds, the models are still going to be loaded into the GPU memory, instead of us having to wait maybe 20 seconds for all of this to happen once again. The obvious benefit is that you keep the container warm, so users will have to wait wait shorter. This means that there is no cold start. And the drawback of doing this is that you'll pay for 15 seconds of usage more, even though you might not use it. So this is kind of a way off that you'll need to do, whether you want this or not. I just like to do it because in production, you'll probably receive a lot of requests at the same time or right after each other. So it's quite nice to have a container with a scale down window that just stays active like this one just for a little bit. And then as I explained, this function right here inside the class is going to load the models into memory whenever we receive a request in our program. So I would like to just put in a decorator. I'll say modal.enter. Like this. And this lets Modal know that whenever we define an endpoint inside this music gen server, before that endpoint is executed, it will need to run this function if it is a cold start. So the first thing I would like to do is just load the A step model and then make sure that that is being loaded into memory. So I can say from, and then I can say ace, and then step dot pipeline dot ace step like this. So what we can do is just to check out the files is that we can run this exact command right here. I'll just do git clone. And then we should be able to see a step in our local directory as well. So now we can see a step. So we can see a step right here, and then dot, and then we see pipeline.astep.py. And then we should be able to find the class ace step pipeline right here. And inside this class, we are able to actually create the pipeline for running inference with the model. So because we are not able to import it directly from the root in our local system, but that we are able to do that because of the way we clone it down here in the Docker image, we'll need to see this yellow squiggly line, but it doesn't really matter because it is going to work whenever we do deploy it. So just don't really worry about this yellow squiggly line. It doesn't really matter. We'll just say from astep.pipeline.astep. I think this is an underline. I would like to import the ace step pipeline. So if I just do a full search like this, we're able to see that that is what they do in their official examples as well. They say from astep.pipeline astep import this pipeline. So that is exactly why we do it as well. Cool. So now we are able to load in this class, import this class. And then what we can do is we can say self.music model is equal to ace step pipeline. So we'll instantiate a new class, a new instance of this. Then we can say checkpoint directory that is going to be equal to models, because that is where we would like to store the checkpoint of the downloaded model weights for this 8-step pipeline. And it's going to download these weights automatically the first time we run it, by the way. And then for the rest of the things we need, the rest of the parameters, what I'll do is I'll just do a shift command F and then search for this right here. And then I'll find an example of where it was used. So GUI.py. And then in here, I can just copy all of these different properties or parameters we pass into the constructor. And then we just paste those right in. And then for the BF16 here, we'll go ahead and remove this. And we'll use this following format right here, data type, if CUDA is available. And because we always have a GPU available, CUDA is always going to be available. So just leave this right here. And then we can go ahead and set these to false. Right there, and right there. And then this should be enough to load the model into memory. So this basically just creates an instance variable. So whenever we create a class on here, let's just say def, and don't do this. This is just me playing around. Def and then test endpoint, and then we pass in self. That is what it's going to look like basically. So this is going to run on cold start, and then because we have set this instance variable down here in every endpoint, which will create within this class, we'll be able to say self.music model, and then we'll be able to run inference with this model that we defined up here. So that is the basic idea of this. So first of all, we define our music gen model. I'll just do this. So music generation model like this. And next I would like to just define the large language model too. And this is going to be the Qwen model. So first I'll just specify the model ID. And I would like to use the following one right here. Qwen to 7 billion parameters from Hugging Face. And we'll use this instruct version. If I just zoom in right here. So basically we'll just use kind of the same method as they do right here. So I'll take this, paste it in. Then I'll take the auto tokenizer from pre-trained, paste it in right below. And we'll just need to import this auto tokenizer and probably also install the library it comes from. So that is transformers. Like this. And then whenever we install a library down here, we just gotta put it into requirements as well. So I'll say transformers. And then we can now say from transformers import, and we'll need both auto model for casual LM, and we'll need auto tokenizer like this. And I actually think it's causal and not casual like this. So first we define the tokenizer. So this will be self.tokenizer for the large language model. And next we need to define the actual model. That is going to be like this. So right below I'll say self dot large language model like that. And then I'll just take this model ID and just paste it in right here. And then also for this, set the cache directory. And the cache directory is going to be the one we defined up here. Just to make sure that the cache is whatever it downloads of checkpoints, for example. And this right here should then be enough to be able to use the large language model in future endpoints, which we'll define inside this class. Next, we only need to define the last AI model, and that is going to be the stable diffusion model. So I'll say stable diffusion model. So this is just going to be the one for thumbnails. And then what I would like to do here is use one called stabilityai. So I'll search for stabilityai, and then stable diffusion XL-turbo. So the one right here. So these are the kind of images we can expect whenever we use this model. And then going down, I think they have a usage section. So we can take this right there, and then we can copy it in. So we can say auto pipeline for text to image, and we'll just need to import this as well. So let me just check out where it came from. If I hop back in here, we can see that it comes from diffusers. So we can take this, paste it in under our imports up here. Then we'll just say pip install diffusers, and I think we also need Torch if I saw correctly. Yeah, so we also need to install PyTorch. So we'll do the exact same thing here. Diffusers and Torch, like this. Then we'll just say pip install Torch, and then we should be all good for this next one as well. Let me just see if we spell that correctly. Diffusers. Yeah, good. So going down here, I just want to change a simple thing, and that is the cache directory. So I'll just want to make sure that the checkpoint for the stable diffusion model, whenever it downloads that, is also put into this cache directory, just so it is stored inside the volume, which we defined up here. Good. So what this does right here is that first time we hit a container and the container is cold, or sorry, the serverless function is cold, then it is going to start up the serverless function and call this load model. It is first going to load in the music generation model, so it'll download down the checkpoint to the models file. So that is the trained model that the researchers trained and then upload it to Hugging Face. So it'll download that into this checkpoint directory, and then it'll load it into a GPU memory. Next, it'll do the exact same thing just for the Quinn down here, or sorry, the large language model. So it'll download down the large language model into the cache directory, and then for the stable diffusion model down here, it is going to do the exact same. So I'll just say self.image pipeline, and I'll say self.image pipeline 2, and then CUDA, just to move it to the GPU. So these are again the free AI models which we'll work with later on in the code. We can then just try and create an endpoint to test it out. So what I'll do is I'll hop down here, and then I would like to say def generate, and then I'll pass in self for now and just say pass. And then up here I can say modal.fastAPI endpoint, and then we can say that the method is post, like this. So to get started with this, first I would like to just create or generate a unique path basically inside this container which we're running temporary directory. So first I'll say output directory. So whenever we use this model over here, as I explained earlier, it is going to create a file, or at least generate some audio, which we'll need to save in a file to the disk before we can upload it to S3, for example, or send it back to our local entry point to test it out. So I'll just define a directory which we can use to save the actual audio file to that it generates. And I'll save this under TMP, so temporary, and then outputs. Outputs like this. Then we can say os.mkdir, so make directory, and I would like to make this output directory, and I'll say exists. Okay. I think it's exist okay equal to true, like that. So what this does right here is that essentially it just creates this directory or this folder right here, make sure that it is created. If it is already there, it'll just do nothing. Then we'll say output path is equal to os.path.join, and I would like to join together the output directory like this, and then a specific file name, so just a random UUID string .vav. So I'll take this, and then what I basically do is I say / and then put in some random numbers like this .vav, and by putting in these random numbers, I make sure that none of these files are going to conflict with any other files that would ever be there basically. So that is basically how we're going to name the actual file. So I'll go ahead and say UUID, and we'll just need to import this UUID packages. So I'll say add import .uuid4, like this, and that is going to generate a random name for it. And the contents of this output path is therefore going to be a string containing the full path name, which we can save this file to, that is being generated by the music model. So down below we can say self.musicModel, and I would like to say prompt is equal to, and the prompt should be something like hip hop, and then I think I'll say rap, I think I'll say New York, and then I'll say joyful, and I think I'll say 120 BPM, just something like that. Then we'll say lyrics is equal to, and we can say instrumental, because right now I don't really want to make any lyrics. So first of all, if we hop over to this A step, what you can do is you can hop under examples and then find this run right here, input parameters. Then you can see different input parameters that people use to try and test out the model. So you can see the different input parameters. We have prompt, lyrics, audio duration, in first step, and guidance scale. Those are the most important ones which we'll use. So I can actually just take this and copy it. I'll just take electronic rap. And then I'll just take all of these lyrics right here as well. Paste them in. Then what I can do is I can hop down and then just put in the audio duration over here. So I'll just take the audio duration and then set that to 2 minutes. That's going to be 60 seconds. I think I'll just set it to 3 minutes just to make sure we get something that sounds decent. Then we can also put in the in first step like this. And I'll just set the in first step to, I think it was 60, right? Yeah, 60. And we can also take the guidance scale, set that to 15, like that. And we can then also set a safe path. This safe path is just going to be the output path up here, like this. We can then take this file that it generates and then read that from the disk. So I'll say with open, and I would like to open the output path as RB. So this will open it in read binary mode, meaning it is going to read the file in binary. We'll then say as file. We can then say audio bytes is equal to file.read, like this. Lastly, we can encode the audio that we just read to base 64, such that we can return it back to where we call it from. We're going to call it from this one. So I would like to say audio, and then something like base 64 is equal to base 64, which we'll just import, dot, and then B64 encode. And I would like to encode the audio bytes, and we can then say decode to UTF-8 such that we're able to send it through the request or the response of the request back to where we call it from. Lastly, we can just go ahead and say os.remove, and then we'll delete this actual file. So we write the file, the file is being written automatically after the model generates it. Then we read the file into memory, then we remove the file, and then we're able to return the actual file just encoded back to where we called the endpoint from, and then write it to the disk. Because remember, if we call it from right here, that is on our local computer, but everything that happens right here is in the cloud. So whenever we call it right here, we expect something returned back, which we can then write to our local disk if we would like to. So I'll just quickly hop up and define a class for this. I'll hop up right here and then say class generate music response, and then I'll just pass in a base model, and then this will just need to go ahead and define. So we can go ahead and say pip install Pedantic, and Pedantic is just a way of doing schema validation and creating different types that we can send back and forth. So I'll just need to hop into requirements, I think, and then say Pedantic, like that. And then this base model will just need to import from Pedantic. Inside here, we'll define that whatever we return should contain the property audio data. This should be an optional, or it should actually not be optional, it should just be a string, like that. And then we should be able to tell the endpoint down here that that is what we're going to return. So we'll do this, and then scrolling further down, after os.remove, we can say return generate music response, and we'll then say audio data is equal to the encoded base 64 right here. So now we created a pretty simple endpoint. It doesn't do much other than just create this hard-coded music right here, and then return this as encoded data, such that we can read it from the response of the endpoint and then write it to our local disk. But in reality, after we have tested this, what we'll do is we'll pass in a request as well up here. That will then allow us to set the prompt, the lyrics, maybe the audio duration in first step, guidance scale as well. And also make sure that this that this song that is being generated is also being uploaded to S3 instead of only being encoded and then sent back as audio. Because usually it isn't great to just encode a large file like this. Maybe I don't think it's that large, but I don't think it's a great idea to just encode a song like this into base64 and just return that entire song over a request. That isn't the best idea. So what we'll do is we'll upload this to an S3 bucket instead, once we are done testing this, of course. So what we have done now is that we have created the actual endpoint, and then whenever we say modal run main.py, this endpoint will then be served such that we can test it down here. So I'll just go ahead and say, instead of a function test.remote, I'll say server is equal to music gen server, create a new instance of this server up here. I'll then just say endpoint URL is equal to server.generate.get web URL. This will get us the URL of the endpoint which we just created up here. Then we should be able to hop down here and just say response is equal to requests, which we'll just need to import dot post. So we'll make a post request because we defined a post accepting endpoint, and we would like to pass in the endpoint URL, and then we can say response dot raise for status, and we'll then just say results is equal to generate music response, where we put in our destructure the response.json. Then we can take the encoded song that we just got returned and then say audio bytes is equal to base64.base64, and now it is decode, not encode, and then results.audio data. We'll then just say output file name is equal to generated.vav. That is what we're going to save it on our local disk over here. Then what we can do is we can say with open, and then I'll say output file name, and then I'll say write binary as file. We'll then say file.write audio bytes like this. Cool. So now what I'll do is I'll just try and say modal run main.py and just run this and see what happens. So it just needs to build a couple of things because we changed the requirements up here. So whenever you change anything in the image, so for example, we change the requirements, it is going to redo the requirements part and then every step that comes after this. So because we changed the requirements, it is also after this going to get clone this down again, say pip install, set the environment variable, and then add this at last. But it won't really touch the following line right here or the following line right here because that comes before the line that we changed. So just so you know that whenever you change something, it's going to change everything that comes after that as well. So now I'll just wait for this to finish and then I'll come back with a response. So right now it has reached a point where it is fetching the files. So remember how I said that up here the first time that you run inference with these models, they are going to download the model checkpoints or the model weights down to the directories that you define, and then they'll be loaded automatically without re-downloading the next time you do it. Well, that is what is happening here. So as you see right now it is fetching these files, and these are basically just the model checkpoints, and then it is loading the checkpoint shards like this. And all of this comes after what we talked about here, where it just read all of the Docker image building steps. So I'll just come back whenever this is done as well. And I can see that we just ran into an error right here. So scrolling up, we can see something about, let me just scroll up. Exists okay is an invalid keyword argument for mkdir. So I think it is make directories like this if you would like to use the following keyword. So I'll just go ahead and say modal run main.py again, and then hopefully it works faster this time because it doesn't really need to do all of those Docker steps. So I'll just wait till this is finished and then we can see whatever the output hopefully is. Great, so it just finished and let's just check out what happened. So it loaded the shards over here, the checkpoint shards, and then down here we can see that it did a bunch of stuff. These are just some logs from the music generation and model. We don't really need to look at that, but we can see that we have a post 200 OK. So now we should be able to, one more thing is that it took about 2 minutes, so 111 seconds for it to finish. Now if we hop up here, we can see that we have a generated.vav. And the reason, as I explained before, is that whenever we call this endpoint up here, the response will then contain the result.audio data, which will then take and write to our local disk on our local machine. So we should be able to click this generate.vav and then listen to how it sounds.
waves on the bass, pulsing in the speakers, turn the moving with the flow, swagger on stage, energy to blow from the blocks to the booth. City lights aglow, rhythm in the.
So it sounds not great, but you can change some of these parameters up here, such as the in first step, guidance scale, audio duration, and you can also set a seed. You can set a manual seed, like this, just to make sure that you always get the same audio out whenever you run it with the same prompt, lyrics, audio duration, etc. So now we at least know that the model works. We can always play around with these different parameters and tune it, but now we at least know that it works, which is great. So let me just close this down and then also close down the terminal by clicking twice here, and then we can move on with the code. Just so I am completely sure that you understand what is going on here, I'm just going to pull up the Excalibur draw again, so right here, and then I'll hop over to the modal part. So I'll just scroll up to right here, and then as you probably remember, we have the part running on our computer, so that is when we code the program, and then we can run modal run, and then some code will then be run in the modal cloud. So I'll just show you what code runs in these two different places. So the first part is this local entry point. So this local entry point runs down here on a local computer. So I'll just take this just for visualization. So it runs right there. And then this part up here, where we do the inference with the AI model, well, that of course runs up in the modal cloud. So what we do basically is that we code the program, and then we say modal run, and then this part right here runs on our local computer. Then it is going to make a request up to an endpoint, because as you see, we define an endpoint right here. So everything that runs inside of this one is being run whenever we hit this endpoint called generate. So therefore we make a request from our local computer. That is what we do right here. We say endpoint URL, and that is equal to the server's .generate.get web URL. And we can then make a post request to that URL with a requests.post. So that request is signified by the error right here. Then the inference happens on the modal cloud right there. And then what happens is that a file is created where the music is stored. So that is just the path, the .vav file right here. So that is where the model saves it to. So we then read the contents of that file, then we encode the contents of the file, and then we send it back to the client. So up here, we just send a request to generate a song, and then what it will return the endpoint is then the encoded song, like this. So the endpoint will return the encoded song, and then back here in the local environment, so on a machine, we are going to decode the contents of the song. That is what is happening right here. And then we'll take that song and then write it to our local machine. So if you were a bit confused on why we have a file both up here, but also down here, well, this is why. We'll need to, first of all, generate the song on the modal cloud, so in the backend, and then we'll need to send that back in encoded format to our local machine again, and then we'll have to decode the song and then write it to our machine. So in case you are a little bit confused, that should probably clear it up what happens. So we have the local machine and then also the modal cloud. So hopefully that cleared a little bit up for you. I would also like to address one more thing. So as you saw, the results of the generated songs weren't great. One thing you can do though is you can hop into the ACE step right here, and then you can go under example, I think it's project, and then you can see a bunch of different songs down here that they actually generated, and then also the prompts for those songs and the lyrics as well. So if I just try and play one of these,
A step is the rhythm the new world knows.
so this obviously sounds way better than ours did, because ours sounded a bit like it was a bit messy and not very coherent. So I just wanted to tell you that you actually are able to get some pretty decent songs out of the AI model, and we were just unlucky that we got a song out that wasn't great. So even if you run the same prompt right here, with the same prompt, lyrics, audio duration, etc., you will get a completely different song out, even with the same inputs, unless, as I said, that you set this manual seed parameter right here, so you always get the same song out if you have the same inputs. So just so you know, you are definitely able to get decent songs out. It's just because we were unlucky with the song that we just generated. So whenever we are going to generate a song for the front end, what we'll do is we'll probably run this 2 times to generate 2 different songs for the user per request. And then we'll change some of these variables such that the guidance scale is maybe 7.5 for one request and then 15 for the other request, just to create some variety in the 2 songs that will generate for the user. So this endpoint that we created right here was just for testing basically, but what I would like to do is just create the free endpoint that we're actually going to need. And as you remember from the theory, we need 3 different endpoints because we have 3 different modes. We have the modes where we provide a description, we have a mode where we provide a prompt, and then also some manually written lyrics, and then you have a mode where the LLM is able to write the lyrics for you. So what I'll do is I'll just take this right here and copy it down, and then we'll call this generate from description like this, and then we'll just say pass for now, and then below this we'll just create 2 more endpoints, this one and this one, and the second one I'll call generate with lyrics like that, and then for the last one I'll just call that generate with describe lyrics. So now we should have 3 different endpoints, and we just need to fill out the contents of each of these endpoints. One thing I would like to do first though is just define what types that we expect, both for the request but also for the response. So as you probably are able to remember, up here we define these different properties that we pass into the model during inference. So I would like the actual request to contain some of these, such that you can from the front end set the infer step, the guidance skill, the audio duration, prompt, lyrics, etc. So what I'll do is I'll just hop up here, and then I'll create a base type that contains all of these, because you'll need to define both the seed, the guidance skill, inference step, etc. for each one of these. So we'll just make sure that each one of these can use a reusable class and then inherit these properties. So I'll go up here and then I'll say class, and I'll call this audio generation base, and we'll inherit from the base model just like we did down here. And then I would like to define the audio duration. The audio duration should be a float, and I'll just set this to 15 by default. I'll then also set a seed, and I'll set the seed to an integer, and I'll set it to -1, meaning we won't set a seed. So if you pass in -1 as the seed into the model, it won't set a seed, so that is why I do that. I'll then also set the guidance scale. This will be a float as well, and I'll set it to 15, like this. And I think I'll actually just set the audio duration to something like 180, just so we always have 3 minutes by default. Then we can just set the infer step to an integer and set this to 60, like that. Good. Now we can define the actual requests for each one of the endpoints. So we'll basically define what we expect to receive whenever you call each one of these endpoints. So for the description one, we would like to expect a description to be provided. Down here, we would like to expect both a prompt but also a lyrics part. And then down here, we would like both a prompt and then also a description of the lyrics. So that is what I'm going to do up here. The first one I'll do is the following one. So I'll say class, and then I'll say generate from description requests. And I'll just inherit from this one right here, just so all of these different properties are available. Then I would like to say full described song, because that is what we do with this endpoint. We just describe a song only with text, and then the endpoint takes care of everything. And then of course we also need an instrumental flag. So I'll just go ahead and say instrumental up here, and just set this to a boolean that is false. Then down here, this should be enough for the endpoint where you only describe the song. And then we can just create the request schema for the endpoint with the custom lyrics. So I'll say generate with custom lyrics request. And then what I would expect to receive is something like the prompt. So the prompt is going to be the style of the song. I would also expect the lyrics, because you provide the lyrics yourself, like this. And then lastly, we can create one where you just describe the lyrics. So here I'll say with describe lyrics, and then I would expect the prompt and also the describe lyrics and not the lyrics. So these are the requests that I expect, the schemas of the requests that I expect from my free endpoints. We can now then just define a response, so what we expect the endpoint to respond with. So I'll just do that right below. I'll say class and then generate music response. And I think we already have one called that actually, so I'll just go ahead and remove that. And then let me just call this S3 instead. If I just do this, because we already have one called that. So I'll just call this generate music response S3 because we'll upload the song and also the thumbnail, etc. to an S3 bucket. So this way we won't have to conflict with the one that we use up here. Good. So I'll go ahead and just define this one. I'll at least return the S3 key. The S3 key is a location in an S3 bucket where we store the song. And I'll just set this to none per default. And I'll actually just not set it to none. I'll just keep it as it is because it is required. I'll then set the cover image as well. Cover image S3 key. So this is the location of the song in the bucket. This is the location of the thumbnail image in the bucket. And then lastly, I'll just return a list of strings. So I'll say list of strings like this. And I'll call this categories. So remember how I said we'll use the large language model as well, just to create a list of different categories that we can use to order the songs within in the dashboard. So that is what we'll return here. And I think we'll just need to import this list as well. And then we just take our newly created classes and apply them down here. So for this one, we'll receive a request. The request should be of type generate from description requests. And then over here, I'll just cover this down and generate with custom lyrics request. And then this one should be called generate with described lyrics request. And then each one of these will return the S3 version of the response like this. So every one of these endpoints should return these three things regardless of the method they use to come to those results. So for the generate with description endpoint right here, we're going to need the large language model for, first of all, generating a prompt for the model based on the description. So the prompt is the following one right here. And then we're also going to need the LLM to generate the lyrics like this. So that is what we'll need the LLM for right here. Then for the generate with lyrics, we already have everything we need. And then, then down here with the generate with described lyrics, we already have the prompt and we only just need to generate the lyrics from the description of the lyrics. So we're going to need the large language model in these three cases right here. And for this one, it is going to be the same both for this endpoint and for this endpoint. So I'll just create two different functions or two different methods inside this class that is able to use the large language model to do these two tasks right here by taking a description provided by the request, inserting it into a template, and then running that through the large language model. So going up here over the endpoints, right there, what I'll do is I'll just create a function. This one should be called generate prompts, like that. I'll pass in both self and then also the user. I'll just call this description, like this. And this will be a string. Inside this, what we'll do is we'll insert it into a template, and then we'll run LLM inference and return that. So that is going to be the first thing we'll build. So first I'll just create the two templates which we'll insert the user description into. So what I'll do is I'll hop over here and then create this new prompt, or it's actually already created because we did that earlier on. And then behind the scenes, I've created two different prompts that we can use just so you don't have to type them out manually. So I would advise you to hop into the GitHub repository and then just grab these two prompts so you don't have to copy all of these different words. These are just prompts that I use ChatGPT to generate. So first we have the prompt generator prompt. So we use a prompt to generate a prompt. That is why the name is a little bit cryptic. Then we also have the lyrics generated prompt because we use a prompt to generate the lyrics. So as you can see, we're able to insert a variable into the following string. The variable will be inserted into the following place right here for the prompt generator prompt, and down here for the lyrics generator prompt. So for the first one right here that is able to generate the prompt, I'll say something like reformat the following user provided music description into a simple comma separated list of audio tags. And then I'll say follow these guidelines strictly when reformatting, include each tag from the category in the found list. And then I would like it to include something like the genre, the vocal type, the instruments, and then the mood energy, the tempo, the key. And then I say the output must be a single line of comma separated text. And then the model is supposed to output these tags down here as its response. So that is what we do to generate the prompt. And then for the lyrics, we'll just do the same. We'll just say generate song lyrics based on the following description. And then I'll say the lyrics should be suitable for a song and structured clearly. And I'll say use tags like verse, chorus, bridge, and intro and outro to structure the song. And then I'll say here is an example. And then this is just an example from the ACE step as I explained. And also the reason that I say these square brackets with verse, chorus, example, bridge, for example, is because that is what they do actually over here in the examples as well. So they put in verse right there, chorus, and bridge, for example, just to help the model understand the song better. So that is what the scientists behind this even do themselves. So that is what I would advise the model to do too. So that is why I put this in. And then I just took one of these that already exists, and then I just pasted that in as the example, just so it has an example, so it's not completely zero shot. Then we just insert the description provided by the user, and then we let the model generate the lyrics below as its response. So the first thing we'll need to do inside the endpoints is just actually inserting the user's description into this formatted string right here. So the way we're going to do this is by hopping in here, and then I'll say insert description to template. Below this, I'll just say full prompt and just indent this correctly is equal to, and then prompt. And I think I'll just need to copy this so I can spell it out all the way and then import that prompt. And we can then say .format in Python, and then we can pass in the user prompt. That is going to be equal to the description right here. And the user prompt right there then matches whatever we called it right here, the user prompt. Good. And then we're just going to do the exact same thing for the next endpoint, which we'll create in just a second. First, I would just like to set up the large language model though, so it runs, and we can run this prompt through it just to test that it works. So I'll just right below this create, or right above this probably, create a function that allows us to use the Qwen large language model that we defined up here. I'll load it up into the memory right here. So I'll say def prompt Qwen, that is what we call the large language model, or what it is called. And then we'll pass in self, and we'll pass in a question, which is a string. So that is going to be the prompt. And then what I would like to do is just return a response down here after prompting it. So to find out how it actually works, what we can do is we can hop under Hugging Face. So I'll search for Qwen, and then 7 billion parameters, Hugging Face. And we're using the instruct version, as you can see up here. Instruct. So down here we should then be able to see the usage. So I'm going to need everything from the messages and then all the way down to response. Because remember, we did this in the cold start method that runs to load the AI model into memory. And then all of this we need to do within the endpoint itself. So the prompt we already have now, and we just need to insert it into messages and run the prompt. So I'll just paste this in right here, and I'll indent it correctly. And then I'll remove the first message right here. And then I'll just pass in the question as the only thing. And then for the tokenizer, we'll say self.tokenizer, because remember we defined the tokenizer, we loaded the tokenizer up here when it cold starts. And then we need to do the same down here, self.tokenizer again. And then for the device, that is always going to be CUDA, but we'll just say self.large language model. And then we'll say .device, because we can also grab the device this way. And then we'll say self.large language model, like that, because that is what we call the actual model right here. And then this we'll just leave as it is. And then down here we'll just say self.tokenizer, and then just return this response. So I'll just say return response. And this should actually be enough to be able to run this Qwen model according to the usage section over here. So that is super simple, and we didn't have to do a lot ourselves. Now the only thing we then need to do is just to take this prompt Qwen and then hop down here and then say return. And then we can say self.prompt Qwen. And then we'll pass in the full prompt, where we pass in the description, insert it into the template, and then we insert that into the model. So what I'll do is I'll just keep the comment just so we're able to remember that. And then I'll copy this down, and then remember this was only for generating the actual prompts. We also need to generate the lyrics in some cases, so I'll say generate lyrics. And then for this one, I'll just insert it into this other template, the lyrics generator prompt, like that. And then I think we call this description down here. So I'll just make sure to insert the description into the description variable, otherwise it'll give an error. So this should be enough for generating the two things that we'll need, or two parameters that we'll need for using the model up here. So we can then go down and actually use those. So first we'll need to generate a prompt. So the way we're going to do this is by saying prompt is equal to self.format prompt, what's it called, generate prompts, like this. Then we can pass in the requests, dots, and from the request we can pass in the full described song. This will then be inserted into the template, ran through the large language model. Then we can pass that in as a parameter to the music generation model. Then for generating lyrics, we'll just say lyrics is equal to an empty string. Then we can say if not request.instrumental, because remember, if the request has the instrumental flag set to true, we'll just completely disregard generating the lyrics because it is not needed. So only if the instrumental flag is set to false, we'll go ahead and say lyrics is equal to self.generate lyrics. And then we pass in this request.fullDescribed song. And that should be enough for generating those two parameters. Then we'll just need to create some way to actually run this music model up here. Instead of just running it and then encoding the data, we'll need to both run the music model, but also upload both the song, but also the thumbnail to the S3 bucket. I'll just create an internal function for doing that. So hopping up here to our other functions, below this, I'll create one called generate and upload to S3. And I'll pass in quite a lot of parameters. I'll pass in self, and then also the prompt string. I'll also pass in the lyrics. I'll pass in the flag for whether it is instrumental or not. That is just a boolean. Then below this, I'll pass in the audio duration. That is a float. I'll pass in the info step, like this. That is also going to be an integer actually. And then I'll pass in the guidance scale. That is going to be a float. And I'll pass in the seed, which is an integer, in case you would like to set that. And lastly, we'll just set the return type of this one. So we'll set the return type to be generate music S3 response. And then we can reuse this function for all three endpoints because it is going to return the correct response. And then after this, what we'll do is just open it up, and then we can start building out the method. So first I would like to handle the lyrics. So in case you do not provide any lyrics or you set the instrumental flag, I would like to put in the following string right here that says instrumental. So if you would like an instrumental song, you need to put in this in the lyrics. I think you can either figure this out by looking at how they actually did it here. So maybe if they say instrumentals right there. So you just put in instrumental like this if you would like to put in an instrumental song. So that is what I'm going to do. You can also just type it out like this. So I'll say final lyrics is equal to, and then instrumental if instrumental is true, else I'll set it to the lyrics. So we override the lyrics if instrumental is true, otherwise we do not. Then we can go ahead and say print, just for debugging purposes, generated lyrics. And this is going to be a formatted string where we pass in the final lyrics like this. Then I'll just pass in the prompt as well. So I'll say prompt, just so we have that for debugging purposes. Then we can go ahead and get the S3 bucket ready, because we do not only need to actually generate it, we also need to upload it to an S3 bucket. Right now we do not have any S3 buckets or even an AWS account, maybe in your case. So what I'll do is I'll just guide you through the entire process of both setting up the AWS account, creating the buckets, and then creating the IAM users that will allow us to upload things to the S3 bucket. So we'll first of all go to, let me just make some comments. We'll head to AWS, create an account. Then we'll go and create an S3 bucket. So we'll create an S3 bucket. This S3 bucket is going to contain both all the thumbnails, but also all the songs, and these will just be stored in the root of the S3 bucket. Then what we can also do is we can go ahead and create some IAM users. The first IAM user which we're going to create is going to be a frontend user. This will be used by the Next.js application. This will have the access to getting objects from the S3 bucket. So we'll say get object, then also list object. These are two different permissions you can give an IAM user to allow to do certain things. So in this case, because it is in the front end, so not this application, but the one we'll build afterwards, we only need the user to be able to actually get things from the S3 bucket, but not actually put things into the S3 bucket or delete anything. So that is the second user we're going to build. The first one is the one that we're currently building. This is going to be for the backend. So right here in the Modal backend, we'll obviously need to be able to, this is going to be Modal. We'll obviously need to be able to upload something to the bucket. So we'll go ahead and say put object. That is one that we'll definitely need. And then we'll of course also just give it read access in case we need that. So this is the pretty simple setup that we're rolling with. We'll create a bucket, create these two IAM users, and then we should be ready to go and then continue with this method. So what we're going to do is we'll just hop into AWS. So we'll go over here, search for AWS, find Amazon Web Services. Then we'll just say sign in. And then I'll just hop into sign in using the root user email. And then I'm just going to sign in with my own account. Otherwise, you can create or you can click this new to AWS and then sign up for another account. Cool, so I just logged in here. And then the first thing I would like to do is hop into the S3 section. So if you hop under search, let me just zoom in a little bit. If you hop up under search and then search for S3, you should be able to find this bucket service. And if you do not know what S3 is, it is basically just a file storage service that you can use to store and retrieve any amount of data from anywhere. So you basically define a specific namespace, and then you can put files into this namespace and also retrieve them again. So it's just a way, instead of a normal database, where you can store actual files, because you can't just put an MP4 file into a database without a lot of hassle basically. So I'll hop under create bucket, and then I'll find a bucket name. I'll try out music, generation, and then maybe bucket. Let's see if that is available. And I think we'll just leave all of this as it is. And then we'll go ahead and say create bucket. Now we have this bucket called music generation bucket. So that is going to be the namespace where we can put in our files. And then to be able to actually interact with the bucket, we're going to need to set up some IAM users. So that is that is a service for managing access to the AWS resources, as you can see right here. So I'll hop under IAM. And then we'll create a user that we can use to interact with the bucket from the Modal backend first. So I'll say create user. I'll call the user music gen backend. And then just say next. And then I would like to create some policies. So I'll say attach policies directly. Then create a new policy. And then I would like to choose a service that is going to be S3. And then we of course need, as I said over here, we need put object, get object, and list object. So put object is for actually putting things into the bucket. Put object, like that. So that is a write permission. Then we need to give it access to get object as well. And we need access to list bucket, like this. And now we have all three of these permissions covered. Good, and then I would like to just specify which bucket that this applies to. So we can actually go ahead and specify that this only is available, that this is only something you can do for a single bucket. So I'll just open up a new AWS tab, hop under S3, go into my buckets, and then under, I think it's properties, we can find this Amazon resource name. So that is basically an ID that is totally unique for this specific resource in AWS, so that is the bucket. Then we can hop back into the policy, paste in the bucket resource down here. This means that we are only able to list this bucket right here, put objects into this bucket, and also get objects from this bucket. So if you create another bucket, it won't really suffice for that one. And then for the specific objects that we're working with, we'll set this to any, meaning you can get any object from the bucket. Good, so now we'll just say next. Give it a policy name. I would like to say music gen backend policy, like this. Say create policy. And then you probably noticed that it opened up a new tab over here. So we'll need to navigate back to the old tab, refresh the list of policies. Call this music gen backend policy. And then we'll attach that and then say next. And then we'll say create user. And now we have the backend user. We'll just repeat this process. So we'll say create user, say music, generation, frontend. say next, attach policies directly. We'll create a new policy again. I'll then say choose service as free. And then we're going to apply the get object and also the list buckets. And then we'll pass in the specific ARN again. And then any object should be able to be interacted with within the bucket. This means that the front end will be able to get the thumbnails and show those, but also get the songs and play those if the user needs to play a song. We'll call this music gen frontend policy, and we'll say create policy. And then going back into the user, we can refresh the list, say music gen frontend policy, next, and then we'll create the user. And now we have these two different users right here. So now you might be thinking, well, how do we use these users to actually authenticate into AWS and then interact with AWS through these users? Well, we can actually generate a username and then a password for these users, and then we can use that username and password right here to actually interact with the bucket. So I'll click this music gen backend, then I'll say security credentials. We can actually also do it up here. I can see we can say create access key, and I'll just say other, next, and then I'll say Modal backend, create access key, and then we have the access key and the secret access key for using these users. So instead of just hard coding those access keys in as secrets in this backend, what we'll do is we'll define them in a secrets manager. So if you hop into the Modal dashboard, then go into secrets, we created this music gen secret earlier, which we can define our secrets within. So that is what we inject into the endpoints with the following line right here. So everything we define in here will be not visible in the code, but it can be used within the code. So we can go into edit, and then we can add the following values. I'll just remove this test one like that, if we are able to. I think we're not able to actually. I'll just say add another, and then this one should be called AWS access key ID. And then we'll just hop into AWS over here and copy that access key. And then we'll add another one. This is going to be AWS and then secret access key. And this is going to be the secret key. So if I just find this again, like that, then we can say add another one, and we'll just need to add AWS and then region as well, because you're able to use multiple different regions in the world and create resources in these different regions with AWS. So if I hop back into AWS, we can see that I'm using a US East one, or usually I do, US East one right here. And then hopping back, that is the one I'll be using. And then we can say S3 bucket name. That is another one we'll use just so we can reference what the bucket actually is. And this one will then be the actual bucket. So this is going to be called music generation buckets. So I'll just put that in, and that should be good enough for the keys that we'll use right now. Cool. So now these four environment variables should be ready for us to use whenever we want to use them inside the backend here. So we just need to install a library for being able to interact with AWS, and this library is called Boto Free. So I'll go into requirements, then I'll put in Boto Free, and then also open up a new terminal and say Python. I can say Python right here, or pip, install Boto Free, and just let that install. That should only take a second. Then what I'll do is I'll just hop back into main, close this down, and then I'll import Boto Free. So I'll say import Boto Free. Then down here in our function, I would like to just delete those because we don't really need that anymore. I would like to say S3 client. So we'll need to create a client to interact with the AWS API through Boto Free. So we'll say botofree.client, and I would like to interact with the S3 service specifically. Then we can just get the bucket name as well. That comes from os.environ. And then we'll pass in S3 bucket name like this. That is the environment variable that we would like to get our hands on. That is this one right here. This will give us the bucket name. Then what we can do is that we can say, and let me just copy this part from down here. We can copy this. So I'll just paste this right down here. And then change these specific parameters. So the prompt is going to be the prompt. The lyrics are going to be lyrics like that. I think it's actually going to be called the final lyrics. The audio duration comes from the audio duration up here. In first step, likewise, guidance scale, the same. And the save path is going to be the output path. What we can then do is that we can take this file that was just saved and then upload that directly to S3. So we'll just say audio S3 key and just define the name that the file is going to have inside the S3 bucket. So if you just close these down, this one, then just say done here. And you can only see this access key once, by the way, so make sure to write it down before you close it. Then I'll just hop in here. So what you'll be able to name the file is what we'll define here. That is called the S3 key. The S3 key will be equal to a formatted string. Well, just format it the same way as we do up here. So we'll just call it a uuid.vav. Then I'll upload the file to an S3 bucket. So S3 client.upload file. Like this. And I would like to upload this output path. And I would like to upload to the bucket. And I would like to upload under this name, audio S3 key. So we define what we want to upload, where we want to upload it to, and what we want to name the uploaded file in the bucket. And now, because we have uploaded the file from the container to the buckets, we can go ahead and remove it from the container. So we'll say os.remove, and then just delete the file from the Modal cloud. So we'll just remove the output path right here. So this actually takes care of the music generation and also uploading it to the bucket. And now we just need to handle the thumbnail generation as well. And then lastly, we'll need to handle the category generation. So whether it is rock, hip hop, etc. So we can just go ahead and create a prompt for the actual diffusion model, which we'll use. So we'll say artistic prompt, I don't know, thumbnail prompt, something like this, formatted. And then we'll say prompt up here. We'll put in the prompt, and then we'll also put in comma, album, cover art. So this is the prompt we pass into the diffusion model, not the large language model. So remember, we also defined this stable diffusion model, and that is text to image, meaning we put in a text prompt and we get out an image. So we would like to put in the prompt for whatever was used to generate the song, comma, album cover art, so it knows to generate something that looks like a cover art album. Then we should be able to use the diffusion algorithm, the diffusion model. So we'll say image is equal to self.imagePipe, and then we can pass in the prompt. That is going to be prompt. We can also set the number of inference steps. That is going to be equal to 2. We'll set the guidance scale to 0.0. And we can then say dot images, and then take the first one generated because we only generate one. Then what we'll do is just take that and just actually go ahead and save the image that was generated. So first we'll just need to create a path for where to save it to. So what I'll do is I'll just copy the logic that we used before as well. And then this one will just be .png instead because it is an image. And we'll then just say image output path instead. Then we can say image.save image output path like this. And when we do this, the image is going to be saved within the container on the Modal cloud. And now that we have the image in the container, we can go ahead and upload it to the S3 bucket, just like we did up here. So I'll copy this logic down, then I'll say image S3 key, and then I'll say .png, like this. Then what I'll do is I'll say image S3 key over here as well. And this will be the image output path. So we'll upload the image under this name to this bucket. And then we'll just go ahead and delete the image again, right down here. Next, we can just go ahead and say auth.remove. That is done already actually. So now we have also handled the entire thumbnail generation. We'll just need to take this thumbnail prompt and use that because that is the correct prompt. And now we just need to do the category generation as well. So to generate the categories, and the categories, remember, is going to be something like hip hop, comma, so it's just a list of categories. So hip hop would be one, and then rock would be another one, for example. So we'll just need to use the large language model to find those. So up here, I'll say define, generate categories, self description, that is a string. And then it's going to return a list of strings like this. Then what we can say is we can say prompt, and I've actually prepared a prompt behind the scenes as well, just like we did before. So this one says, based on the following music description, list 3 to 5 relevant genres, or categorize as comma separated list. For example, pop, electronic, sad, 80s, etc. Then we pass in the description, and then the description is what the user actually passed in himself. Then we can just say response text is equal to self.promptQuent, where we pass in the prompt into the large language model. And then we just need to take whatever it outputs, and then because it is comma separated, break it into its different components, and then construct a list from that. So we can create a list like this. We'll say categories, that is going to be a list. It's going to be equal to category.strip, so we will remove trailing white spaces or leading white spaces, and then we'll say for category in response text dot split, and we split the response by comma like this, if category dot strip like this. So this is just going to filter out empty strings that might be a result of the large language model putting out something that is a little bit weird, for example, because sometimes the large language model can give a response that doesn't completely match the format which we are expecting. Then because we now have the categories as a formatted string, or sorry, a structured list, we can then go ahead and say return categories, and then return that back to the front end or the caller of whoever called the endpoint. So now we have this available, so we'll just go ahead and use it down here in the generate and upload to S3. So I'll say categories is equal to generate categories. We'll of course need to say self to generate categories, and I'll pass in the description, and we'll just need to actually create a parameter we pass in up here. So I'll say description for categorization. This is a string, and I can also see that this right here is unused, so we'll just pass the seed in as well. This is going to be manual seed, and it is a string like that. And then this one is going to be different based on which endpoint it is. So for the endpoint that just accepts a description, it is of course just going to be that description. But for the endpoint that receives both a manually written lyrics but also the prompt, we'll need to define which one of those are used. So that is why I put in this prompt parameter called description for categorization. Good. So down here we can then use that, and let me just find it again, right there, description for categorization. And this should then be the last part of the 3-piece puzzle that we just solved here. So now we have the song, thumbnail, and then the category, and then we can say return generates music, and then response S3, and then we'll pass in the S3 key. That is going to be for the song, so this will be the audio S3 key. We'll then also have the cover image S3 key, or the thumbnail. This is going to be image S3 key. Then we have the categories, which will just be categories like this. Good. So this should be enough for actually doing what the endpoint is supposed to do. And now we just need to feed the different inputs for the different endpoints into this method, and then this method is going to take care of the rest. Going back down to the endpoints down here, we can actually go ahead and use the method which we just created. So for the first one, generate from description, we have both the prompt and also the lyrics. So I would like to now just say return self.generate lyrics, because this generate lyrics, I think it's called generate upload in S3, like that. So this one is just going to return the same class as we would otherwise with the endpoint, so we can just return this straight away. Then we'll pass in the prompt. The prompt is going to be equal to the prompt here. We'll pass in the lyrics as well. So we'll say lyrics is equal to lyrics. We can also pass in the instrumental. So if that is true or false, we'll say request.instrumental. And we'll then also pass in the description for categorization. In this case, it is just going to be requests.full-described song, like this. So this full described song, so the description of the song that should be generated, is what is going to be used to generate the categories as well. What we can then do is we can take every single field from this model right here. So that's going to be all of these, and then we'll just unpack each one of these automatically without having to define each of these as a parameter. So the way I'm going to do this is by just going back here to right there. Then how I'm going to do this is by saying **, and then we can say request.modal dump, and we would like to dump the entire thing but exclude the full described song, like this, the one up here. And then I think we also want to remove instrumental here, because instrumental is also a parameter that is there and also included in the base model. So we'll just remove instrumental because that is unpacked automatically anyways. Good. So this should be enough for actually having this endpoint work. We'll just finish the 2 other endpoints, and then we can go ahead and test those, because it is pretty quick to implement the next 2 as well. For this generate with lyrics one, what we'll do is we'll just paste this directly in, like this, and then we already have the prompt. We can just go ahead and say request dot, and then prompts, and we also have the lyrics because that is also a custom thing defined by the user. So we can say request dot lyrics, and then what I'll do is I'll just remove this exclude right here, because we don't have anything to exclude. Every single one of the parameters, right here, every single one of the parameters from the request up here, so the prompt, lyrics, the audio duration, seed, etc., matches what we expect as parameters right here, prompt, lyric, instrumental, etc. So that should work out just fine. Now we just need to implement the last one down here, where we have to use this generate lyrics, and then otherwise just pass in the prompt as it is. So I'll again just copy this up here, only the generate lyrics part, and then also the generate and upload to S3. So I'll just do this, and then the prompt is going to be request.prompt, and then over here we'll just say described lyrics, because we would like to exclude that. The described lyrics is not a parameter that is expected by this one right here, so we'll just go ahead and exclude that. And here it's going to be described lyrics instead. And then for the description for categorization, that is just going to be the request.prompt. And then I'll say, let me just see what the type of that is. So we have prompt and described lyrics. So I'll just go ahead and say request.prompt and just use that. And up here we'll also say request.prompt for request.full described song, like that. And now we're then actually ready to test our endpoints out. So as you probably are able to figure out, we won't really see anything return to our local computer, so we won't be able to play generated VAV, for example. We'll have to hop into the S3 bucket and then download the specific files that were just generated every time we run this. But it doesn't really take that much time to just download the files and check them out. So I would like to first of all test out this generate from description endpoint. So what I'll do is I'll hop down here, and then I'll find the generate from description, to get that web URL, and then we'll just need to form out a request. So I'll say request data is equal to generate from description request, and we'll need to pass in a full described song. I'll just say acoustic, ballad, something like that, and then I can say audio duration, that is actually default 3 minutes. We can set the guidance scale just to test that that works, 7.5. Then what we'll do is we'll just take this requested data and pass it in as a body. So we'll go down here and then say, I think we actually need to do this, payload is equal to request data.model dump. So we'll just need to dump the model, and then we can go in here and then say payload is equal to payload. JSON actually is equal to payload, like this. Good. And then the response is of course not going to be generate music response. It is going to be a generate music S3 response. And this down here is also not relevant. We'll just do some printouts instead. So we'll go ahead and say print, and then I'll just say success. and I would like to pass in the results.s3 key. I would like to also pass in, let me just copy this entire thing, pass in the cover image s3 key, and then also the categories, like this. Good. So now, because we changed some of the requirements up here, it is going to take a while to run again, but we can then just test it out. So I'll hop into the terminal again. I'll just use the same one and then say Modal, run main.py, and it will probably get an error because it is the first time testing it, but let's just test it out. And I'll come back whenever this is finished running. It finished up here, and then we can just check out what happened. So I see that we do have an error. And then we see that this os.environ is not callable, and that is because I actually use it as a function call, whereas I need to use it as an index. So I'll just go ahead and search for this, and then I'll just index into the list, the dictionary, instead of calling it like this. So if we just check out what else happened up here, we see that the large language model worked just fine. So we have the generated lyrics right here, and then also the prompt that was generated. So it seems to be working just fine. It was just that little issue. So if I just try and run this again, we can just check out what happens in a second when it is done. The second error we're running into here as well, if I just scroll up, it is unexpected keyword manual seed, and then it is actually called manual seeds and not manual seed. So let me just try and fix that and run it again. Luckily it runs pretty fast whenever we start it up. So I'll just wait for this to finish again. It just finished up here as well, and now we can see the printout. So it did both the lyrics and also the prompt down here, and we can see that we have all of these log printouts from the actual music generation. We also see success, and then we have the S3 key of the song, and then we also have the S3 key of the thumbnail, and we have the categories for the song that was generated. Good. So let's now hop into the S3 bucket and then check out what we got. So if I just refresh, we have a thumbnail and also a song. So let me just download both of these. I think I need to download them one at a time actually. I'll download this one, and then I'll go ahead and open them up. So this right here is the thumbnail, and this looks pretty decent for a cover image that is AI generated. Let me just open up the song as well. So I just open up the song from my downloads folder right here, and then if I just try and play that.
Strings, gentle breeze, a melody to ease your stress. We find solace from life.
So it also sounded a little bit better than last time, but it still wasn't great. Let me just try and generate one more just to see if there's any difference at all. So I'll just go down here and set this to 15, and then just say modal run main, and then I'll come back whenever this is done. And it just finished up here. So I'll just take this song and just find that over here. So that is this one. So I'll download this and then just play this for you as well. So this is what was just generated. I'll just turn the volume down just a little bit.
The rhythm of the heart's delight, an acoustic ballad pure and bright. A story unfolds, words of love in an acoustic gold.
So I would say that this is much better than the previous ones we got. So as you can see, it does work out for the best if you try out some different parameters. So you can set the guidance scale to 7.5 and 15. And then when I do this, I usually get some tracks that are a little bit bad and then some that are pretty good. And if you're wondering whether we can do better than this, so this A step right here, the model that we chose to use, is basically the state of the art for music generation right now. It will of course improve much in the future, but right now this is the best that we have to work with, and I would say that it is pretty decent for being open source. And now I would like to just test out the other two endpoints just so we know that they work. So I'll just hop in here and then find the other ones. So this one should be generate with lyrics, like this. And then we of course need to use the generate with custom lyrics requests. That's the one that is used, yeah. And then for this one, we'll need to pass in the prompt and also the lyrics. So the prompt should be, I'll say trap and then hip hop. And then for the lyrics, I'll just go ahead and find some lyrics from this page right here. So I'll just take these ones and just paste those in as they are right there. If I just make this a multi-line string, I think it'll work a little bit better like that. And then I see that we have an error up here somewhere. So it says it is not closed. So we'll just make sure that it is actually closed by putting in a comma right there. Cool. So let me just try and pass this into the model. So I'll just go ahead and say modal run main.py. And then in the meantime, we can just go ahead and get ready for the next one. That is going to be generate with describe lyrics. So we'll just take this one, I'll just wait for this to finish, and then I'll do that. And I can see that we got an error down here after it finished. It says this one got multiple values for the keyword prompt. So if I just take this and then find out wherever we used it, so line 245, that is up here, we have prompt. So the reason that prompt could be passed into this function twice could be because we pass it in both here, but also whenever we dump everything right here. And we actually do dump the prompt as well, because we have prompt and lyrics, and we pass in both prompt and lyrics already. So we'll just go ahead and exclude those two by doing this. Then I'll say prompt and I'll say lyrics. And then we might want to just do the same down here. For this one, we have describe lyrics, but then we also pass in the prompts, but we also destructure the prompts like this. So we'll need to just do it down here as well. Cool. Let me just try it out again. Modal run main.py, and then I'll just wait for this to do something. It just finished now without issues. So let me just copy this sound link, or sound is free key, sorry. Then I'll hop in here and just find that. So I'll refresh, search for it, and then I'll just download this one, and then we can just take a listen if the lyrics match what we actually expect, because we took these lyrics right here. Was it this one? I think it was this one actually. So here I have opened up this new one, BA33, that is this one. And then what I'll do is I'll just check the first couple of lines. So voices blend in harmony, lost in pure cacophony. So I'll just take this and try and play it and see if it matches. Let me just turn down the volume just a little bit as well.
Neon lights, they flicker bright. City hums in dead of night.
So I actually just realized while the music was playing that I was scrolled down to right here. Of course, we need to scroll all the way up. So it said neon lights, they flicker bright, city hums in dead of night. So the lyrics were matching just fine. So let me just try and play a little bit more so we can see what it sounds like.
Rhythms to pulse to keyboard dances. My chest, heartbeats match.
So the only thing I think it doesn't do very well is it doesn't really match the trap and keyword and prompt very well. But we could also describe these better and use even more keywords. So inside the A step project, if we hop in here, we can see that sometimes they use all different kinds of combinations. Maybe they have like 10 different down here, and they also try all kinds of different combinations. So you can of course try a bunch of these combinations and maybe it'll work better. We just happen to have a song that didn't really match trap and hip hop very well for the generated song. Cool. So let me now just try the generate with describe lyrics, and let me just see what that is going to look like. So that is this one. And then for the lyrics, we do not need to pass those in. We'll just pass in a description of the lyrics. So I'll say lyrics description, generate with describe lyrics request. Then I'll say describe lyrics, and then lyrics about water bottles, like this. And then I'll just say rave and funk 140 BPM, disco, just to try some other ones, and then we'll see if this works even better. This is kind of a fun request, so let's just try it out and see what happens. I think everything should be set up fine now. Good. So I'll just go ahead and say Modal run main.py, and then we can check out the results. And it just finished. So I'll just copy the name of the S3 key, hop back into the buckets, and just refresh and find that. That is this one. Then I'll just go ahead and download it like this. And then I'll just play it in the Visual Studio Code right here. So I just opened it up, and remember we described lyrics about water bottles, so we can just check out if that worked. So crystal clear, perhaps a bit flat. A simple bottle holding water in chains. So it's definitely something about water, hydration, water bottles in all shapes and sizes. Okay, so it's definitely working with the described lyrics, even though it might be a little bit weird. Let me just try and play this just to see how it sounds as well.
In the land of convenience, always there. Reasonable to disposable, they're everywhere. To disposable, they're everywhere.
So again, I think it didn't really match our request very well for the actual tags, but at least the lyrics worked out just fine, so that is good to know. Whenever we build out the UI for this, it will be easier to test it out because you can just click a single button and then have the dashboard generate a couple of sounds for you that you can then play. So this way, whenever we build the dashboard, we'll be able to generate a bit more sounds and then actually test them out and find out what prompts work well, etc. And then one more thing before we are done with the backend is also that right now our endpoints isn't really secured, so everybody will just be able to find this URL right here, the web URL, and then just make a post request with the data and then be able to generate something with our processing power. But we don't really want to do that. We would like to make sure that we are the only ones that can actually call these endpoints. So we're going to use something called proxy auth from Modal. So that is basically just an authentication token that we can pass in whenever we want to call the endpoint. So what I'll do is I'll hop into the Modal dashboard here, and then I would like to go into my settings like this, and then hop under proxy auth tokens, create a new token. And then this one I'll just copy in straight away. So what I'll just do just for testing is that I'll just make it a comment here, and then also a comment right here. And then we'll be able to define a dictionary with these two right here. So modal key and modal secret. So I'll just do this and we can then pass them in as headers for the request. Otherwise it won't work. So we'll need to say headers is equal to, and I'll just say modal key. And I'll say this value. And I'll then just put in this one for the modal secret right there as well. And then we can pass these in as the headers for the request. So I'll say headers is equal to headers. And then I'll just try without these first, because now we do have the proxy tokens, and we'll just go ahead and enable those. So up near our endpoints, we can go ahead and say it requires proxy token like this, set this to true. And I'll just do this for every single one of our endpoints. So this one, and we also have that one, and also this one. So now if I try and call one of these endpoints without the proxy token, so let me just do that. I'll just run modal run main.py, and then hopefully we get rejected. So for one client error, unauthorized. And then if I actually pass in the proxy token, so going down, passing in the headers like that, hopefully it should work. So I'll just run this and come back whenever it is finished. So let me just see what happens. So the endpoint just started doing something. It is loading the checkpoint shards, and it wouldn't be able to do that without actually accessing the actual code in here. So the proxy token seems to be working just fine. So now we also know how to authenticate our endpoints. We just need to make these two secrets in our environment file in the Next.js application to make sure that we're actually able to access these endpoints. Great. So currently what we have done is that we have, let me just close this and go back, is that whenever we have ran modal run main.py, it will just start up something right here. I can just try and do it again. If we just say modal run main.py, it is going to start up an app right here, And that is going to be one that is ephemeral, meaning it is going to disappear whenever it is done running. So if I just go ahead and close this, and just shut this off again, cancel, then it should disappear from here at some point. And then what we would like to do is just create an app that is always live. So we would like to actually deploy our endpoints. Luckily, because we have been testing this way that we have right here, we know that we should just be able to deploy this and then the endpoints should be live. So to do that, what we'll do is we'll say modal deploy min.py, and that should actually be enough for deploying our endpoints. Let me just see if it is gone over here. If I refresh, it is still not gone. It is going to disappear at one point though. So I'll just go ahead and say modal deploy min.py and just execute this. And we can then see app deployed in this amount of seconds. And then the actual endpoint URLs is going to be this one, and this one. This one was just the testing one we used earlier, so we can just discard that. But we'll be able to call these from the Next.js application and then interact with all the code that we built earlier. If I then refresh over here, we're able to see that we also have a web endpoint that is not ephemeral. So this one up here, and that is our actual deployed endpoint. We can also see the specific endpoints for these specific serverless functions or endpoint up here that we also created. So now that we have done that, we have basically just created the entire backend for our system, or at least the backend that handles the AI inference. There's of course also a backend in Next.js. So what I'll do is I'll go ahead and create a new Next.js project so we can get started with the front end as well. So what I'll do is I'll hop into File, Open Folder, and then I'll hop into Music Generator and just say Open. And now we have the backend folder, so I'll just open up a new integrated terminal. Then I'll go to T3 stack, search for that on Google. This is the stack which I'll use to initialize my new Next.js application. So I'll just say npm create T3 at latest, and I'll use npm. In here, I'll just put in this command. And then my app will just be called frontend for now. I'll say Typescript, yes, and I'll say no to TRPC. I'll say none to Next.Auth. I'll say yes to Prisma, yes to the app router, and I'll then just say Postgres because we'll use Neon, that is Postgres. ESLint, yes, no to this, and then yes to npm install. Great. So I'll just wait for this to finish. Now that it is done, we can go ahead and navigate to the project we just created. So hop into Open Folder, then find your project, hop into Frontend, and then we'll just open up the terminal, the project like this. Then you should be able to go down here to npm scripts, find npm run dev, click the play button. If you aren't able to see npm scripts, you can right click right here, and then check on npm scripts. Then you can copy the following URL, the localhost local server, and then we'll just paste that into the browser. So I'll just open up the browser in a side-by-side view here. And now we have the side-by-side view. So I'll just take the URL we just copied and then just paste it into the browser right here. And we should then be able to see the create T3 app running on localhost, so our local development server. So it seems to be working just fine. Now the first thing I would like to set up are just the fundamentals, such as the database for example, and also just inserting the environment variables that we already know into the env file right here. So let's start by just inserting the environment variables. If we hop into the IAM right here, the IAM service from AWS, and then find the music generation frontend, we should be able to find the user we created and create an access key. So I'll say create access key, other, and press next. And this will just be frontend, and I'll say create access key. Then I can take this access key right here, and then over here I'll say AWS access key ID is equal to, then I'll paste it in. Then I'll also say AWS secret access key ID is equal to, and this will be the secret access key, like this. Then I'll just press done over here and continue. Good. I'm also just going to put in the AWS region like this, and this will be US East 1 for me. Otherwise you'll be able to see a region up here usually. And then of course also the bucket name, and that is going to be S3 bucket name. And this will just be music generation, I think it was called. So music generation buckets, like this. And then we can also just hop into the Modal dashboard over here and then find our URLs. So the first one is going to be this generate from description. That is the simplest one. I'll then say generate from description, and this would be equal to the following URL. I'll then also take this one with the described lyrics, generate from described lyrics. That is going to be equal to this URL, and then the generate with lyrics, so where you provide the lyrics yourself, is going to be equal to the last URL, generate with lyrics, like that. And that should set up the 3 URLs which we'll need to connect to. Then one more thing I would like to do actually is, instead of being inside this frontend project here, I would like to just open it up from the root folder, because I think that'll actually make it a little bit easier. So I'll go into open folder, hop into the root right here, where I can see both the backend and the frontend. I'll then open this up, and then in here I'll just close this down, close these down as well, and then I'll just open up frontend. And then if you click this package.json, you can see that the npm scripts appear down here, and then you should be able to just click that. So npm run again, and then whenever you refresh over here, it should work exactly like it did before. The only difference now is that we can see both the frontend files, but also the main.py over here, in case we would like to look at how the code works, etc. So that is pretty good to have right here as well. So one thing we definitely need to also set as an environment variable is the 2 Modal proxy keys down here, or proxy authentication. So we have this Modal key. I'll just go ahead and say, I'll do it up here, Modal key, and we'll also need a Modal secret. And that is again for authenticating the endpoints, which we did up here with the required proxy auth. So we'll just take these 2 values, paste them in right there, and also we'll paste it in right here. And then you shouldn't really have these 2 lying around hard-coded inside the code, so we should probably go ahead and remove these. And then over here, we'll just remove this as well, just so we don't get an error. And this way it won't really work, but we will at least not have this hard-coded inside our code, such that if we do push it to GitHub, for example, they won't just be lying around, and because that would be pretty bad. So now that is gone as well. And now we should be ready to go ahead and set up our database. So I'll just hop into the Excalibur quickly. I'll just remove these 2, this one as well. Hop into Excalibur here. And then inside the database, we talked about wanting to run 2 different branches. We have the production branch that the Next.js running application connects to, and then we also have a development branch right here inside the same project that we can connect to whenever we develop, such that if we change anything in the database whenever we develop, it won't affect the production environment at all. So first we'll hop into Neon, and I would really appreciate if you would use the link in the description, because it tells Neon that I sent you, and that really helps me out and lets me keep making these videos. I'll just search up Neon right here, Neon database, and then I'll press login. If you do not have an account, you can click sign up. It is completely for free, which is also one of the reasons that I use it for this video right here. I'll just go ahead and log in with my GitHub and then see you on the dashboard page. In here, I would like to first of all create a new project. So create a new project up here, and then I'll call this one music generation. I'll just pick AWS and then the newest Postgres version. And then for the region, because I'm in Europe, I'll just pick Frankfurt right here in Germany, but you can pick the one that is closest to you, or anyone for that sake. It doesn't really matter that much. I would just like to use the European one. Then I'll click create. And now we are able to see that we have our project up here, music generation, and then we can see the branch right here, production, and then we also have development branch. So we're able to go to tables, and then see the tables that are in each database. We haven't really pushed any tables to the database yet, so that is why it is empty, but we'll just use the development one for developing right now. So that is also empty. So we'll need to figure out the connection string such that we're able to put it in right here and then connect to the database. So what I'll do is I'll hop over here under connect. Remember that you need to be under the development branch such that you do not interfere with the production data. Then click connect right here, and then go under connection string, and then just say show password and copy this entire thing right here. Then we can paste it in under database URL under your environment variables like that. And this should be everything it takes for us to connect to a Postgres database. If we then just click the cross right here to close it down, hop under tables, we can then go into our npm scripts, and then I'll just close this down. If you then also go under Prisma and then schema.prisma, this is going to be the database schema. And as you see, it is very simple right here. We only have a single post and that is it. So this is not something we are going to use. I just want to really check the connection between our Next.js application and then Neon. So if you go under npm scripts right here, we can say db push, and that will run the npm run db push command. And this will then push the schema right here to our Neon database. And as you can see, that was done successfully right here. So I'll just go ahead and close this down and then refresh the browser over here. And now we're able to see this this post table over here, as well as the columns that is also specified within the schema.prisma. So now the database for the development is actually set up, and we know that we're able to connect to it. So any changes we make in here, we can just go ahead and run db push afterwards, and then they're going to be changed directly inside this development database, such that we can develop our application. Great, so now that is done, I'll hop back into the application that is running over here. I'll just close this down as well, and probably also this one, because we do not need that service anymore. And also this Modal one right here. Then what I would like to do is just set up a couple of more things regarding the environment variables. So if you open up this env.source.env.js file, what we're able to do is that we're able to take the environment variables in here and make sure that they're actually defined before we run the application, and also make them type safe whenever we access them. So what I'll do is I'll just make this split screen. So I'll do this, and then I'll take the modal key first of all, and then I would like to define that the modal key should only be accessible on the server, and that it should be available whenever we run the application, and that it should be a string. So I'll go ahead and do this both for the modal key, the modal secret, the AWS secret key ID, and also the secret key. I'll also just define the region, the bucket name, the description URL, the described lyrics URL, and also the lyrics or generate with lyrics URL. So let me just see what happened there. Good. And now we just need to define which one of these match each one of these. So what I can do down here is I can just say that the modal key can be accessed through process.env. And as you see, they are not type safe right now, but whenever we specify this up here, we are able to say env and then dot, and then access each one of these in a type safe way. And you'll see why a little bit later as well whenever we start developing the application. So we'll just need to take each one of these and then specify them down here as well. So the modal key is going to be the first one, and then below the modal key we can put in the modal secret, both right here and right here. Below that we can put in the next one. We can then also take the secret key right there and right there. Below the secret key we'll put in the region, and below the region we'll put in the bucket name, like that. Below the bucket name we'll just put in the last three endpoints, and that includes these two as well. So this one, and this generate with lyrics too, right there. So whatever we define inside, whatever environment variable we define inside this server property right here is only going to be available on the server, and whatever environment variable we define inside this client property is going to be available on the client as well, so that the user can actually see its value. So if you have any secrets, you do not need to put them inside this client, because that will make it unsafe. You only need to take the secrets and put inside the server property usually, because you want to hide them from the user. Another cool thing about doing this setup right here, and it is built in with the T3 stack, is that whenever you deploy the application to Vercel, the compiler is going to fail unless the environment variables are there, because they, as you see right here, they are required, and we also define that they are strings. So this makes sure that you don't really forget any of the environment variables, because if you do, it won't even compile. So that's another cool benefit of using the following approach right here. So now we have set up the environment variables, we have then also set up the database, or at least connected to it. So these are two very fundamental things. Next, I would like to set up BetterAuth. And the reason I want to set up BetterAuth now is because BetterAuth will make some modifications to the schema.prisma over here. And then as soon as we have set up BetterAuth, This will look a little bit different, and then after doing that, we'll be able to actually make some changes to the schema.prisma so that we can build some application logic around the current database structure. This also means that after BetterAuth, we can start by setting up Inngest. Inngest is, of course, the queue system which we'll use to send requests to the Modal backend as a background processing job. And then as soon as we have a connection between the Next.js app here and then the Modal backend, we will be able to build out the actual dashboard and then the application UI, logic, etc. So this is going to be the order with which we'll build the Next.js frontend right here, just so you know that. So let's get started with BetterAuth first, such that we can get this set up and then get the database working with the BetterAuth setup. So I would like to hop into BetterAuth and then just find this installation right here. Then I would like to select npm, and then down here we can select Postgres and then also Prisma, just so that will work. We'll then just npm install BetterAuth. So we'll need to open up a new terminal. So it's very important that you right click frontend right here and then open an integrated terminal, because this terminal is going to be opened in the frontend directory opposed to being in the root or in the backend directory, for example. So inside here, we'll put in npm install BetterAuth, and that will add the BetterAuth package to the package.jsons down here. So BetterAuth is going to be right here, and then it's going to install the library and then put all the library files under node modules and then BetterAuth right here. This means that we'll be able to import BetterAuth inside the frontend project now. So first, we'll need to put in this BetterAuth secret. So I'll just take this and then copy it in. I'll just do it right over the modal key, and then I can press generate here and then just take this entire value and paste that in right there. And then it looks like we also need to set a base URL down here. So the base URL is just going to be, I'll just wrap this in a string. So these should be the environment variables that we need to set. I'll just take these though and then hop into the environment.js and then set those in here as well. So I'll just make this a little bit smaller. Then we can take the BetterAuth secret and then just copy this right here and just remove the URL part. And I'll just also take the URL. Then down here, we can just copy this twice, put it in right there and right there. We'll then just take the secret as well, or sorry, the URL as well, and paste it in twice right there too. The next step, as far as I can tell down here, is then to create a BetterAuth instance. So we'll need to create a file named auth.ts in the library folder. So I'll hop under source and then create a new folder called lib for library. In here, I'll create a new file called auth.ts. Inside auth.ts, we'll just take this code right here and export it. So that is going to be all the code down here. And I'll just remove the following and just find out which Prisma we should import. So I'll just go ahead and remove this Prisma and then use db instead. And then we can see that it has already been defined under server/db. And the reason that it is already defined is because the T3 stack sets up this for us automatically. So we don't really have to think about initializing Prisma. It is already exported right here. This means that we can access the database anywhere in the server by importing db, and then we can say db.thetable.findMany, etc. So we can just say that we use the Prisma adapter for the database client that we have right here, and then we'll just need to put in Postgres instead of SQLite. And then going down here, we'll need to generate the tables that is required for BetterAuth to work. So the schema.prisma file is going to be amended. So I'll just go down here, paste in the npx BetterAuth CLI generate. Make sure that you are still inside this frontend folder right here though. So I'll just go ahead and run that. And then I'll say why, so yes. If I then hop into the schema.prisma, we're able to see both a user table right here that contains the user with the user's email, etc., and also an ID. We can also see a session, we can also see an account table, verification, etc. So that is required for BetterAuth to work. So I'll just close this schema.prisma down. I think I'll just remove this post because we don't really need that. And what we're then able to do is that we can say prisma db push, so run this command again. And this will then push the entire schema that was just created to the Neon database over here. So if we refresh, just to make sure that it is up to date, and then we are under the database and then the branch, we can then say tables, and then find the 4 tables right here: account, session, user, and verification, matching the tables defined in the schema.prisma file over here. So it seems to be working just fine. Great. If we then hop back over here to installation. We can then scroll down and we can see that we can specify the authentication methods. So you're able to authenticate by a bunch of different methods. You can sign in with Apple, Discord, email or password just regularly, and that is what we're going to do. And all of these different kinds of authentication methods down here. So these you can specify inside this auth.ts folder, auth.ts file, to actually allow these being used. So what I would like to do is first of all, just set up BetterAuth, and then we can decide on these later on. So I'll scroll past this authentication method and all the way down to mount handler. Make sure that you're under Next.js. We'll then just take this file and copy it. And we'll then need to make the following file, route.ts, under the following path. So if you go under app right here, I'll just close everything down, front end, source, and then app. You should then be able to right click, then say new folder, API. Right click, say new folder, auth. You should be able to right click again, say new folder, and then say square brackets, and then ... all inside of it. Inside this, we'll put in a route.ts file. We can then paste in the contents and just fix the import up here. So just delete this line, hover auth, and then press command ... to see this menu, and then press add import from libauth right there, because it'll import it from the following path right here. And then the next step is going to be creating this client instance down here. So this is going to be a file under auth client.ts. So I'll just copy the file's content right here. Then hop under library, say new file, call this auth client. That was completely wrong. Auth client.ts. And I'll then just paste it in right here. And then we have the base URL. And what I would like to do is just remove this base URL actually like this. And as we can see over here, that should then be it for setting up BetterAuth. So that is pretty cool. Now I just need to set up some of these authentication methods to actually get it up and running. So I would like to just close this, and this. And then we'll just hop into this auth.cs file right here. Then first I would like to just enable logging in with email and password. So I'll take this line and then just copy it in right below the database. So now email and password should be enabled. And then what I would like to do is just install a library. So I'll search for BetterAuth UI, because right now we are able to log in with BetterAuth and it should work, but we will need to create the entire login page, etc. ourselves. So I actually found this library called BetterAuth UI that is pretty cool, because it is allowing us to actually just reuse all of these different components that were just created by someone else. So by integrating with this library, we're able to use an auth card, use avatar, user button, settings card, and all these kind of cool things, which is just automatically being set up for us. So if we go into Next.js, we can see that all of these different things are being set up for us automatically. Sign in page, sign up, forgot password, sign out, settings, reset password. So all these things would take so much time to create ourselves, but we can just reuse something that somebody else created for us. So that is why I'm super hyped about this library specifically. I would like to just go into installation and then find the installation for npm. Then I'll hop under the front end directory and just install this. And we'll just need to close this down, because sometimes when you install something while the server is running, the server might not pick it up, so you'll get some weird errors whenever you continue developing. So I'll just go ahead and close it down and just install this and wait till it's done. Then we'll just need to go ahead and take this source annotation and just put it into our CSS file. So in our case, it's going to be globals.css. We'll paste this in up at the top. And then going down here, we can just hop into the Next.js integration. And then we'll just need to create this providers.tsx. So I'll just take this code and copy it. And then I'll hop under the components. So source, app, and then I'll hop under, actually I'll just create a new folder under source. So I'll say new folder, components, and then I'll say providers.tsx. In here I'll just paste in the contents, delete this line and fix the import. So I'll say command dot and then just fix this import. So add this import right here, save, and then that should be it for that file. That is just some boilerplate. And then I can see that we need to hop into the layout.tsx. So what I would like to do first of all is hop on the app, and then I'll create a new folder, and I'll use normal brackets right here. So just round the brackets, or parentheses, sorry, and then I'll just call this auth. And the reason is that I would like to use a specific layout for the auth routes and then also another layout for the dashboard routes. So we'll be able to create this grouping of routes within the folder without actually impacting the routes names up here in the URL bar. So I'll then take this layout, paste it in under auth over here, also the page. And then for the layout, we'll just need to add the providers it looks. So I'll take this providers and then just paste it in right here, right there, right next to the body, so right inside the body. So I'll then say add the import. And then over here, if I hop back, we can see that we also need to define the following page, app/auth, path name, etc. So we'll just do that inside this auth group. So we'll say we have auth, and then I'll just add new folder, call this auth. Inside here, I'll add a new folder again. I'll call this square brackets with path name inside of it. And inside this, I'll just drag in the page.tsx. So I'll put it inside this path name, like so. Good, and then inside this page.tsx, we can just put in whatever it tells us to. So I'll just paste this in. And then we need to define this view2, I can see. So that is probably right down here. Yeah, view.tsx. So I'll just create a new component inside of this called view.tsx, paste it in. And then we just need to import that over here. So I'll just go ahead and do that. And now it detects the import just fine. If we then just hop under npm scripts and say npm def, or run def, we can see over here that the newly created dynamic route covers the following paths by default. So because we put in this square bracket route, it is going to catch multiple different routes. So if you enter different different route segments, such as this one right here, that is a route segment, it will cover both the sign in, sign up, magic link, forgot password, etc. So it'll handle all of these different cases simply by putting in this path name and then these two boilerplate files that we just did. So let's just test these out and see what happens if we go to those. So if I say /auth/sign in, hopefully it should take us to something. So we see that we are taken to the route right here, but the CSS doesn't seem to work just right. So what I'll do is I'll just hop under the global CSS, and then it seems like this maybe isn't found. So we have both the styles and also the source, and then the node modules is in the same folder as the source. So we don't need to only hop one step back, we need to hop 2 steps back. So if I try and do that, go back over here, we then are able to see the styles like this. It still looks a little bit funky though, as you can see, and that is because we actually require ShadCN to be installed. So under requirements, it says you must have ShadCN UI installed. So I'll just open this up, hop over here, and then say get started, Next.js, and then we'll just install ShadCN here. I'll just select npm, copy that, and paste it in over here in the front end directory. And I'll just say y, like that, say neutral. Great, and then what I'll do is I'll just hop back in here actually, and then see what else is required. We'll need to install this Sonar component from ShadCN, so we'll just open this up as well. Then install the Sonar component. Good, and then if we hop over here and find the Sonar component, that is actually the one we're already at, we'll just need to put this inside the layout file as well. So hopping into the layout, we'll just right below this provider, right inside the provider actually, I'll put in Toaster, I think it's called, from components UI Sonar. So whenever we install a component like this, npx ShadCN latest add Sonar, what it'll do is that it'll grab the component from the internet, clone it down to a local machine, and then put it into this folder called components/UI/Sonar. So right here, instead of us having to create this ourselves, it is just being imported from the internet, which is pretty cool. So this means that this is just a component that we are able to use. We do have a small error up here. So what I'll do is I'll just say command dot and then see if we can just fix this. So we can just add this use type and save, and this should then fix the Sonar.tsx component. I don't really know why that error was there. Maybe I imported the wrong thing, but I know that this will work, so I think we're good. Cool. If we then hop back, we then also need both BetterAuth and Tailwind CSS, and those should be handled. So now if I hop into npm scripts, run def again, then hopefully we should be able to see it look a little bit better. If I go on Auth and sign in, we're then able to see the sign-in form, and it looks pretty decent now, I would say. I think it actually looks really great, especially compared to us not having to do anything. So if I just click sign up right here, it'll then take us to the sign up page. And we can actually also just try this forget your password. That works completely fine as well. And then because right now it is up here at the top, that's probably because the height of this body is just fitting to whatever the height of the content is. We can just check this by pressing F12, and then we can just see what the height is. So if we just see the body height is just the same as the content. So we can make sure that the body is actually the height of the entire screen by putting in a class name here. I'll say class name. Then I would like to put in minimum height screen, or small viewport height. And this unit right here, small viewport height, just represents the smallest possible viewport height, but also accounting UI elements such as address bars up here that might be part of a browser. So if I just click save now, then we can also just put in a flex, probably a flex column, just to send the things vertically. Then it should look like this on desktop and on this, and like this on mobile for these different views as well. Great. So I'll just go ahead and close this F12A again. And then up here, I would like to just say music generator, both for the title and the description, just so it says something different up here. We also probably want to change this favicon. We won't really do that right now. It's not super important, but just so you know, if you would like to change the favicon instead of T3, you can go ahead and replace the file called favicon.ico right here. And then you can just refer to the new file or just call the file favicon.ico still. Then what I would like to do is just to hop into the normal page. So I'll just go ahead and do this. And as you can see, we're still able to just navigate to this page right here. What I would like to do is just go under app and then create a new folder and then make another group of routes. And I'll just call this main. And this is just because these will be all the different dashboard pages. I'll then just take this page and also layout and then paste it into main right here. Or sorry, just move them into that. This means that if we just refresh over here, it should look exactly the same. And then on the page, what I would like to do is just remove all of this inside main and just put in a paragraph and say dashboard. Cool. So this is where the dashboard is going to be within. Then I would like to hop in here and then say const session. And by the way, the reason that we're doing this right here is because, as you probably noticed, we shouldn't really be able to access the dashboard unless we're logged in. And right now we're definitely not logged in. We don't even have a user. So I'll just say const session is equal to await. And we'll just need to make this async. So we'll await auth. We can import that. Dot. We can then say API. Dot get session. And then we can say headers. Await headers like that, and this will need to be plural, and this will just need to import from Next. What we can then do is we can go ahead and say if not session, then we'll redirect and we'll say auth and sign in like this. So if we are not logged in on the dashboard page, so on this page right here, we'll just redirect back to this auth/sign in such that the user can actually authenticate. So right now, if we actually hop into the dashboard page, press enter, we are immediately taken to this auth/sign in. And the reason we are taking so fast is because this all happens on the server. This is a server component because we don't have use client on the top, and it is an async component. So the client won't even know that it is being routed to this place actually. It's just being redirected straight away to auth/sign in, meaning unauthenticated users won't even be able to access this page. Cool. If we then hop into sign up and then try and create a user, what I'll just do is I'll just keep Neon open up here just so we can see the tables. So I'll just hop under user, and then right now we have 0 users. But if I go ahead and say Andreas, and then I'll say test, I'll just say Andreas actually at gmail.com. Then I'll say password 123 like this. Then I'll create an account. This will then immediately redirect us to the dashboard, and now we're actually able to access the dashboard, and that is because we're logged in. So if we check the Neon dashboard over here and just refresh that, we are able to see that we have a user in the user table. So we now have a new row in the table We have the name Andreas, the email, an ID. We also have created that, etc. Then we also have accounts, session, verification. We don't really need to worry about neither the account, session, or verification, only the user table right here. But it is pretty cool though, because now we're able to create users and log in, and this was really fast, right? So as I explained before, after creating this simple BetterAuth integration, we'll be able to actually form out or shape out the data structure of the schema over here, such that we can get started with the Inngest integration. Before we can start with the Inngest integration, I'll just go ahead and create some more tables such that the database is ready for what we're trying to do with it. This, for example, is making sure that the user has a credits field right here, such that we can check the user's credits and also deduct credits whenever a song has been generated. We'll also need to create a table for storing the actual songs and their status, for example. So what I'll do is I'll just take this and make it much smaller. Then I'll say Command P, open up main.py. Inside this main.py, we can just make it split screen. I'll just take it over here maybe. And the reason I want to make a split screen is just so we can see these different properties that we are able to pass into the endpoints. Because that is pretty important, because I'll store some of these inside the database as well whenever we create a new request for actually creating a song. So the first change I would like to make inside the database here is actually giving the user a credits field. So I would like to say credits, and the reason is that I would like to use a credit system for making sure that the user doesn't make more more songs than he is supposed to. So this is going to be an integer. So I'll say integer with a capitalized, and then I'll say add default, and I'll then say 100. This means that whenever you create a new user, this field will be initialized to 100 per default, starting the user off with 100 credits. We can then create another table down here, so scrolling all the way down, I'll then just go ahead and say, I'll actually just do it up here just so we can keep them closer. I'll just say model, and every model that you create is going to become its own table within the database. So I'll say model song. So each song that we're trying to create will be a row inside a table called song, and a row can either contain a song request, or a failed song, or a song that is processing, or a song that is finished, and that also contains the S3 keys to where it stores the actual song and thumbnail, such that we can access it. So we'll need quite a lot of properties for this one, or columns. We'll need an ID that will be a string. It is going to be an ID with the default value of a COID. So just kind of like a UUID basically. So we'll go ahead and do this. We'll then say that a song is going to have a title. A song should also have an S3 key. And we'll make the S3 key optional. And the reason is that whenever you create a song request, the S3 key is not there because the song is not being created yet. So this is going to be null until the song has been created. And then the song's actual S3 key is going to be set within this column. We'll then just say thumbnail S3 key like this. And this will of course also be a optional string because that is the same case as for this one. Beneath this we'll say status. We'll then say string. And then I would like to store some kind of status for whether we are currently processing it, whether it failed, whether it is finished, etc. So I'll just say default, set the default value to queued. This queued value is just meaning that we haven't really started processing the video yet. It is just there waiting in the queue. We'll then just set the different flags that we defined over here, such that a row in this table actually marks a request that we can then use to call one of the endpoints. So I would like to first of all say instrumental. So I'll just copy this right here. Instrumental should just be a boolean, and we'll set the default value to false. Beneath instrumental, we'll put in a prompt. The prompt should be a string. We'll just make that optional. We'll also put in the lyrics. That should also be an optional string. I'll just start copying these lines. So beneath lyrics, we'll put in the full described song. The full described song is going to be for the endpoint down here. So all the way down, generate from description. We'll then have this full described song. So beneath this, we can go ahead and put in described lyrics. If we have a case down here where we pass in the described lyrics, we would also like to put in another property that is going to be the guidance scale So this is one of the ones that is shared between every request. The guidance scale right here. The guidance scale is a float, so I would like to put in float. Beneath the guidance scale, I'll put in the infer step, and then beneath this, I'll put in the audio duration. Beneath the audio duration, I'll put in a seed. Beneath the seed, I'll put in published, because I would like users to be able to publish songs. So I'll just say published, make this a boolean, set the default value to false, like this. So this means that if the user clicks the publish button, it is going to be set to true, meaning that we will actually show the song in the dashboard for other users whenever they open the dashboard. As you probably remember from the intro, we are also going to set a listen count. So I'll say listen counts. This is how many people have listened to the song. We'll set this to be an integer, and the default value should obviously be 0, like that. And I'll then just also set a likes, and likes should refer to another table, which we'll also just create in a second. So we have a many-to-many relation between users and then likes, between users and then songs, because one user can like multiple songs, but one song can also be liked by multiple users. So that is why we'll need to create this intermediary table between these. So we'll go ahead and say model likes, like, and then for many-to-many relations, you often have to create a joining table between these. So we'll go ahead and say user relation fields user ID. We can then also say references, the ID, and on delete, we'll say cascade, like this. Beneath this, we'll then put in a user ID, which is a string. I'll then just take these two lines and copy them down below. I'll call this song, and I'll call this song ID, and this should be song ID, and this is good. So this now means that for every single like that a user gives a song, we'll create a new record inside this model, this like table right here. And this will then allow the many-to-many relation where a user can like multiple songs, and a song can also be liked by multiple users. Good. So now we'll just need to say like right here. And I'll just need to create something down here. I'll need to say add ID, user ID, and song ID. This means that a like is going to be identified by a compound key consisting of a user ID and a song ID. This means that we can't identify a like row only by the user ID or only by the song ID. We'll need both a user ID and a song ID to identify a row from this table if we would like to get one of those out. If we then hover this up here, we can see that we don't really have this defined in the user. We have this likes set inside the song. We'll just need to set it for the user as well. So we're going up to user, we'll just set likes here as well. This means that a single user can have multiple likes, so the single user can like multiple songs. That is why it is an array. But a song can also be liked by multiple users. That is why it is an array down here as well. And I can also see that we actually put in user right there, where it was supposed to be song. We can then also make sure that a user owns an actual song. So we'll need to create a relation between song and user. This will be a one-to-many relation because a user can own multiple songs, but a song can only be owned by a single user. So down here we'll say we'll say user. This will be of type user. And I'll actually just copy the same as we did right there because it is completely the same. And then we'll also need to go up to user and then say songs. And we can then say song to annotate that this is actually a one-to-many relation. A user can have multiple songs because it is an array, but a song can only be owned by a single user. Then I would like to just make sure that we know when a song is both created and updated. So I think I'll be able to find somebody who did it down here maybe. No. Well, what I'll then do is I'll hop over here in the song table. Then I'll say created at. This will be a date, time, with the default value of now. I would like to also say updated at. This will just be a date time as well. And I'll just put in this updated at annotation, which means that every time this record, any record in this table is updated, the timestamp for that update will then be stored within this column right here. And then also, because we'll very often fetch songs by the S3 keys, what I would like to do is hop down here and then say index, and then create an index on that S3 key such that we're able to get them out faster. And then, as you probably remember over here from main.py, if we scroll down, we see that we had this method for generating different categories, and these categories are then going to be a list of comma-separated tags. So for example, electronic, sad, 80s, etc. And we'll need to store these over here in the database whenever they get returned to us from the Modal backend. So I'll just create a table for storing those. I'll say model, category. And this is also actually going to be a many-to-many relation, because a song can have multiple categories, but a single category can also be used by multiple songs. So we'll try and create the many-to-many relation in another syntax, which you can just see which one you prefer. So this one, we'll go ahead and say ID. I'll just copy this one up here actually. I'll then say ID, and then go ahead and just create an ID for this one. I can then say name. So a category should have a name that is a string, and this string should be unique, like this. And the reason it should be unique is because we only want a single row per category within this table, which means that if we have rock as a category, we don't want 10 different rows saying rock, we only want a single one saying rock. This is why we make it unique. Next, we can go ahead and say songs, and then we say song, and make this an array to let it know that this is a many-to-many relation, or at least a category can have multiple songs attached to it. Then up here, we can also go ahead and define the categories. So we'll say categories, and then we'll say category, and make this an array as well. So because we have an array both here and also down here, this is going to be a many-to-many relation. I think this is what you call an implicit many-to-many relation, because you don't define the table like you do right here explicitly. So the syntax is a little bit cleaner, but you also don't have this explicit way of defining it, where you can also attach even more properties to the rows or to the many-to-many relation if you would like to. So for example, right here, if we do this notation where we make it implicit, we won't be able to say like that, for example, and put in a date time. So, but if we do with this explicit notation, we'll be able to store additional information per many-to-many row. So that is the difference between these two syntaxes. Cool, so that was the data structure that we're going to use for the database. As you can see, it wasn't that bad. We only have a few tables. We have the song, then we attached a couple of properties to the user, such as the credits and the relations to likes and songs. Then we also created the categories and the likes right here. So it wasn't that bad, but this is actually all we need to be able to build the software as a service application, as you saw in the intro. So I'll go ahead and go over here, then find npm scripts and say db push. And this should then push this entire new schema to the development branch over in the Neon database. So if I refresh the tables here, we should be able to see both the user, category, like, song, and also category to song, because it is a many-to-many. So we have a category with the many-to-many with the, let me just find that song up here, right there. So because we have an implicit many-to-many relation, it's just going to be called category to song, whereas if you have an explicit one, you can name the table whatever you would like, such as like we did. And then one thing you might have noticed is that because we made some updates to the user without actually recreating the user, and by that meaning deleting the user and then creating one again, what would then happen to these properties that we added? So if we go on the user, we can see that this credits field was added right here, and 100 credits was added to the user's account immediately. And the reason that the database push didn't fail right here is because we set a default value for the user. So we set default right here. Had we just done this and then pushed it, it wouldn't have worked, because then the database wouldn't have known probably how many credits to give to the user. Maybe it would have just given 0, but usually you'll need to set a default value like this if you would like to change an existing database table by adding new columns, for example. But we can also then see under user that we have the relations now. We have a relation to the likes table. We have relations to songs because we can own multiple songs. And under category to song, we can see that we have an ID for a category and an ID for a song, meaning we can make a many-to-many relation. So what happens right here with this implicit category to song many-to-many relation is the exact same thing as we did down here with the explicit one. We store the user's ID and the song's ID. Over here we just store the category ID and then the song ID. Cool, so with that out of the way, I'm going to go ahead and close down schema.prisma, then hop back into our application over here. I'll just close this one down, and then just clean up all of our tabs over here as well. I'll just close down these different ones, like this. Now we can then get started with the queue system, such that we can create a link between the front-end application right here, the music generation application, and then also the Modal backend. And as I previously explained in the calendar as well, we're going to use Inngest for this. So I would really appreciate if you would use the link in the description for accessing the website, but I'll just hop in here and search for Inngest. And then I would like to go to the documentation, so I'll just hop under docs right here, and then we'll find a quick start guide for Next.js. And then what we'll do is we'll just scroll down and then first of all install Inngest. So I'll open up my terminal once again. I'll just open up a terminal right here. And then we'll make sure that we are inside the front-end directory, and then we'll install Inngest, npm install Inngest. And then after doing that, we should be able to run the local Inngest server. So we won't really need to connect to the production server or development server running on Inngest infrastructure to start off with. We can just run a local development server. So this means that we do not even have to create an account before even starting. So that is pretty nice. I'll just go ahead and take this and close it down, and then just start the Inngest development server. And then I can also start back up the server right there. Good. So now we just need to set up a couple of things before the Inngest development server will be able to connect to our actual Next.js application. And that is what you'll see down here. So first of all, we'll need to hop into source. And then I'll create a folder under source called Inngest. In here, I'll create a new file that is going to be client.cs, and we'll then copy the contents of this file right here, and then call it music generator, like that. Then we also need to create an API route. So it says app, API, ingest, and route.ts. So I'll go up under app, and then I'll find the API, and then right here on API, I'll right click, new folder, ingest. And then I would like to create a route.ts, and we'll then just take all the contents and copy it in right here as well. And then the ingest functions, which we'll define later, so that is all the steps I explained in the theory, we can put in right here to register them as our functions. Cool. So we'll just scroll down and then create a function. So under source ingest, we'll just create a new file called functions.ts, paste this in right here. And then I would like to just call this generate song. And I would like the event to be called generate song event, like this. Then I'll just call this process, or just generate song, like this. And then we'll need to go down and add it to serve right here. So we'll hop back into the route.ts and then register our function generate song. We'll just import this as well. So I'll say command dot, and then we can import it right here. And I'll also just save this one. And then if we scroll down further, we see that it is now time to run our function. So going down, we should be able to see something inside the Inngest dashboard now. So if I just copy this URL and just paste it in right here, we can then see that we have our Inngest development server. And then under apps, we can see that we have the app music generator that connects to our Next.js application under API ingest. So that is the route that we configured right here. API ingest and then route. So that all happens automatically. And then we can just test it out. So if I just hop back in here, I think we should be able to just trigger a run. So we can find our specific function. Let me just see why I left that out. I'll just open up the ingest again. Then if we go under functions, we can then invoke the specific function. So inside a function, as I explained in the Excalibur, we'll have a series of steps. So we can then invoke these steps with an event. So I'll just go ahead and invoke it like this. And then we see that it is running and that it is completed. So that is basically what we do whenever we create a queue. And when we then click this invoke button that we just clicked right here, we then add an event to that queue, which will then activate the function that we just defined inside functions right here. So the idea is then that whenever the user inside our dashboard clicks create a new song or generate a new song, an event is going to be added to the queue. And this means that it is going to be, this function right here is going to be invoked automatically. And this will then call the Modal backend and then create the song for us, etc. So let's get started by shaping out how this should look. So I'll just go ahead and remove these two lines right here because we don't really need those. And then first of all, I would like to get the information from the event. So I'll just hop back into the XColorDraw to explain. So I'll hop up here. So as you can see, each one of these events in the queue, so each one of the elements in the queue contain both the prompt, the lyrics, the instrumentals, etc. And the way we're able to get these different parameters out is by just letting each event contain the ID of a song in the database. This means that inside this function, we can then query the database for that specific song that we want to create, and then get these out, which we can send to the Modal backend. So I would like an event to both contain the song ID of the song that we're trying to create, but also the user ID. So I'll go ahead and say const song ID, and then I'll say is equal to events.data, and then I'll say as song ID string, and I'll say user ID string like this as well. So we have the song ID, which we can use to query the database, and then the user ID we'll use a little bit later to manage concurrency for the queue. I'll get back to this whenever we have finished implementing the function, so it is just so you know that we are actually going to use it in the future. Good. So I'll just make this a little bit larger again. And then right below this, and by the way, this event.data is what we receive from the actual queue element. So hopping into XColorDraw, each one of these queue elements, so both 1, 2, etc., will then contain an event.data. So each one of these will contain some data which we can use to do something within the function. So that is basically why we're able to get out some data from each one of these events. And the way we also create these events is by putting an element into the queue, and then each one of those elements should then contain some of this data which we require in the function. Good. So the first step that we're going to create is going to be checking the user's credits, because if the user do not have enough credits to generate a song, we should just set the status of that song to be failed or not enough credits or something like this. So I'll go ahead and say awaits, and then I'll say step.run, and then we'll define a step called check credits. And then inside here, we'll just define an async function. So we'll just do this. Good. And then what I would like to do is just say const song is equal to awaits. Then we can say database import that dot song dot find unique or throw, because if the song with this ID is not found, then we shouldn't do anything further. We should just throw an error, because then we didn't pass in a correct song ID. Cool. We can then say where ID is equal to the song ID. So that is the song which we're looking for. And we can then select some specific columns from that row in the database. So I'll say select. And first of all, I would just like to select a couple of things from the user. I'll say select, user, select. And from the user, I would like to select the ID and also the user's credits like this, such that we can check the credits. And then since we're already making a call to the database, we might as well also get all of these properties out right here, the prompt, lyrics, instrumentals, etc., which are stored within the table. So if I just hop on the song right here, so those are stored over here. We have the lyrics, the prompt, etc. So all these different parameters that we're going to send to the Modal backend. So instead of making two different database calls, we're just going to make a single one where we get everything out. So under user right here, we're going to select some specific columns from the song row. So we'll then say we at least want the prompt. We also want the lyrics out. We also want the full described song. And I'll just copy this line. We also want the described lyrics. I would like the instrumental flag, guidance scale, and then the info step, the audio duration, and then also the seed like this. So these are the parameters that the Modal endpoints expect whenever we send a request for processing or generating a new song. Then inside the same step right here, I'm also going to define a couple of other things. So right beneath this database query, I would like to just create a request body that we will be able to send to the endpoint for Modal. So I'll just find the main function first of all, and then we can just see all these different parameters. So expect all of these different ones. So I'll just make it in another page. Cool. Then we can go ahead and say let body be equal to, and it'll be of type request body, like this. And we'll just have to go ahead and define a request body. So right above, we'll say type request body, and the request body is what we're going to send. So it's going to be either this one, or this one. So we'll then go ahead and say is equal to, and we'll have the guidance scale. I'll just scroll up, copy it. We'll have the guidance scale. That is going to be an optional one with a number. Like this. And then below that, we also need the in first step. We also need audio duration. We also need the seed, like this. And below the seed, we also need the full described song for this one, for example. And then we also need the prompt, the lyrics, and we need the described lyrics. I think they're somewhere here as well. Like that. And lastly, we need the instrumental flag. Actually, I just forgot that. Cool. And then we of course need to just change the types. So this is going to be a boolean. This up here is going to be a string. And the same for both the lyrics and also the prompt and the full described song. And I think that should be it for the request body that Modal expects over here whenever we query the endpoints, or sorry, make a request to the endpoints. Right there, for example. Great. So now we can actually go ahead and initialize this request body based on whatever we have fetched from the database here. So I would like to first of all say const common parameters, like this, is equal to, and then the common parameters are going to be the guidance scale. So the guidance scale, this will be song.guidance scale, or undefined, like this, if it is not set. Then we're also going to need the in first step. That will be song.inFirstStep, or undefined. And I think we'll just need to make this comma separated. And I'll just close this down. Then below this, we'll need to put in the audio duration. And then below this I'll put in the seed as well. And below the seed, I'll just put in the instrumental flag. That is the last common property that is shared between all of these different ones. And the audio duration, it says, did you mean audio duration? And I think I just need to make this camel case instead, like that. Now we can then create the body for the specific endpoint that we're trying to call. So the reason that we even do this in the first place is because a single song, so if I just hop into the neon right here, a single song right here contains multiple properties such that it can both be a request for if you only provide the description, or if you provide custom lyrics, or if you provide both described lyrics and then the prompt. So we can handle multiple different endpoints with a single row right here. So we therefore need to determine which endpoint that we're trying to call, and then also what properties we should actually send to that endpoint. So that's what we're doing. And the reason we have this common parameters up here is because this common parameters will be common for all of the endpoints, so we can just reuse this regardless of what endpoint it is. So we have four cases down here. We have the case where the user provides the description of a song, like this. And then we have the case right below this, another else if statement where the user provides both the lyrics but also the prompt. So this is going to be the custom mode. And then below this, we're going to have the custom mode where the user provides the prompt and then the described lyrics, like this. So first, the way we can determine if the user is just providing a description of a song is just checking whether this full described song is there or not. So we'll just go ahead and say if song.full described song. In that case, the endpoint which we'll call, and I'll just create a new variable for this. So up here, I'll just say let endpoint be equal to an empty string. And then down here we can redefine that. So we'll then say endpoint is going to be equal to environment variables from this import right here, dot, and then we can say generate from description, like this. And the body which we'll send to that endpoint is then going to be the following. So I'll say body is equal to full described song. That will be the song dot full described song, and we can then take all of these common parameters and then destructure them out into the body, because that is going to be needed regardless. So the only thing that makes this endpoint right here different from the other endpoints is that it just has this full described song. So that was the first case. The second case down here is going to be an else if. So I'm going to go ahead and say else if song.lyrics. So if the lyrics are provided, then we'll say endpoints is equal to env dot generate from description, and then I'll say lyrics as well. And I actually also just want to make sure that we have the prompt as well. So I'll say if song.lyrics and prompts, then this will be our endpoint, and I would like to create the body that should be lyrics song.lyrics, and the prompts should be song.prompts, and we can then destructure the common parameters out like we did before. Cool. So the next case is if we have the describe lyrics. So in this case we'll say else if song.describe lyrics, and in this case what we'll do is we'll say endpoint is equal to env.generate with describe lyrics, and the body, which I'll just copy from up here again, is going to be the following. We'll have described lyrics, that will be described lyrics like that, and then we also have the prompts. So I'll just go ahead and say and song.prompts like this. And then what we can do is we can go ahead and say return from this step user ID, that will be song.user.id. We can also return the credits, that will be song.user.credits. The endpoint is going to be the endpoints, and the body of the request which we'll send is going to be the body, like this. Cool. So if we just walk through what happens here is that we create this step. So this is a single step, and that does some code, that executes some code, and then it returns something from that step. So we're then also able to destructure, catch whatever it returns up here. So we can just say const, and then user ID, and we can say credits and endpoint, and we can say body is equal to, like that. Cool. So this means that the 4 variables that we returned from the step is going to be accessible within other steps. So walking through what just happened, we first of all do this as the first thing inside the function, such that we can check the amount of credits that the user has. Then we'll use the song ID to query for that specific song in the database over here, in the Neon dashboard, in the Neon database. Then we'll select the user's ID and the user's credits. We'll then also select the things required to actually create a song, so that is the prompt, lyrics, full described song, etc. Then we're going to construct the body for whatever request we're going to make based on which ones of these are available, because a row can contain some of these or a mix of these depending on which song we're trying to create, so which endpoint we're trying to hit. Then down here we'll find out what endpoint that we're going to hit, and then also what body which we'll send to that endpoint. So we have some common parameters that are the same across every single endpoint. Then we also have some custom parameters that are that needs to be set depending on which endpoint we're trying to hit. So we then determine the endpoint that we're trying to hit based on which ones are available or not. So if the song.full-described song is available, then we'll add that to the body and also destructure all the common parameters into the body. And now we then have everything we need. We both have the endpoint to send the body to and also the body itself. And then we do this for every single endpoint, so the 3 endpoints which we defined. And we then return this information back such that we can actually make the request later on. So after this step up here, I'm going to do something else. So I'll just scroll down right here. And then I'll actually make sure that nothing happens if the user does not have enough credits. So I'll say if credits is more than 0, well then we're going to actually generate the song. We can then say else. And I think we just need to actually move this outside of this parentheses right here. Cool. Else we're going to go ahead and set song status not enough credits. And let's start with doing that. So if the user does not have enough credits, we'll create a new step, await step.run. And we'll call this set status no credits. And then we'll say async. In here we can say return awaits database.song.update, And we already know the ID of the song. So we'll say where ID is equal to song ID. And I would like to update the field status and set that to no credits, like this. Cool. So now we know in the database whether the user has any credits or not. And then also the reason that I actually return something from each step is because inside our function invocations, we'll then be able to more easily debug. So if you return something, you'll be able to see the returned output of each step right here. And this way we can debug what actually happens in each step compared to just seeing nothing as we do right here, for example. So that is why I usually return something from a step, just simply so we have an easier time debugging. Cool. So if a user have enough credits, we'll first of all set the status of the song to processing. So I'll just copy this step right here. And then I'll say set status processing, like this. And then I would like to set the status to processing. Cool. And this should then show the dashboard or let the dashboard know that now you can actually show that the clip is being processed compared to it just being queued, as is the default value for a given song. So let me just find the song. I think it's maybe all the way up here. Yeah, so whenever you create a song for the first time, the status is going to be queued. When we then create the actual song or start queuing it, we'll then set the status to processing. So not when we start queuing it, but when we start actually processing it. This way we can show in the dashboard whatever the status of the song is. And now I would say that we're actually ready to call the Modal backend. So we can go ahead and say const response is equal to await, and then we'll use something called step.fetch. Then we can say endpoints. We would like to make a post request as we defined as our endpoint. We'll then say the body is just json.stringify, and then we pass in the body which we already constructed up here. So this is just going to be the body. We'll also pass in the headers. The headers are going to be content type. And then because we are sending JSON, we'll need to say that the content type is JSON. So we'll say application JSON. We also want to send the modal key, because remember we created these proxy auth tokens such that nobody can hit our endpoints besides us. So we'll need to send these authentication tokens. This will be env.modal key, and we'll also have a modal secret. This will be env.modal secret, like this. And then what does this step.fetch, you might think? Well, we can just go over here to Inngest docs and then find out what it actually does, or I can at least visualize what it does, because it is pretty cool. So if we go over here and then find step.fetch, I think it is one of these articles that are in the top. So maybe if we go into the blog, I think we should be able to see it because it's pretty new as well. So we'll just go and find the step.fetch down here. Great. So this is what it actually does when we visualize it. So each one of these steps over here, so this step right here, and also this step right here, and also this step up here, will run as a serverless function whenever you deploy it to Vercel. But with Vercel has these function timeouts. So this means that they can only run for maybe 30 seconds at a time before they will time out, because it is serverless. And this is quite annoying because whenever you want to do AI inference, you might wait maybe a couple of minutes before the AI inference is done. As we saw earlier when we tested it, it took about 2 minutes to generate a 3-minute long song. So this means that we would hit these serverless timeouts if we were to just use the regular fetch. But whenever we use step.fetch instead, what we'll do is we'll offload the waiting time to Inngest's platform instead of having to actually wait on our own, inside our own serverless function. And this also means that we won't really hit these serverless timeouts as we would if we just use the regular fetch like this. So all waiting for the request to finish will then happen in the Inngest platform instead of in our local serverless function, and that will just solve this massive problem for us. And that is actually pretty big when working with AI, because I've run into this before, and then you would have to work around it in some weird ways. Cool. So now that we know what step.fetch does, we can just hop back. I'll just go ahead and close this down and make this smaller again. So after waiting for the modal endpoint to finish, we can go ahead and just get the response that modal returned from us, and that's going to be the S3 key for both the song and also the thumbnail, along with the categories. So I'll just go ahead and create a new step. So I'll say await step.run, and then we'll say update song results. Because remember, now after waiting for the endpoint to finish, we actually have the result of the AI inference. So we'll go ahead and update that in the database. We'll then say async, open up a new function, and I can then first of all just check the response that we got, because this is an HTTP response. So I'll go ahead and say const response data is equal to if the response dot okay. So I'll say response dot okay, and I think it's because we are missing an S up here. In that case, what we'll do is that we'll await response dot JSON. So we'll get the response as JSON, and then we'll just set a type for it as well. So I'll go ahead and say S, and then we already know the type. The type is going to contain an S3 key. It is going to contain, this will be a string. It is going to contain a cover image S3 key. This is going to be a string, and it is also going to contain the categories, and this will be a list of strings. If I just open up the main, we can just check what the actual names are, because these were just off the top of my head. So up here we have the S3 key, the cover image S3 key, the categories, and the types match perfectly fine as well. Good. Then if the response is not okay, we'll then need to define that as well. And in that case, we'll just set the response data to null. Good. So now we actually have the response as structured data, which we can put into the database. So I'll go ahead and say awaits database.song.update, and then I'll say we'll update it where ID is song ID. And we can then say data S3 key. This will be response data. So I forgot an S again. That's kind of weird. I'll then say response data dot S3 key. And then what we can do is we can say thumbnail S3 key. That will be response data dot S3 key. Sorry, the cover image S3 key. And the status will then also just need to be updated. So this will be response.ok. If the response.ok is true, then we'll set it to processed, so it is done. Otherwise, we'll set the status to failed. And you probably noticed that we didn't really insert these categories. And that is because we have a many-to-many relation for the categories. So the categories right here, that is a many-to-many relation. So you'll need to insert into that table as a separate query. So I'll just do that below. I'll say if response data dot categories dot length is more than 0, like this. And I'll also just say if response data and response data, like this. Good. Then what we can do is we can say awaits database.song.update where ID is song ID, and we can say data categories connect or creates. So if the category already exists, we'll just connect to it. Otherwise, we'll create a new category. Then I'll say response data dot categories dot map, then create a structure of the categories we would like to insert. I'll say category name. Then I'll say where name is category name, and creates name category name like this. And this will just need to be category name right there and right there as well. So we'll create a relation between a song and then a category where the category name is the category name right here if it already exists, and if it does not exist, we'll just create a new one as we mark right here. So these are the two different options. So that should take care of actually creating the categories as well. And now that we have saved the response from the Modal backend, we can go ahead and move on. So the next thing I would like to do is just deduct the credits from the user. So I'll say return awaits step.run. Then I'll say deduct credits, because now after the user's song has been created, we can then go ahead and deduct the credits. So I'll say async and then make a new function. I'll then just say if not response.ok. Then we'll just return and do nothing. Otherwise, we can go ahead and say await. And I'll just return here for debugging. Return await database.user.updates, where ID is user ID. And we can say data credits. And we can then use this decrement option from Prisma and decrement by 1. So whenever we run this function, we'll create a single song, and we'll also decrement the user credits by 1. And as you saw up here, we only do this if the user has more than 0 credits, meaning the user's credits can never go below 0. So that is pretty nice to know as well. And then in the Excalibur over here, I also talked about limiting concurrency. So over here, we say we'll limit concurrency to 1, meaning 1 event can be processed at a time per user. So let's say the user has 1 credit left, and then the user queues 10 different ingest items, meaning the user clicks the create new song 10 times in a row. Well, in that case, right now 10 different songs would be created, and then the 10 credits would be deducted afterwards because they will probably just be ran at the same time, these different function runs for the user. And this means that the user would be able to get more songs that he actually has credits for. So we'll just make sure that the user can only create a single song at a time, both because of that, and also just to make sure that the user just doesn't create a bunch of songs at a time. And then if every user does that, the system might be a little bit overloaded. So we'll just avoid that by controlling the actual concurrency of the queue. So I talked about the user ID earlier. So the event.data contains both the song ID, but also the user ID. And we can then use this user ID right here to limit the concurrency based on that user. So for each request, we'll then use the user ID to limit how many requests can be processed by this user ID at a time. And the way we do this is that we go up here next to ID, and then I would like to put in concurrency and set the limit to 1. And the key which we're going to use is going to be event.data.user_ID. So that is going to be event.data.user_ID down here. And then one more thing I would like to define as well is that we can say on failure like this. This will be an async function, and I think we'll just need to move it inside right there. On failure is an async function that will receive an event and also an error. And then if we see an error happening inside here, and then it won't be able to be fixed within the retries, then we'll say await database.song.update, where ID is events.data. And I think it's events.data.songID. And we'll just need to put in optional chaining like this in case any of these are null. And then what we'll do is we'll say data status is failed like this. This way, if anything fails down here and Inngest isn't able to just retry the steps and make it work, but it actually fails for real, then we'll just set the status to failed just to show that in the dashboard. Cool, so looking over at the Excalibur drawing right here, right now we have made the backend endpoints that will actually make the song and also the thumbnail whenever it is called. We have also defined the trigger that will then run through the steps of both calling this endpoint and also updating the database with the response. We have also created the queue itself, but now we need to create the logic that actually inserts the event into the queue. So first of all, just to test it out, what I would like to do is just create a simple button right here in the dashboard. And whenever we click this, we'll insert a single element into the queue just to test out that it works end to end and actually generates a song. So I would like to first of all hop into the dashboard. So that is going to be, let me just close all of this, front end, source, app, and then main, and then the page right here. Then what I would like to do is just create a new component that we can import. So I'll say creates.tsx. This will be a use client. In here we can say export defaults function, and then it's going to be something like creates a song, and it's going to be like this, and we'll just return a symbol button, and this will just be a normal button. We'll just import one from ShadCN actually, so we'll say ShadCN button and just install this button. So if I open back up my terminal, we should be able to just open up a new one in front end here, install the ShadCN button. Good. And then we can import it up here luckily, or hopefully. Then we can say on click, and then we'll say generate a song. And then we'll just need to define the server action that happens whenever we click this button. So we'll just leave it empty for now. If we then just hop back in to the dashboard right here, we'll need to import that. So I'll say create song, import the button, and now we can see the button generate song. If I click it, nothing happens because we have set the on click to just be nothing. But we'll just create a server action that will hook this up to the backend. So I'll go ahead and hop under source, and then we'll say new folder, actions. In here I'll create a new file called generation.ts. I'll then just say use server to make sure that it only runs on the server. And then I'll create a new function called queueSong. So I'll say async function queueSong. And this queueSong should then receive some parameters corresponding to what the user types in here in the dashboard. So for example, if there's an input field like here as you saw in the intro, and the user types in the prompt and also the lyrics and then sets instrumental to true, then those values is what we're going to receive in the parameters right here. Right now though, we're just going to test it out, so we'll just leave it empty and then just hard code the values. So I'll go ahead and just import this and then just export this function. So export async function, import it over here. And now this button should be hooked up to the server action and actually do something on the server. So over here we can go ahead and move on. So I'll just say const song is equal to await database, which we'll need to import, dot song dot create, and we'll create a song with the data user ID, and the user ID we're able to get from the session from BetterAuth. So we can say const session is equal to await auth. So we'll import that dot, and then we can say API dot get session. We can say headers is await headers like that, and we can then just say if not session, then we'll just throw a new error unauthorized or something. We'll just actually do the redirect as we did before. So I'll just go ahead and take this redirect and do the exact same thing over here. Good. So we'll just need to import the redirect, call this headers, and then down here we can then say user ID should match session.user.id. The title of the songs we're trying to create should just be test song 1. I'll then set the prompt to be hip hop song, and I would like to set the lyrics to just be, and to make it easy for ourselves, I'm going to actually just use the full describe song to create a song in the simplest possible way. And then if I remember correctly, this right here should be enough to create a song in the database to actually that actually works. So now we've created this song in the database, and we can then say await ingest.send to add this message, to add a message to the queue. So I'll just go ahead and say add import from ingest name generate song events, because that is what type of event we are sending. We're sending it to the following queue right here. And then we can say the data, and remember the data must match what we expect right here, song ID and user ID. Luckily we have both, so we can say song ID will be song.id, and the user ID is going to be song.userid, like this. Cool. So now let's try it out. So what I'm going to do is I'll hop over here to the Inngest dashboard first of all, and then just say refresh runs. And then we know that there's only a single run right now. Then what I'll do is I'll just click generate song, hop back in here, and now we see that we have an event that is running. We first check the credits. We then set status to processing. We then say step.fetch. And this is just running for a long time because this is what has been offloaded to the Inngest cloud platform. Then we'll go ahead and hop into Modal if that is still open. I'll just search for Modal, go under apps, music generation server. And then right now we can see that this request is pending. So whenever this, it is running now. Yeah, so we also see the logs for the song being generated. So whenever this is done, we should be able to see the request return something over here in the Inngest development server. So I'll just wait for that to finish and then I'll come back. Cool, so the steps just finished up here. We can see that we get a response from the step.fetch containing both the S3 key, the cover image S3 key, and also some categories, hip hop, rap, urban, etc. Good. We can also see that we have this step update song results. We have the step that deducts the credits. So now we have 99 credits instead of 100. And then finalization down here. So everything seems to be working just fine. We also see that the entire function is completed instead of being failed, for example. So this proves that the solution works end to end. So that is pretty nice to know. We can then also test the concurrency part. So if I just hop under creative rap here, and then I click this twice in a row, then I hop over here, we can then see that the first one that I just clicked on is running, and the second one up here is then queued. This means that we can only do one per user per time, which is pretty cool as well. Good, so both of these just finished. The last one right here took way shorter time than the first one. So if you just hop under the app details over here, we can see that the startup time for the second request was 0 seconds, whereas it was 25 seconds for the first one. And the reason is because we hit a cold container because we are running serverless. So this means that because we have the scale down time of about 15 seconds, because this was created right after, we only had to wait half as long for the video to finish as we did for the first one. So in a production system, a lot of people would probably be using this at the same time. So we would have this startup time being closer to 0 because requests are being made to the endpoints all the time. Good. So now that we know the system is working end to end, and we can go ahead and actually create some of the parts that some of the components that we're going to use for the dashboard. This includes both the actual layout with the sidebar, the top bar, and then also the contents that we need to create the songs. So let me just close down these tabs over here, this one, and I think we'll just move this over to the first one. And then what I'm able to do is just close all of these down, this one as well, and then we can get started with the actual layout first. First, we'll just head to the ShadCN website and then search for sidebar. Inside here, we should be able to install a sidebar. So we'll open up the terminal, install the sidebar, and then we're also going to need the breadcrumbs. So we'll just import that as well. And the breadcrumbs are going to look something like this. So those will install too. And then I'll just hop back to the sidebar. And then we should be able to scroll down and see what we need to add to globals.css, for example. So I'll just open up globals.css. And then we just need to add some of these down here. So I'll just copy the contents inside the layer base because we already have one layer base. Then I would like to paste them in right here. And then go back to the layout. So under app, main, and then if you hop into the layout file, we just need to change this file now. Good. So going down, we can see whatever we need for the sidebar. So first of all, we at least need the providers that we also had inside this auth. So we had these providers right here and also the toasters. So I'll just paste this in as the first thing. So I'll go ahead and do it inside right there. Then I'll just import the providers and also the toaster from Sonar right here. So that's going to be this one. Then we're going to need a sidebar provider as far as I can tell right here. So we'll take that and then put it inside the providers. And then we'll just wrap the entire thing except for the toaster in the sidebar provider like this. And then we're going to need some kind of app sidebar component as well. So let me just take this one and then hop under source components. I'll just say new folder sidebar. In here, I'll just say app sidebar.tsx, paste in the contents, just remove this import right here. And then we'll just manually import this because we need to import it from UI/sidebar and not from the Lucid React, like this. Then we should be able to add the sidebar up here. So we'll just copy this line and then hop right into the sidebar provider, paste it in right there, and just import this like this. Good. Let me just see how that looks over here. So we at least have a sidebar right now, but this looks a little bit funky with the dashboard with the actual page contents. And the actual page contents is what you see inside here with the page.tsx. And we would like that to fill out the entire area. So what I'll do is I'll take the children, wrap them in a main, put them inside right here, and then I'll say class name flex1, and then overflow y auto, like this. And now the page contents actually take up the entire page like they're supposed to. If I then make this a little bit smaller, we can see how the sidebar disappears. So we're going to need some kind of trigger for the sidebar up here, such that we're able to open it up whenever we are on mobile as well. Then I would like to just create a header up here that shows the breadcrumbs. So for example, if we are on the create page, I would like this header to show create, such that we can navigate back and forth and also see what page we're on. So to do this, I'll just hop under this app sidebar and then add a sidebar inset like this. Then we'll just add the main as contents for that one. We'll just say class name flex hide screen and flex column. Inside this one, we'll then go ahead and add a header. The header should have the class name bg background sticky top set 10, and then also border bottom px4 and py2 like this. Then inside that we can add in another div, so I'll just go ahead and make this a little bit larger. So inside this header we can say div, then I would like to add in the class names flex shrink 0 grow items not grow items, that is completely wrong, items center, and then gap of 2. And then the first thing I would like inside this top menu is going to be the actual trigger for the sidebar. So when we're on mobile, we should be able to open it up. So I would like to add a sidebar trigger. This one I'll just go ahead and save now so we can see it. And then I'll move it a little bit closer to the actual sidebar. So we can say margin left 1 and then put it on a minus to make it closer to the actual sidebar. Now we are able to open it up right here on desktop, and on mobile we are also able to open up the sidebar like this. So now it works on mobile as well, which is pretty nice. Then we can add in a class called a separator like this. This should have the orientation vertical, because right now it is horizontal as you can see. And then we also want to say class name margin right 2, because we'll put the breadcrumbs just to the right of that. And we'll then just say data orientation is equal to vertical. And in that case, we would like to say the height should be 4. Cool. So because we set it to vertical, so if orientation is vertical, then we'll set the height to 4. And that is how we're able to see this vertical one with the height of 4 right now. Great. And then we just need the breadcrumbs. So hopping under ShadCN, we can just see the breadcrumbs over here. So we're going to need a structure kind of like this. So let me just go ahead and copy this and then just see how that looks. So if I just hop into to the right of the separator, we can just put this in and just import these ones. So add all missing imports. Then we have home, components, and breadcrumb. And this should of course be breadcrumbs that match our actual application. So I'll just go ahead and remove these ones, so we only have a single item. And then I would like to create a component for actually getting the path name such that we can show the correct path up here. So what we can do is we can hop into the sidebar folder, say new file, breadcrumb, and then page client.tsx. Then I would like to create a new component, export default function. In here, I'll call it breadcrumb page client. And this should be a client component, meaning we can use hooks. So I'd like to use the path name hook, use path name. Then I can say return breadcrumb page, like that. And we'll just need to import this. And then I would like to just take this and then put it in directly here. So instead of this breadcrumb link, we'll just put in our new component, so we can see how it looks. Then over here, we can just go ahead and say if the path, and the path is just what you see up here. So if we say create, for example, then the path would be equal to create. If we set home, then the path would be home. So we can thereby do a conditional, so we check what the path is, and then we can change the text based on that. So first of all, we can go ahead and say if the path name is equal to just nothing, like it is right now, just a /, then what we'll do is we'll say and home. So we'll set the text to that. And then we just need to put in the end right there, and path should just be path. Cool. And then because the path can only be one thing at a time, we'll just go ahead and copy this and then just say if it is equal to create, then we'll put in create. Cool. So that is how it is going to look right here. If I just refresh, we can see that because we're just on the default dashboard path, it is going to say home because we just get a single /. And then the sidebar up here actually doesn't look very good. It's just a default one. So we'll just make this fit to our use case. So I'll hop into layout, find the app sidebar, and then hop into this. And then I'll just remove these items right here. And then I'll actually just bring those back quickly. Then we'll just create a component for both showing these different items and also highlighting the one that is active, because right now, even though we are on the home menu, it doesn't highlight home with a gray background like it does right there. So we'll want this to be done automatically, and therefore we'll need to create a client component that can then check the path just like we just did, and then highlight the correct option over here in the sidebar. So inside the sidebar, we'll just say new component, new file. Then we'll say sidebar menu items.tsx. Then I'll say export defaults function sidebar menu items, like this. Inside here, we can just first of all get the path name. So const path name is equal to use path name. And I'll just need to make this a client component as well, of course. So use client. Then we can just take the same structure as the used over here. So I'll just copy these ones and remove the rest. And then I'll paste them in. And the first one should be called home, just have a / as the URL. The icon should be home. And then I'll also just create a property called active that is false per default. And then it should be true whenever you are on the page that this represents. So we'll just call this create, call this / create. Then the icon should be music from Lucid React, and active should be true, like that. We can then set this active flag based on which path name you're currently at. So what I'll do is I'll hop down here and then say items is equal to items.map. So I'll just redefine the variable and then just set the active to true for the one that it should be true for. This should be true, not false, not true. And then I'll say item, and then I'll say ... item to just keep all of the different items as they are. So item, and then specifically this active property I'll set to true if the path name is equal to item.url right there. And then this should be a let because we are going to redefine it down here. And now I just need to render out the different menu items. So going back in here in the app sidebar, we can just take this sidebar menu item, take the entire thing, and then also just say sidebar menu item like that. Import our own version of it. Let me just see what it says. Oh, it's just not returning anything. That is why. I'll just say return a React fragment where we put in this map. Then we'll just import that and import that. And we'll just then need to say is active for this button. So is active if item.active like this. So now because we are on the home page, as you can see, home is a little bit gray in the background, even though I don't hover it. So that is exactly what I was looking for. And I'll just zoom in a little bit actually, just so we can follow along even better. And then I'll just create a logo for application up here. So right now it says application. I'll just remove that first of all. So I'll go ahead and close this down. And then also, instead of application, it should say paragraph, music. And then right below this, it should say paragraph. Oh, I messed up there. Paragraph, and then generator, like this. And then generator should be text large, and the music should also have some styling. I'll just say class name, text primary, MT4, margin bottom 12. And then I'll also just say flex and flex column to make it a column. So it looks like this. I can then say items start, justify start, px2, I'll just save that. And I'll say text free Excel, just to make the music text really big as well. I'll then say font black, and I'll say tracking widest, and I'll say uppercase, like this. So now it looks like a pretty decent logo, I would say. Obviously it's not a custom generated logo, but it is good enough for our purpose, which is just to show the name of the actual application. And let me just check how everything looks on mobile. It looks pretty decent as well. So I'm completely happy with that just for now. I will then just put in a sidebar footer component down here. So I'll say sidebar footer. Inside this, we can put in a couple of things, such as a button that the user can click to see his profile, but also an upgrade button and also a piece of text that shows how many credits the user has left. So inside the sidebar footer, I'll first put in a div. Here I'll put in some class names, margin bottom 2, flex with full. I'll put in items center, justify center, gap of 1, and text extra small, like this. Then I'll just create a component for showing how many credits the users have left. So I'll say, oh, that was wrong. So I'll create a new component here, new file, then say credits. And I finally got a credit right here. So I'll then say export, async, function, and this will be credits, like this. This will be a server component, so I'll say use server. And the component app sidebar is actually also a server component, so I'll just say use server up here, just so we have it. And then async. And then in here, we can go ahead and say, I would like to get this session, so we'll just do this exact thing right there. And then we'll just import auth, headers, and also redirect, like that. But then instead of redirect, actually, I would like to just return null, so not render anything. Otherwise, if the user actually has a session and is logged in, we'll query the database for the amount of credits that the user has. So we'll say const user is equal to await database dot, and let me just import the database.user.find unique or from, where the ID of the user is equal to session.user.id. And then I would like to select credits where they're true, like that. And then we should be able to actually show the amount of credits that the user has. So I'll say rec fragment, and then I'll return 2 paragraphs. The first one should just say user.credits. And the second one should then say credits with pure text, like this. And then if we just import this component over here, right inside this div, like that, we should be able to see it in just a second. So I'll just do some styling here. Paragraph, I'll say class name, font, semi-bold, save that. And then down here for credits, I'll say text, muted, foreground. So it looks like this now. And then we can also put something in called a user button. So BetterAuth UI actually has a button called the user button. So let me just see if I can find this user button right here. So it is a button that looks kind of like this, and we can use it very simply just by importing this component because it's already pre-made for us. So that is a pretty cool thing. So I'll just go ahead and do that. So right below this div, I'll put in the user button, import it, and just save. And then we're able to see the user button. I'll just hide this thing right here, hide. And then we'll just style it a little bit because right now it is dark mode, but I would like it to be light mode like our application is. So I'll say variant and then outline like this. Good. And then let me just see why it didn't hide. Cool. Then right next to this, I'll say additional links, because if we click this right now, we can see that we have a settings and then a sign out. But I would also like to create a link to a customer portal where the user is able to see his purchases, etc. So I'll just make a link to that customer portal. And the way I'm going to do this is by passing in an array of additional links here. And then for each link, we'll need to supply a label. This will be customer portal. The link to it should be an href, and this is going to be customer portal like that. And lastly, we'll need to supply an icon. This will be the user icon from Lucid React. So just like that. And now we have an additional item called the customer portal. Of course, if we do click it, nothing is going to happen because we haven't implemented this page yet, but now it is at least there. Then I'll also just create an upgrade button. Right now we haven't set up the payment service, so Polar, but we'll just implement the payment service later. But I'll still set up the actual UI for being able to click upgrade. It just won't do anything until we set Polar up. So I'll go ahead and create a new component under sidebar, new file, and then upgrade.tsx. Then I'll say export defaults function and call this upgrade. And then I'll make this a client component, so use client. In here I'll just return a ShadCN button, like this. Import that, then I'll say upgrade. Take this button, upgrade, and then use it right under credits, like that. And then we'll just make this a little bit different, so we'll say variance, outline. And we'll say size small. We'll also say class name, margin left 2. To distance it a little bit, we'll say cursor points up, because right now if we hover the button, the mouse doesn't really change. So we'll say cursor points up. So now when we hover it, we can see that it becomes something that we can actually see that we're able to click. We'll then also just say text, orange, 400, to make it look a little bit nicer as well. Like this. But right now, if we click it, nothing really happens, and that's because we do not have this on-click defined right here. So we'll just go ahead and do that whenever we have Polar set up as well. We are actually also going to want to create a soundbar on here for playing the actual music. We won't really do it right now though, because we haven't even created the logic for being able to create a song. So what we'll do is we'll go ahead and implement this create page. So first we'll make the create page such that the user can actually create a song. Then we'll make a track fetcher over here that will fetch all the different tracks that the user, all the different songs, that the user has created. After doing that, we'll probably make the soundbar so the user can actually play those songs. And then we can go ahead and create the dashboard page, aka the home page, where you can see other songs that other people have published as well. So right now, if we click create, we see that we get a 4 of 4. So we'll just go ahead and create an actual page here. So I'll close this group down, and then under main, I'll create a new folder. This one should be called creates, and it should contain a page. So I'll just take this page and then paste it in directly and then say create here. And now we can browse between the dashboard and the create page like this. Inside this create page, I would like to create 2 different things. First of all, I would like to create a song panel. So over here, taking up maybe a third of the space that is left on the page, on the blue page right here. I would like to create a little panel that looks kind of like this one, but where you're able to actually create a song. So you can input the prompt, the lyrics, if it should be instrumental or not, and then click the create button. Then just to the right of this create song panel, I would like to create some kind of server component that fetches the song that the user has already created themselves and then shows those in a component over here to the right. That should take up maybe 2/3 of the space on the x-axis. So to create this kind of layout, what I would like to do is just remove this create song first of all, and also the main. So I'll just put in a simple div, and then I would like to say flex age full. I can put in flex column, And on large devices, flex roam. This means that if we are on mobile, we will have the song panel so first, and then you can scroll down, and then you can see the tracks afterwards. But on desktop, we're going to have the song panel over here to the left, and then the tracks that the user has created over here to the right. Good. Inside this div, I'll first of all create a component, and I would like the component to be called song panel because it is the panel right here that we use to create a song with. So I'll hop under components, and then I'll just say new folder, and then I'll probably do something like creates, and then in here I'll say song panel.csx, and then within this component file I can go ahead and export a function called song panel like this. In here I'll just return a paragraph saying test for now, and then I'll make this a client component like this, just so we can use states within it. Then I'll copy the name right here and then hop back into the create page, paste in the song panel component, import this, and then we should be able to see the test over here, and that is the actual song panel from this component. And then what I can do is I can put on some classes. So I'll say paragraph, class name, BG muted at 30% opacity, save that. And now we're able to see that the background color changes just a little bit for the song panel compared to the rest of the page over here. Next, we can go ahead and put in a flex with full on small devices, flex column as well, and then we can say border rights. And on larger devices, we can give it a width of 80. So this is what it looks like on larger devices. It is a panel over here on the left. If we make it on a small device though, it takes up the entire width such that we can have the song panel at the top and then the list of tracks below that also in full width. So that is why we create the width like we do over here in this way. Then inside this paragraph, and I'll actually just make it a div like this, I'll go ahead and put in one more div. So I'll open it up and then say div. Inside here we can say class name, flex1. Then I'll say overflow, y auto, and a padding of 4 for everything within this container. So if we put in a paragraph that says hello, we'll have a padding of 4 so it doesn't just close up against the top or the left border over here. So that looks pretty nice now. Cool. Then what I'll do is I'll hop inside this and then I'll put in some tabs, and we probably need to install these tabs from ShadCN. So what we'll do is we'll hop under ShadCN, then we'll find the tabs over here, and that is these ones, tabs. So a tab is going to look something like this. We have a custom mode, and then we have, a simple mode over here for generating songs, and then we'll have a custom mode just to the right of this. So to create these tabs, we'll first of all install the tabs component. So I'll open up my terminal, paste in the command. And now that this is done, we can go ahead and just import the tabs over here. So I'm going to make this a little bit smaller, hop back into our application. And then what I'll do is I'll say tabs, import the tabs from UI tabs right there. And then we can say tabs list inside of this. So tabs list also from UI, and then we can say tabs trigger. This tabs trigger should have the value symbol like this, and we'll have two of these. We'll have one for custom and one for symbol like that. And this means we now have two different tabs, and we just need to keep track of the value for this one as well. So we'll do that with the use states up here, and we can use states because we are, hooks just in general because we have a client component. So I'll go ahead and say const mode, and then set mode is equal to use states, and the value should be able to be either a string that is called symbol or a string that is called custom. And I'll just initialize the value to symbol just as default, and this way we can go into the tabs list here, and then we can say, and I actually think it's up here at the tabs, we can go ahead and say value is equal to like this, and then we can say mode. Cool. And then whenever the value changes, so whenever we change one of these, we'll need to set the value up here. So we'll say on value change, then we'll get the value from the events, and we'll say set mode, where we pass in the value as symbol or custom, just to get the types right. So now if we refresh over here, we should be able to see it working just as we imagined it to. And then what I'll do is I'll just make these full width. So I'll go ahead and say class name width full. This means that whenever we are on the desktop mode, it looks like this. And when we're on mobile, it looks like this, where they take up the entire width of the page. So what we're now able to do is that we can actually switch between these tabs, but we still have to make the content beneath each one of these tabs, depending on which one it is. So to do this, we'll hop under the tabs list and then create a component, we'll use a component called tabs content right here. And this will allow us to define some content that is shown for a specific value of the tabs up here. So whenever symbol is chosen, we'll go ahead and just show a paragraph such as symbol, like this. And then whenever we switch away from symbol, then it is no longer visible. So that is how we're going to define how the content will be shown. So first, inside this tabs content, I'll just go ahead and put some classes on. So I'll say class name, and then I'll go ahead and say margin top 6 and space y6 to space out the elements on the y-axis. Good. Then we can put in a div. We can say class name flex column, and then also gap free between the items. Then we'll put in a label first of all. This label should say describe your song, like that. Then we'll just style this a little bit. I'll say class name text small and font medium. Then we'll put in an actual input field below this. So we'll use something called text area, and I think we'll need to actually install it from ShadCN here as well. So we'll just go ahead and hop to ShadCN, then find the text area, that is this one. So this is the component that we're interested in. This means that the user will be able to say, I want a hip hop song about cars, for example. And then this will be the input field that he uses to input that into. So that is basically the purpose behind it. So going into our terminal here, we can just install this component and close back down the terminal, say text area, and then we'll just close it up like that. Hopping back in here, we should be able to see it in just a second, and now we are. Great. And then for the placeholder, I'll say placeholder, a dreamy, lo-fi, hip hop song, perfect for studying or relaxing. And I'll just fix this like this. So now the tabs are going to look like this, which looks pretty decent in my opinion. And then we'll just put in some other properties as well for this component. We'll first put in a class name. I'll say minimum height of 120 pixels, like that, just to make it a little bit larger, because otherwise it becomes pretty small. I want the user to feel like he can input a lot of text into this one, and if it is too small, you might not get that feeling. Then what I'll do is I'll also just say resize none, like this, to remove this little handle down here that allows the user to resize. So if resize none is not on, the user is able to do this, and I don't really like that. So I'll just set resize none to true. Also, put on the class in the CSS class name here. And then we'll just need a way to track the state of the actual input field. So we'll use a use states for that. So I'll just say const description, and then also set description is equal to use states, and we'll just make it an empty string as the default value. And then we can go ahead and go down to text area, and then we can say that the value should be description, and on change, what we'll do, let me just fix this, on change we get the event, and then we can say set description to event.target.value, like this. And this means that whenever we click the big create button down here that lets the user create the actual song, it'll then be able to access the value of this text field up here because it is stored within this use state. And then below this div right here, I'll put in one more thing. I'll put in a lyrics button and also an instrumentals toggle. So these will be two separate input fields. So first of all, I'll put in a div. For this, I'll say class name like that. Then I can say flex, items, center, and justify between, because I would like them to be on the same row. And then inside this div, the first thing I'll put in is a button, and we already have the button from ShadCN from UI/button. This button should say lyrics, and then we just need to import this, of course. And right next to this text saying lyrics, I'll just put in a plus icon. So I'll say plus, import that from Lucid React. And then we'll need to just set the height and width for this plus. So I'll just go ahead and say class name. And then first of all, I'll say MR2 to space the plus a little bit from the lyrics text. Then I'll say height of 4 and width of 4 as well. And I can see that that was actually already the original default values. So I'll just go ahead and remove these classes just to keep it simple. Then I'll go ahead and hop into the button, and then I'll set the variant. The variant should be set to outline. And then I can also say size, small, and I can say on click. And what I would like to do is that whenever you click this lyrics, because we are in simple mode right now, we aren't able to let the user manually provide the lyrics. So I'll just switch the tab to the custom tab over here to let the user know that if he wants lyrics, he'll need to switch to custom mode and then actually manually put in the lyrics or describe the lyrics. So we can go ahead and switch the actual tab by calling the set mode, and we'll set the mode to custom like this. Then if I click the lyrics, it'll switch to custom. So that is exactly what we wanted. Then next to this button component right here, I'll put in one more div. I'll then say class name, flex, items, center, and I'll say a gap of 2. In here, I'll put in a label. This should say instrumental. And I'll just style this a little bit as well. I'll first of all say text small and font medium. And then right below this instrumental, I'll put in a switch, which we'll need to install from ShadCN too. So hopping in here, we'll just find the switch component, and that is this one, because this is a checkbox or kind of a toggle for whether you want the instrumental mode or not. And it looks pretty cool in my opinion. So hopping down to the terminal, we can go ahead and install that. Good, and then now we should be able to use it as well. So I'll say switch, import that. Then I'll say checked. Actually, I'll just say first just so you can see it, but we just need to store the actual value in a use state such that we're able to send it to the Modal backend with our request. So I'll go up here and then say const instrumental and set instrumental is equal to use states. And then I'll just set the value to, not a string. I'll just set the value to false per default. So it is not an instrumental per default. Then we can say value is equal to instrumental, and we can say on checked change set is instrumental. And then I think we actually need to change this to checked like that. And now we should be able to store the value of this one inside a use state so we can send it to the backend for the request. Below this part of the page over here, I would like to put in a horizontal row of different tags that you can click and then automatically insert them into this describe your song input field. These should be inspiration tags such as hip hop or rock, for example, that you can just click if you don't really know what kind of song you would like to create. So I'll hop under this div of the lyrics button and instrumentals toggle. Then I'll say div, and then I'll give it a class name, flex column, and a gap of 3. Then I would like to say label, inspiration. The class names for this should be text small and font medium, like the other labels as well. Then below this label, we can go ahead and create a new div. This div should have the class names with full, overflow, x auto to make it scrollable, because we'll have more text probably than fits within the width of the screen. So overflow x auto, and we can also say white space no wrap like that. Within this, we'll create the actual horizontal row of tags. This will be a div with flex gap 2 and then pb2. And in these, we can loop through a list of different tags, which we'll just hop up here and then go and create. So I'll just go ahead and take something from behind the scenes and then paste them in. So I would advise you to just hop into the GitHub repo and then just copy this right here, or just pause the video and just type them in. You can also just create your own ones if you want some that are even simpler than this. So we'll take these inspiration tags array and then hop down and then loop through this with a map. So I'll say inspiration tags.map. This will allow us to loop through each tag and then render out some HTML per tag. So for each one of the tags, we'll get the actual tag, and then I would like to render out a button from ShadCN. We'll need to just define a key, because whenever you loop through something with .map, you'll need to define a key for the elements that you create, such that React can actually keep track of which is which. So for this key, we'll need to just use tag probably, so just the actual name of the tag, because the key must be unique. Cool. Another thing we'll have to put in is also a plus right here from Lucid React, and I'll just go ahead and say class name mr1, and then right to the right of this I'll put in the actual tag in text. So now we have the tags and we can scroll on the x-axis. Then because this looks kind of robust or a little bit too much, we'll just go ahead and change this button a little bit. We'll say variance, outline, and we'll also say size small. And we can then say class name, and I'll make it height 7 to make him even smaller. Then I'll say flex, shrink 0, background transparent, and I'll say text extra small so it looks like this. And we're still able, of course, to scroll to the right and to the left. Then the first thing I would like to do is the next thing is to then create this on click. So right now when you do click it, nothing really happens, but I would like the actual tag content to be added to the input field up here. So to do this, I'll hop up and then create a new function. I'll say const handle inspiration tag click, and this will be equal to the tag, it will receive the tag, which is a string. And then first of all, I would like to prevent duplicates, because if you have already inserted this 80 synth pop, I would like to not add it again. So I'll take all the different elements from this input field, split it by comma, and then check if the tag that we're currently trying to add already exists in the list, because if that is the case, we'll not add it again. So first I'll say const current tags is equal to description. And remember, we have the value of this description input field from the use state description up here. So we can say description.split. So we split all the different elements, we split the entire contents by comma right here, and then we get a list out. Then we can say .map, and I would like to say s.trim. So for each one, we trim away leading and trailing white space. And then after this, we can go ahead and say .filter, and then I would like to filter away white spaces, so we can go ahead and say s and then just s, because this will evaluate to false if it is just an empty string in JavaScript. This way white spaces will be filtered away. So now that we have a list of all the current tags, we can then go ahead and check if the tag that we're trying to add to the input field is already there. So we can say if, and then not current tags.includes. So if the list does not include the tag, well, then we can go ahead and add it. So we'll then say if description.trim is equal to an empty string. So if the input field is currently empty, then we can say set description and just set the current description to the tag. Otherwise, we'll need to actually append it. So we'll then say else set description, and this will be description plus, and then we'll need to append it with a comma at last, plus the tag, like this. So now if we just set this as the on click down here, so right there for the button, we can then say on click. And then what will happen is that we'll call this function with the actual tag as the parameter. Then if I click here, we can see that it adds the tags with a comma in between them. If I click this 80s synth pop again, it won't be re-added, so it works perfectly fine. Let me now just test it on desktop as well. So on desktop, it is going to look like this. You can still scroll right and left, and everything looks perfectly fine as well. And now what I would like to do is just implement the custom menu such that that is working as well. So I'll start by just scrolling up to wherever we have this tabs content, and then I'll just copy maybe these 3 lines right here, scroll down to right below tabs content, paste them in. I'll put in the end div and also the end tabs content and go ahead and save. And this should then be for custom, meaning that it'll only be shown on the custom tab over here. And then first I'll just call this right here lyrics, and then I'll wrap this in a div like that, and then give the div some classes. It should be flex, items center, and justify between like that. And the reason I want to wrap this in a div is because I want 2 buttons below this lyrics. I would like the user to be able to describe the actual lyrics, but I would also like the user to be able to manually input the lyrics. So we'll need to differentiate between these 2, and I'll do that with 2 different buttons that you can then toggle on or off, toggle between. So in here, right below this, I'll put in another div, say class name, flex, items, center, and gap 1. This means that we can show the buttons next to each other. Then we'll put in the first button, and that should say auto. And then for the class, we'll say height of 7, text extra small, save that. And then we'll also put in size small, like that. I'll then just hop up to the use states up here, and then I'll create 2 more. I'll first of all say const, and then lyrics mode, and then also set lyrics mode. Let me just fix this. Is equal to a use states where we have write and auto as the 2 possible values, and we'll set write to the default one such that the user can actually put in his own lyrics. I'll just go back here. And then I would also like to just create a use state for the actual lyrics. So I'll just copy this entire use state for the description, paste it down here, and then I'll say lyrics and set lyrics. Good. Then scrolling back down, we should be able to use those now. So if you go ahead and click this, so on click, I would like to say set lyrics mode, and I'll set this to auto, because right now this is the auto button, and we'll then also clear the entire field that we're going to create later that will contain the lyrics. So I'll say set lyrics to, and just set that to just an empty input field. Then I would like to also just differentiate between the button that is currently pressed. So right now this is auto, but we'll also have a button right next to it called write. And I would like to have the one that we just clicked be selected. So we'll go ahead and say variant, and then we'll determine the variant based on the actual value of lyrics mode. So if the lyrics mode is auto, then it'll be a secondary. Otherwise it'll be ghost, like this. And this will just need to be a question mark, like this. And now we should be able to copy this button. So I'll just copy the entire thing. And then down here, this will be write. This will be write as well. And this will then be write as well. And now if I click these, I'm able to toggle between them. And also the reason I used 2 buttons instead of using the actual tabs up here that we used earlier, so these tabs right here, is just to make the design look a little bit better, because if you just have a lot of tabs stacked, I personally do not think that looks very great. So that is why I use 2 buttons instead of the tabs. Cool, then we can go ahead and put in the actual input field for the lyrics. So beneath the buttons, the button divs right here, I'll put in a text area. Inside here, I'll put in, and I'll just close the tag like that. I'll put in, first of all, the value. This will be equal to the lyrics use states. And then the on change is going to be, we'll receive an event, and then we'll set the lyrics to event.target.value. And then what we can do is we can also say class name minimum height of something like 100 pixels maybe, like that. And lastly, I would like to just say placeholder, and then we'll make this placeholder be determined on what mode we've set it to, so whether it is auto or write. So if we are in the write lyrics mode, like that, what I'll do is I'll say add your own lyrics here. Otherwise, if we are in auto, I'll say describe your lyrics, e.g. a sad song about lost love, like that. Great. And now if I switch between them, the user is able to see what he actually had to do. So for writes, the user knows that he can add his own lyrics, and for auto, the user knows that he can just describe the lyrics and they'll then be generated like this. And it also works completely fine for the desktop view. Good. And then this custom view over here should also have an instrumental toggle. So I'll actually just take the instrumental toggle from up here and then just copy it down. So right beneath this tab's content, this div right here, I'll just paste in this instrumental toggle, and then I'll just remove this and then just say something like justify between. So it's going to look like this in custom mode and like this in simple mode. So in simple mode, we'll have two different components, two different elements in the same row. So therefore we'll make the instrumental close to the actual checkbox. But over here, because the instrumental is the only thing in this row, we'll just make it fill the entire width of the row by putting in justify between. This way it is going to look a little bit nicer. And then remember, in custom mode, we both need to provide the lyrics for the song, but also the actual prompt for the song. So for example, hip hop, rock, etc. So we'll need to just create another input field for the actual prompt or style of the song. So I'll do this below this div right here. I'll just say styles, make that a comment, and then I can put in a div, say class name, flex column, gap free. Inside this, I'll put in a label, say styles. Then I can say class name, text small, and font medium, like that. I'll then just copy the text area from up here and paste it in right below the label. And then the placeholder is going to look something like, let me just do this, enter style tags. And then the actual input of this style input field will then go up here. So I'll then say style input, and then set style input. And then down here we can go ahead and use that. So I'll say style input and set style inputs, like that. Then I'll make this a tad bit smaller. So if we put in 60, go over here. I'll then also create an inspiration list of tags that we can enter. So just as we have this inspiration list down here, we can then click these. I would like the same just for the custom tab, just for these styles. And to do this, behind the scenes, I've created one more of these lists that I'll just paste in. So again, just pause the video and paste them, and write them in, or copy them from the repo, or put in your own ones. So going down, we can then render these out. And first, I'll just make this resize none to remove the little handle down here. And then also for the lyrics text area, I'll make this resize none, like that too. Then going down below this text area, I'll put in a div, and I'll say class name with full, overflow, x auto, and I'll say white space, no wrap. Inside this one, I'll put in one more div. I'll say flex, and I'll say gap 2 and padding bottom 2. I can then render out these style tags. So I'll go ahead and say style tags dot map, like this, and then I can get the actual tag. Then I'll be able to render out a badge, and we'll just need to import the badge from ShadCN. So hopping back into ShadCN over here, we can just find the badge component. That is going to be this one right here, and then we can install that. So I'll hop into my terminal, install the badge component, and then I can render this out. I think I just need to go ahead and do this, and then include the tag in the middle, and then import the badge from UI badge. And now we can see all the different tags down here as well. They look a little bit different from what they do over here, and that is because they are badges and not buttons. Good. So then for each badge, I would like to set the variant to secondary. And I would like to also say key, and the key should be equal to the actual tag. We also then need to say class name, and then hover, I would like to say background, secondary at 80%. I'll then say flex shrink, 0 cursor pointer. And we can lastly put in text extra small. We can then hover them over here and see that the background changes just a little bit. It is going to be easier to see whenever we change the background color later on in the video with a theme. So right now we just need to implement the logic where we can actually click them, then insert the content into this style description. So up here, we'll just take this for now and just copy that. And then we'll call this handle, and then style input tag click. This will then be the style input instead of the description. This will be the style input, and this will be the style input. Let me just see, yeah. And then for the set description, that is going to be set style input right here. And we'll just need to use this down here again. So for each batch, whenever you do click one of these, so on click, then we can call this and pass in the tag. And then I should be able to click them over here and then insert these, but not insert any duplicates, just like we were able to with the simple mode. Lastly, down here, I'll put in a big button that says create, such that the user can fill in the input fields and then create the actual song. I'll do this beneath this div right here. So I'll say div class name border top, so border T, and then I'll also put in a padding of 4. So now we have the border right there, and this will mean that we can put in the button right below this border top. Cool. So right inside this div, we can put in an actual button like this, and then we'll just say create for now. Then I'll style it a little bit. So I'll say class name with full. I'll say cursor pointer like that. And then I also want to put in background gradients to R from orange 500. And then I would like to transition it to pink 500 like that. And then I'll say font medium, text white. I'll say whenever you hover it, we'll say from orange 600, and then to pink 600 as well, like this. So it'll look like this whenever we hover it. The colors will just change a little bit. Then we can just create a loading state for whenever the user actually clicks create, because some loading is probably going to happen. So I'll just hop up and create a use state for that. I'll say const, and then loading, and then set loading is equal to a use state, and that should of course just be false per default. And then down here, if it is already loading, then we'll just say let me just do this. Then we'll say creating ... Otherwise we'll say create, so the user knows that they can do an action like that. And then we'll also show a logo based on whether it is loading or not. So I'll just copy this line. And then if we are loading, I would like to show a loader 2 icon like that. And then otherwise we can go ahead and show the music icon from the seed reacts. Cool. And then for this loader icon, we can go ahead and put on a Tailwind CSS class called animate spin. This will allow it to spin whenever it loads. So if we just set this to true, we can see that it says creating, and we're then able to see that it spins. Otherwise we see the music music icon, and we see that it says create. And then of course, as you probably noticed, whenever it was loading, we were still able to click it, and we don't really want to be able to do that. So I can just go ahead and go to button and then say disabled when is loading is true, like that. So now we aren't able to click it while it is loading. Then the last thing we got to do here is just say on click. And then whenever we click it, we're just going to call a function called handle create, which we'll go up and create now. So I'll just set this loading to false again. And then we can implement the logic for actually calling the backend and enqueuing the request. So I'll say const handle create is equal to an async function. I'll then say if the mode is simple and not description.trim, then we'll say toast.error, and we can import this toast from Sonner. Toasted error, please describe your song before creating, like that. So if you now go over to the simple mode, and then we don't put anything in, and we then say create, then we say please describe, then we see please describe your song before creating, such that we can't really trigger this without having actually filled in the input field. And then if we say, just copy this and say if mode is equal to custom and the style input.trim is not there, then we'll say please add some styles for your song. Then over here, if we just click create now, we see please add some styles for your song. And anything that then happens below this should not be executed in any of these cases, so we'll then just return straight away. Cool. And then below this, we can go ahead and say generate song, and then we just need to hop back into our server action. So under actions and generation, and then we'll just need to create a function that enqueues multiple songs, because I would like for the user to be able to click this and then it enqueues multiple songs with different creation parameters. And we also of course need to insert both the lyrics and the styles as the values right here, instead of just hard coding those. So first I'll hop under here, and then I'll say export async function. That is what we're going to call from the front end here, a server action, generate song, and we'll pass in a generate request, and then we'll just export an interface where we define what we want to receive in the server action. So I'll say export interface generate request, and I would like a prompt that is going to be the styles. That will be a string. I also would like the lyrics, a string. I would like a full described song, which is also a string. I would like the described lyrics, and I would like if it is instrumental or not. That will of course be a boolean, like that. Cool. And then what we can do is we can just say that we would like to accept this right here. And then first we just do this. So I'll just take this entire part and move it up to this function right here. So this function down here actually enqueues the song the song request in the ingest queue, and then this one up here, which is the one we're going to call, is going to call this function twice. So we get 2 songs created every time you click on this create button, just with a different guidance scale, just so we get some variety in the songs that the user creates. So to enqueue a song, I would like this function to receive both generate request, that is the same as this one up here, then also the guidance scale, that is going to be a number, and that is the only thing that is going to be different between each time we call this function. Then we're also going to pass down the user ID, which we have from the session up here, like this. Then inside this queue song, we can take this information and then we can process it. So first I would like to determine a title. Right now we have just put in title test song 1, and that is obviously not good enough. So we'll first of all set the default title to be untitled, and then we'll try and determine a title based on both the described lyrics or the full described song, if that is the case as well. So next I'll say if, and then generate request dot describe lyrics. So if that is set, that is going to be if we are in this case right here. If we are in this case right here in custom mode, where then have described the lyrics like this. In that case, we'll set the title to generate request dot describe lyrics. If you instead are in generate request dot full describe song, so in simple mode right here, we'll set the title to generate request dot full describe song. I'll then just also create one for the third option, where you have the auto mode, where you have the manual mode right here. In this case, I'll say dot lyrics, and we'll then set the title to the lyrics like this. And then I think I'll actually just remove this line right here, because if we remember back to how Ace step looks, let me just hop into this one, go down to the project, then find some lyrics. So we might see verse 1 as the standard lyrics, for example, or something like verse right then square brackets as the title. So I definitely don't want that to be the title, so I think I'll remove that line again, and then only make the actual inputs the title if they are written words like this. Good. So next we can go ahead and hop under this, and then we can uppercase the first letter always in the title. So we'll say title is equal to title.character at 0.to uppercase, like that. And then we'll say plus title.slice 1 like this. This will just uppercase the first letter in every title regardless of what the title is. Then we can go ahead and just amend this right here. So this is going to be user ID. The title is going to be the title. And the full described song, I'll just remove this and then go prompt first. This will be generate request dot prompts. And then below this we can put in the lyrics. Below the lyrics we can put in the full described song. Below this we can put in the instrumental flag. So right there. And below this flag we can put in the guidance scale. So that actually comes from right here, that guidance scale. And lastly we can put in the audio duration, and I would like every song to just be 3 minutes long, so 180 seconds. And the rest of this down here just stays the same because that just enqueues the song. Then all that's left to do is to just call this queue song method twice up here. So I'll say await queue song, pass in the generate request. And then for the first version or variant, I would like the guidance scale to be 7.5, and set the the user ID to session.user.id. And then for the second one, I'll just set the guidance scale to 15. And then I would like to revalidate the path to create, like this. And the reason I would like to do this is because whenever a user is on this page, the component which we're going to create after this is going to show the songs that the user has created, and it is also going to show the status of the songs. So whether the song is finished processing, or whether it is currently processing, or whether it has failed processing. So whenever the user clicks this generate button right here, I would like these songs to show up immediately in the dashboard without the user having to refresh the page or anything. So by calling this revalidate the path, we are going to revalidate the database query that will create in the component that is then going to show the songs over here. So that is why we do that. Good. Now that we have this generate song, we can go ahead and hop back into the song panel and then call this down here somewhere. So I'll say let request body to the serve action be of type generate request, and we'll just import this from actions, and that is the interface which we exported up here just so we can reuse that type. Then I'll say if the mode is simple, then we'll say request body is equal to full described song. That will just be the description, so this one right here. And then the instrumental flag should always be present, and this is just going to be instrumental, like this. So that is going to cover the simple case right here. And then we can also say else, and then const prompt is equal to the style inputs. Then we'll say if lyrics mode is equal to writes. Let me just open this up. Then we're going to say request body is equal to prompt, lyrics, and instrumental, and we can actually just pass it in like this. And then otherwise, so we'll just put in an else here. Otherwise, the request body is going to be equal to prompt and then the describe lyrics instead. So this will cover all three cases. This one is for the simple mode. Then for the custom mode with auto, that is going to be this one right here. And then for the custom mode where you write your own lyrics, that is going to be this one right here. And the reason we use lyrics both of these different places is because we use the same input field both for auto and write. The way we differentiate between these two is by using either the lyrics as the property key or describe lyrics as the property key. Cool. So now we're able to actually call the generation action. So we'll say try, and then we'll just say catch. Like this, we catch an error. And we then also say finally, and we'll then just say set is loading, set loading to false. And then the first thing we'll do inside the try is just set loading to true. Then what I'll do is I'll say await, generate song, import this from actions, generate song, generate, we'll pass in the request body. And we'll then just clear all of the different input fields such that the user can go ahead and create a new song. So I'll say set description to nothing. I'll also set the lyrics, and I'll set the style input to nothing as well. And then if something fails, I'll just go ahead and say console dot, I'll actually just say toast dot error, and then failed to generate song, like this. Good, so now we should be able to actually generate the song. So what I would like to do is hop into the Inngest dashboard. So I'll just open this up over here and just refresh. And then we can see that currently I see no runs in my dashboard. If I hop over here and then go to symbol mode and then say 80 synth pop and then something like about cars, I can then say create. And then it is cleared right here. We don't see any error messages. If I then hop into the Inngest dashboard, we can see that the first one is currently being processed, and the second one over here is then queued, so that seems just right as well. If I then hop into custom mode, I'll then just say lyrics about lamps or something like that. And then for the style tags, I'll then say industrial rave, press create. If I then hop into here, we then see two more queued items, like that. And then if I go into write, we can then also say this is the best song, yeah, something like that. I'll then just also set this to into instrumental just to try that out, and then say orchestral and then create. And then in here we now have two more enqueued messages within the queue. Cool, so it seems to be working just fine end to end. So we can now create songs from the song panel over here. And then because the user obviously do not have access to this Inngest dashboard over here, the users should be able to see the songs that they both enqueue and also create over here on the right. So that is the next part of the application, which we're going to take care of. Good, so first what I'll do is I'll hop over here and then I'll go under components, under create, new file, like that. And then I would like to say track list fetcher.tsx. In here I'll say use server because it is a server component. We'll use this component solely just to fetch the tracks, the songs from the database, and then push these in, inject these into a client component that can then show and also play these tracks. So I'll then say export defaults, async function, track list fetcher. And then in here, I would like to return something. So I'll go ahead and say return, and then paragraph tracks loaded. And because this is a server component that requires a fetch to the database, this might take a second or maybe just 100 milliseconds. So we'll just simulate the wait. I'll say await new promise, and then resolve, set timeout, resolve, and then 1000. So this way we can just set a fake loading state for about 1 second until this right here is actually shown. And then if we go back into not the song panel but the page.tsx, we can then create a suspense that shows a loading state for this 1 second until it is actually loaded. So right below the song panel, I'll put in a suspense from React. Inside this suspense, I would like to put in the track list fetcher. And then I'll say fallback, and this is going to be the loading state. This will be a div with a loader2 component inside of it. like that. And I'll then say class name h8 with class name height of 8, width of 8, and then animate spin. And then we just need to import this from Lucid React, and then also spell this correctly, of course. And then what I'll do is I'll just hop into the div2 and just say flex h full with full items center and justify center. This will make this div right here fill out the entire box or div right here, so the entire parent div. And then with the flex and then also the item center and justify center will then show this loader right in the center of the box. So if I then go over here and just refresh, we then see the loading. And then if I make this desktop as well and then refresh, we then see the loading. It is not centered though on the x-axis, so I would like to fix that. And I spelled something wrong, completely wrong down here. It should be justify center and not justify between. So reloading again. Now the loading state is centered as it should be, like that. And then on desktop, it's going to look like that whenever it is loading for this 1 second. The loading time is likely going to be much faster than this 1 second. It is only just to show you how the loading state is going to work whenever we are loading. So next, I'll just copy this logic right here and then hop into the track list fetcher and then just paste that in. And then I'll import the auth, the headers, and also the redirect right here. And now we should be able to grab the user's ID and then query the database. So I can say const songs is equal to awaits, and database will need to import .song.findMany. We would like to select many songs where the user ID of the song corresponds to session.user.id, and this will just need to be within a curly bracket like that. Then we can select specific columns from each song which we find with this ID, and those should be the ID of the song first of all, the title too. I would like to also select the created at, the thumbnail s3 key, the s3 key for the actual song, the instrumental flag, the prompt. And I think we're selecting so many columns now that we can just remove this select statement entirely and just select every single prompt like we do right here. And then I'll just say include, and then user, and then something like select the name as well. So we'll select every single property from the actual song row, then also the user right here. Then I would like to take all of these different songs that we find and then order them by the created at property in descending order. This means that we get the newest songs first in the array of songs right here. And the reason that we select all of these properties and also the name of the user is because this allows us to show about a bunch of information about each song that is in the database over here on the right. And then whenever you click play for a specific song, it is going to show all of that information down here in a play bar, which we'll create as well later on. And we can then also show the name of the user that created each song. So whenever you click play on a song over here, it then shows the song and then also your username. So in my case, it would be Andreas right beneath the song name. Good. So one thing we need to do though is we need to take the s3 key of the thumbnail and then turn that into a URL that we can use to actually show the thumbnail. Because right now, even though we have the s3 key, we do not have the physical image. So that is the first thing I would like to do. Also, we are not going to get a URL for each of the each of the VAV files. So each of the songs that we also store in the S3 bucket. And the reason is because the user might not even press play on any of these songs. So don't really have any reason to actually grab a pre-signed URL that allows the user to play the song until the user actually clicks play over here. We do need to show the user every single thumbnail in the dashboard though, because otherwise it would look very weird. So we are going to grab pre-signed URLs for every single thumbnail, but only when the user actually wants to play a song. We'll then grab the pre-signed URL for that song that the user wants to play and then play that. So down here I can say const songs with and then thumbnails is equal to await, and then we'll say promise.all to run a series of promises in parallel so we can await multiple different statements at the same time. Then I'll say songs.map async song. And then inside this, I'll first of all get the thumbnail URL. So I'll say const thumbnail URL is equal to song.thumbnail URL. And if that is present, I would like to get the actual pre-signed URL of that. So I'll just say true for now. Otherwise, I'll say null. So here we need to create a function to get the pre-signed URL. And that is a URL we'll get by calling the AWS API and then getting a URL back that allows us to access the actual object in the S3 buckets. So here's how we can do that. I'll just hop into this serve action again, and then we'll create one more serve action which we can use to do this. I'll say export async function, get pre-signed URL, and I would like to pass in a key which corresponds to the object we are getting the URL for. Then I can say const s3 client is equal to a new s3 client, and we're just going to need to install an npm library for this client to be accessible. So we'll search for npm and then s3 client, so client s3 right here, copy the installation command, hop into our terminal, install the library, and then we'll just need a request pre-signer as well. So that is going to be this one, s3 request pre-signer library. I'll just copy that command too, paste it in right here, close back down this, hop into application, and then I'm able to say s3 client and then hopefully import this. So if I go up and then say import, and then I think it's the s3 client like this from, and then we just installed the AWS client s3. Good, so we are able to import it now. Then we'll need to authenticate our requests to the S3 API with our credentials. So remember our credentials in here. We have the AWS access key ID and secret key ID, the region, and also the bucket which we would like to generate a pre-signed URLs for. So all of these we have already defined, so we can just pass this in. The region is going to, and I think this needs to be a dictionary. The region is going to be env from this import right here, dot AWS region. The credentials is going to be another dictionary with the access key ID being env.access key ID and the secret access key being env.secret access key like that. So this will then create an instance which we can use to interact with the S3 buckets. Then we can create a command which we can use to make an API request to the bucket. So I'll say const command is equal to a new get object commands. And I would like to make a get object command to the following bucket, the env.s3 bucket. And then I would like to get the object with the following key right here. So the one we pass in to the server action. Lastly, we can fire off this command by making the actual API request. So we'll say await get signed URL, and we'll need to just import this from the correct place. I'll just say import and then get signed URL from AWS. Let me just see, AWS request pre-signer like that, and we should then be able to use the get signed URL down here. We pass in the client, so our authentication tokens, the command which we would like to send, and then also an option, and the option is expires in an hour. This means that the URL generated to access the object in the S3 bucket will only be valid for an hour, and thereby people can just ship the links around and then have access to the files forever. So now we go back to this tracklist fetcher and then use the new function we just defined right here. So going back, we can say if the song.thumbnail s3 key exists, then I would like to pass it into this get pre-signed URL method. So we just pass in the thumbnail s3 key. Otherwise, it is null if it is not there. Then I'll take all of this data and then destructure it into a single, create a single dictionary containing all the data. So I'll just say return id song.id. I would like to also return the title. That should just be song.title. And the created ad, song.created ad. And then I would like the instrumental flag. And we can also do the prompt. That will be song.prompt. The lyrics. Then the described lyrics. And then the full described song. This one right here. Lastly, the thumbnail URL. And that should just be the property name as well. Good. Then we can go ahead and say play URL. This is a property which we'll just set to null for now. This is what we'll get whenever, this is what we'll use whenever the user clicks play on an actual song. So we'll set this to null for now, and then when the user clicks play, we'll go ahead and set this to an actual value, which we can use to play the song. Next, I'll say status, song.status, and created by user name, song.user.name, and published, song.published, like this. This will then give us a list of promises inside this map right here. So this map is going to return a list of promises that will need to be awaited because it's async, and all these promises are then awaited at the same time with this promised at all. And it'll then get the pre-signed URL for every single thumbnail URL. So this songs with thumbnails will just contain all these different properties, as well as the actual thumbnail URL or the link to it. So now we should be able to take this entire list of songs with thumbnails and then pass them into a client component, and then go ahead and render them out over here. So I'll go ahead and create a new component under create, new file, and then track list.tsx. Then I can say use client, and I can say export function, track lists, and I would like to pass in the tracks, so the songs, and I'll just create a type for it as well, so what we would like to receive. So up here I'll say export interface track, and then we'll just take and say that the tracks is a list of these. So tracks is a list of track. Then we can say that, and let me just return something just so we don't get an error. Then what I'll do is I'll just implement all of these different properties in here. Not implement, I'll just put them in. So this should be a string. The created at should be a date. And then the title should be a string or null. Instrumental is a boolean or null. I think it's actually just a boolean because it's false per default. The prompt will be string or null. The same for the lyrics. And then the described lyrics as well. This one as well. Thumbnail URL, that should be string and null, or just string, sorry. And then the play URL, null or string. Status, that should be string and null. Username, string and null. Published, that should be a boolean as well. Like that. Good, and now we should be able to take these tracks over here and then pass them down. So I'll go ahead and say track lists, there, like that, and then pass down the tracks, and that is going to be the songs with thumbnails. And then I think we have a type mismatch somewhere, and I can see that we have this promise string null not assignable to type string, and the only thing that could be a promise is this one up here. And we actually forgot to await that. So now it should match just fine. Let me just see. I think we just need to set this thumbnail URL to string or null, because it can be both null or it can be a string up here. So now let's build out the actual tracks that is going to load over here. So I'll just start with a div. So I'll say div, and then class name flex1. Flex column, and I'll say overflow, y scroll, like that. And then let me just make it a little bit smaller actually. Then what I'll do is I'll put in another div, class name flex1, and a padding of 6. Inside this, I'll put in a search bar and then also a refresh button, so you can refresh the status of your songs, because remember in the functions.ts, we set the status of the song to both be processing and also to be processed, I think, after the song has been processed. So we'll just make a refresh button over here so you can see the actual status of the song. So I'll put in a div with the class name margin bottom 4, flex, items center, and then also justify between and gap 4. Inside this, I'll put in a container for the search and the input. So I'll say relative, max with medium, and flex 1. In here, I'll put in a search, and this is just an icon. So I'll go ahead and just import this from Lucid React. Then say class name, text, muted, foreground, absolute, top, 1/2, left 3, height of 4, width of 4, minus translate, y 1/2. So we have the search icon now. And then right next to this, I'll put in an input. And then I would like to say placeholder search. And I'll just put in 3 dots like that. Then I would like to say class name. And this should be padding left 10. So see how we now space the text away from the actual icon. And this is positioned absolutely relative to this div right here, so the parent container. Then we can go ahead and put in a value and then also an on change. So we'll just define a use state up here for the search query. And then set search query is equal to use states, and we'll just make it an empty empty string as the default value. We can then say value search query and set on change, I think it is, and then we can say we'll receive an event, and we then call the set search query with e.targets.value. And if I then type something over here, so I just type something in, we see that it works, and then the value should be stored within the following use state right there. Then we'll just create a refresh button. We won't make it functionally work. We'll just create the button, and then whenever we actually have some tracks over here, we'll create the refresh button such that we can see what effect it actually has on the software. So right below this div, I'll put in a button. This button will have its text be dependent on whether we're refreshing or not, because refreshing might take half a second or so. So we'll just create a use state to keep track of that. So I'll say is refreshing, and then set is refreshing is equal to use state, and that will be false per default. So if we're currently refreshing, I would like the button text to be the following, and I'll just put in an icon. Is refreshing down here. So that should be the loader 2, like that. Otherwise, we'll put in refresh CCV, like that. And then I'll just import this one and this one as well. And then for the loader 2, I'll just say class name mr2 and animate spin to make it spin. And then for the class name, for the other one down here, I'll just make it only mr2. So it's going to look like this, and then we'll just put some text right next to it that says refresh. And I think we just need to make this text be outside the parentheses, like that. So now if we are not refreshing, then this is how it's going to look. Otherwise, if we are refreshing, it's going to look like this. And then of course we need to do a couple of other things, such as just making this disabled if we're currently refreshing. So we can go ahead and say disabled if is refreshing. We can also say variant outline just to make the style match the rest of our application. We can then also say size small, because right now it's pretty huge. And we can say on click. And And then on click, we'll need to just implement this handle refresh method. So we'll just leave this out for now. So right now it won't really do anything whenever we click it, but we'll just wait with implementing that till a little bit later on. We can then go ahead and render out the actual track list. One thing I would like to do is, instead of just taking all the tracks and then rendering them out as a list from this variable right here, I'll create a new variable called filter tracks that will contain all these tracks where we apply this search filter right here. This way we only render out the track that the user has searched for. So we can say const filtered tracks is equal to tracks dot filter, and then we get the track in this filter. We can then say track dot title dot to lowercase, like that, and we can say dot includes search query dot to lowercase. So this will search among the track's titles. So if you put in the title of a track up here, it's going to search among all the track's titles. But we also want to be able to search among the track's prompts. So I'll just go ahead and put in the prompt as well, so you can search for that too. Good. So this will then contain a list of all the tracks that live up to the search query filter, and then we can use that to render out the tracks. So down here, right after this div, we can put in, I'll just say track list, just so we can tell this apart. Then I'll put in a div, say class name space y2. In here I'll put in the filter tracks dot length. If the length is more than 0, then I would like to render out something. Otherwise I'll render out something else. I'll just put in a reg fragment for now, like that. And then what I would like to render out is the filter tracks dot map, where we put in a switch, and then based on what status the track is, we render it conditionally. So if the track status is filled, for example, we then render out a red track that says track filled. If the status is no credits, for example, we can then show that this track wasn't rendered because there were no credits. So we can say track dot status, and then we'll say case failed. So if the track status is filled, we'll then go ahead and render out, I'll say return a div with the key, because we need to put in a key because we're inside a map right there. So I'll say key. The key should be the track.id. I'll then just put in and actually one thing we can do is we can hop into the Neon console and then just find our songs and refresh over here. And then I would like to find we already have one that's failed. What I wanted to do was just set the status manually in case we didn't have any failed ones. So we have failed and then processed. I'll just set one to processing as well. And I would like to set one to no credits just so we can test it out, like that. Cool. And then if we hop back in here, and actually while we're here inside this Neon, we can just go ahead and fix the failed ones anyways. So as we can see, there are some failed tracks right here. So I'll just hop back into Neon, and we can see that these ones right here failed. So those were the ones, let me just see, in custom mode. So these 4 up here are going to be the full described songs, that is simple mode. And then we have these were 2 different requests, and all of these then failed. So let's just take a look at why that might be. Cool. So if we start by hopping into the dashboard right here, we can see that we have the call to generate with described lyrics, and we get a 422, so that is a unprocessable entity. So I just spent a couple of minutes digging around, and here's what I found. So hopping into the Inngest development server, if I hop under these failed runs right here, and then go under this, I just want to find wherever I get the response back from. Let me just look around. I just want to find out where I get the response back from the Modal backend, because that should contain something about what was wrong. So I think if I just take one of these, I should be able to find a step.fetch right here, for example. And then this is what we get back from the step.fetch. So this is the call to the Modal backend. So Modal returns to us a detail, type missing, and then something described lyrics. So we're missing the described lyrics. and then it says field required, and then we can also see the input that we actually sent to them. So since the Modal backend is telling us that we forgot to send some fields over, I immediately thought that we had probably sent the wrong request to the wrong endpoint. So hopping inside of functions right here, we can see that this generate from described lyrics is used twice, but actually we should use the correct endpoints. So it seems that right here we are passing in the custom lyrics, and down here we are passing in the described lyrics. So this one seems to be correct. So let's take this one and then just say generate with lyrics, because we have both the custom lyrics and the prompt. And then we can try and save this, hop back over here and just run it again to see if it makes any difference. So I'll just refresh, and then I'll go to custom, and then I'll say write, and then this is the best song too. Then I'll say industrial rave, click create, and then I'll just wait for this to finish just to see how it turns out. So it just finished over here, and it seems to be working completely fine. So we have completed, and then from the step.fetch we see that we get the s3 key back, as well as this cover image s3 key, etc. So everything seems to be working for these two requests. But if I hop back here, we can see that this one and this one gives the same error message, and then these two down here gives two other error messages. So it seems that we're encountering two different errors, because for, let's take this one for example, if we go under set status processing, we can see what it returns. So for this one, we have an instrumental song that is orchestral, and so we have the prompt and we have the lyrics. But if we go back to this one, go under here, we have the instrumental is false, and then we have a prompt, but no lyrics. And then what happens down here is that we get this invalid URL, and that is probably because if I go under functions, which we're already at, that is probably because the endpoint being called is just nothing, because none of these right here are actually being hit. I had to do some digging around to figure out what this problem actually was, and I found that in here in the generation.ts file, I forgot to add one line whenever we create the song in the database. I forgot to add the described lyrics right here, and that comes from generation request.described lyrics like this. Because as you can see, whenever we hop back into this one, for example, then if we go under set status processing, we neither have the lyrics right here or the described lyrics, and we also don't have the full described song. We only have the prompts. So it seems that either the lyrics or described lyrics were provided, but they're not saved in the database. So now that we actually saved the described lyrics in the database, it works completely fine. So just please go ahead and fix this. Otherwise you'll encounter the same error as I did before. And now with these bug fixes, we can go ahead and close generation and also functions, song panel, etc. and go back to creating the track list. So if we have a failed sound or failed song right here, what I want to do is render this right here with the class names flex, cursor, not allowed, then items, center, gap 4, rounded large, and a padding of 3, like that. Then I'll go ahead and hop inside this div, create another one. In here I would like to put in an icon called X circle. This icon should be text destructive, and then also height of 6 and a width of 6.2. And then the outer div I would like to style to. I'll say background destructive at 10% opacity. I'll say flex, height of 12, width of 12.2, like that. Then I would like to say flex, we already have flex shrink, and then 0, items center, justify, center, and rounded medium, like that. So now we have a proper looking icon. Then right below this, I would like to put in another div. Then I'll say class name, minimum width 0, flex 1. In here I'll put in some text. This should be an h3. I'll say generation failed. And then this totally does not match with the actual icon, so we'll just need to style it. So we'll say text. And then destructive, truncate, text small, and font medium like that. So now it matches way better. Right beneath this, I would like to put in a paragraph. Please try creating the song again. And then I'll say text muted foreground, truncate, and text extra small like that. So this is only what is shown for failed generations, and because I tested so many different songs right a couple of minutes ago when I was debugging, we have quite a lot of failed songs right here, but don't worry, we also have some songs that succeeded. So let's go ahead and just implement one with no credits now. Just hopping into Neon, I think we actually updated one to have no credits, so this one should be shown, only a single one, whenever we implement this next case. So for the next one, I would like to just copy the entire case actually. So that is going to be this code here. And then just say no credits as the next case. And I'll then say not enough credits. And I'll say please purchase more credits to generate this song. Like that. And now we should see this down below, not enough credits. Then I'll just take this entire case and copy it again. And then I would like to introduce another case too. This one should be queued, like this. So if you have queued or processing, so processing, these two should be handled the same. So if you just take two cases in a switch statement and then put them next to each other like this, without putting anything into the first case right here, both of these are going to be handled the same. I think it is called a switch fall through if I remember correctly. So in this case, I would like to say loader 2, because if we're currently processing, then we should show the loading icon. Then I'll say processing song ... and I'll say refresh to check the status like that. And then of course we don't need all of this destructive text or this red text. We'll just replace this with bg muted, and then for this destructive right here we can say text muted foreground, and we can do the same for this text destructive right here. And we're then now also able to see the songs that are currently processing. So you see how this is not spinning right now. And that is because we forgot to put the animate spin on it. So we can actually see that it is processing. Then if a song has already succeeded being generated, we're going to show that as another case as well. So down here, we'll just say default. And default means that if none of these cases are the ones, we'll just render it out as the one we define right here. So we'll say return, and then I would like to return a diff with the key being track.id. We'll then style this a little bit too. We'll say hover, bg muted 50, flex, and then cursor, pointer, and then items center, gap 4, rounded large, padding of 3, and then transition colors like that. So now we can see some that are finished processing, but we don't really render out anything yet. We only show an empty slot. So inside this, I would like to render out the thumbnail first of all. One thing though is that whenever we do click this diff right here, so whenever we click one of these, I would like to then play the actual song. So we'll just say on click, and then I'll say, and then I'll just put in an empty function right now, just so we don't do anything. But just know that whenever we have finished implementing this UI and we then implement the play bar, we should then be able to click one of these, and then we can activate the play bar and start the play bar in playing the actual track that we just selected. So right now I'll just leave it empty, and then we'll implement that later on. So first I'll just implement the thumbnail for the song, so just the image. So we can go ahead and say diff, and then inside this one I'll say class name, I can say group, and then relative, height 12, width 12, flex, shrink 0. We can then also say overflow, hidden, and rounded, empty, like that. Cool. Then what I would like to do is say if we have a track dot thumbnail URL. Then I'll just render out an image like that. We can say source track dot thumbnail URL, and then I'll just make an else statement here, rendering a reg fragment. So now we are able to see the actual thumbnail URLs. And then for the class names here, so for example for this one, I will say age full with full object cover like that. And then for some reason, if the object cover is not, if the thumbnail URL is not available, then we'll put in a div where we put a music logo in the middle. So we'll say music, and we'll just import that, and then say class name text muted foreground, and height and width of 6 like that. And then I don't really think we have any of those cases right now. We can just try and trigger it actually. We can say false, so it's going to look kind of like this. And then I'll just style this a little bit by saying BG muted. I would like to say flex age full with full items center and justify center like that. So this is how it's going to look if no thumbnail is present. Obviously it is going to be present, so we'll just go ahead and put it in right there. And we are actually able to implement part of this method up here, the handle track select or whatever we want to call it, where we pass in the actual track. I'll just implement what we are able to implement. So for example, if we do click a track like this, we at least know that we have to get the pre-signed URL for the S3 song, for the song in the S3 bucket. So we can do that and then leave the actual playing to the play bar later on. So just going up here, I'll say const handle track select is equal to an async function that receives a track. So this, and then I'll say track, and then I would like to keep track of what sound or what song that we're currently getting the S3 pre-signed URL for. So to do this, we can say const and then loading track ID. So that is the song that we're currently trying to load. So then I'll say set loading track ID is equal to a use state where we can either have a string or null. And we'll just set this to null per default because we aren't loading any songs per default. So first in here, I would like to say if not, or I'll just say if loading track ID, then we'll return. So we won't really do anything. And we just need to open this up like that. Then otherwise we'll set the loading track ID because now we're actually going to load a track. We'll load it from track.id. Then we'll say const and then play URL is equal to, and then we'll just implement a server action called get play URL where we pass in the track.id. This server action is then going to take the track ID, find it in the database, take the song S3 key, and then get a pre-signed URL for that and return it back to us in the front end such that we can play it. So if we just hop into the server actions, we should be able to do that. So I go into generation, and then I'll go down to write over get pre-signed URL. Then I'll say export async function get play URL song ID string. Then I can say I'll just want to authenticate to get the user's actual ID. So I'm going to go ahead and do that. And then right below this, I'll say const song and try and find it in the database db.song.find unique or throw just to make sure that we actually find it. Otherwise, we should definitely not do anything. Where the ID is song ID. And then we'll say or, so we can put in an or statement right here, where we put in an array of things that can be ORed together. So we'll then say or user ID session.user.id. So this means that the user that are currently trying to play the song actually owns the song because the user ID matches that user. Or we can say if published is true. This means that we try to play the song, but it is another user that owns the song, but it is published, so we can play it because it is public, right? And we can then also say that we would like the S3 key to be not null, because otherwise we can't really play anything. Cool. What I'll then do is I'll say select S3 key true. This way we can get the S3 key out from the S3 bucket and use this function down here to get the pre-signed URL for that. So now I can go ahead and say await before we do this, because this place right here is the perfect opportunity to count one up in the listens for a song. So remember, going into a song, we have the listen count right here. So every time a user tries to get a song, or tries to play a song, we're going to make a request back to our backend anyways. So in this request, we might as well plus this with 1 just to count up this listen count every time a user plays a song. Good. So I'll say await db dot and then song dot update where ID and then song ID. I'll then just say data listen count. Oh, we'll just need to make this a colon. Listen counts, let me just do this correctly. Listen count, and then we can say increment, and we would like to increment this with 1. And lastly, we can return the await get pre-signed URL, where we pass in the pre-signed URL from the, where we pass in the S3 key from the song, like that. And then right now, if we hover this, we can see that the argument is string or null. So that is because this S3 key right here can be string or null. So going over a song, we can see S3 key string or null. But actually what we did down here was that we tested that the S3 key is not null. So it shouldn't even be able to actually be null. So I think that is something that the Typescript language doesn't really pick up. So therefore we're going to just tell it that it is always not null, just so it works. Good. So hopping back, we can just copy this function name, get play URL. Go back here and then import that like this. And then because we have now loaded the actual track, we can just set this to null again, because now we aren't loading anything anymore. And then down here is where we want to play the song in the play bar, right? And then for now, I'll just say console.log play URL, just so we can actually test it out in the console. So over here, if I just I'm just going to refresh quickly, and then I'll open up the console. Then I'll just click this one, for example, and now we see that we have a URL to an S3 bucket. I can click this one too, then we get a URL again, and this one too. Cool. So now we know that we're able to get the pre-signed URLs, and they are also generated pretty quickly. And then if we hover this thumbnail right here, we can't really see that we're able to play the song. So I would like a gray background to be placed over this thumbnail, and then also a hover button, a play button that is white over the gray overlay, just so you can see that we're actually playing. If you then click it while it is then loading, so while the loading track ID is then the song that we just clicked, it should then show a loading animation, just so we know that we did click it, because it isn't instantly loading, so the user shouldn't just sit there and wait without knowing if he's waiting or not, basically. So down here we can create another div, and I'll then say class name absolute, and I can then say inset 0 flex items center. Let me just make this smaller again, and I'll then say justify center as well, just to center everything. BG black at 20% to make this an overlay. Opacity 0. Transition opacity to make a nice animation, and then group hover opacity 100 like this. So because we defined group, let me just find right there. So this div right here defines the group right there. So this means that whenever this entire element right here is hovered, then everything inside of it will be able to define this group hover CSS condition. So this means that whenever we hover this one, we're able to change the opacity right here for a sub element or child element within this. So that is basically what this group hover does. So if I hop over here and then hover it now, we can see that when hovering this thumbnail, we are then able to bring forward this overlay. Then I just want to create a button over that. So right inside this div, I'll just make a condition. I'll say if the loading track ID is equal to track.id, then I will show the loader to icon like that. So I think I'll just need to import that. We did already import it. And then I'll say class name animate spin, and text whites. So I think we have a little issue right there. We'll need to put in an else condition. Otherwise, we'll show the play condition, the play icon, like that, from the seed React as well. So if I hover that, we can see that it's black right now. So we just want to make that white as well. So I'll say class name, text, whites. And now when I hover it, we can see that it is whites. If we then also put in fill whites, we can then see that it is fully filled out. So I think I like this better. And then we can start showing some of the information about the track. So down here, I'll just say div again, and then I'll make a comment saying track info. And then inside this div, I'll just style it a little bit. Minimum width 0, minimum width 0, and then flex 1. Then I'll hop inside this one and create another one. Class name flex, items center, gap 2. Inside this we can put in an h1, sorry, an h3, where we put in the track.title. So now we can see what the title, what the track is called. We'll then say truncate, text small, font medium, like that. And then right below this we can put in an if condition, if track.instrumental, like that. Then I'll show a badge from UI badge, so from ShadCN. This badge should say instrumental, like that. And we'll then just make the variant outline like this. So right now I don't think we have any instrumental tracks. So what I'll do is I'll just hop into the Neon database and then just change one of these. So this one is processed, for example. I'll just set this to true, save the change, and then hop back here. And now, okay, the refresh doesn't work, of course. Now I should be able to see that it says instrumental right here as a badge. So that is what I'm trying to create. Good. Then right below this, I would like to put in the prompt that was used to create the track. So I'll say p track.prompt. And then I can say class name text, and then muted foreground, truncate, text extra small. And now we can see the prompt that was used, and that was industrial array for all of these. So that matches perfectly fine with what we put in. Lastly, we're going to put in some actions that are available for the users to do with each track. So I'll say actions right here, and then I'll say div, close it down again, class name, flex, items, center, gap of 2. I'll put in a ShadCN button here, and then this one should say either published or unpublished, depending on what the status is. So I'll say track.status. If it is currently published, sorry, not status, published right there. If it is currently published, then we'll say unpublish, because it is published, so you can only unpublish it. Otherwise, we'll say publish, like this. And now this looks terrible, so we'll just say variant outline to make it match. And I'll go ahead and say size small, and I'll just say class name, make this a conditional. And then I would like to put in, first of all, cursor pointer, just so we're able to hover it and see that we can do anything. Also do something, sorry. And then I would like to say if track.published, then we'll just color it a little bit red, just so we know that it is an action that destroys something. So I'll say border red 200, otherwise nothing. Good. So right now we aren't really able to publish anything, so I'll just create the functionality for publishing. It is pretty simple though. Under this button, we'll just say on click, and we'll then just get the event. Then we'll say e.stop propagation, and we'll say, and what I'll do actually is I'll hop into the actions, click this actions folder, create one called song.ts. I'll say use server up here in the top. Then I'll say export async function, Because right now, whenever you need to publish, you're going to have to call the server, aka the backend, to update the status in the database. So that is what we're doing here. We're defining an endpoint or a server action where we can do this. So I'll say set published status song ID string published boolean. And then I would like to, first of all, just authenticate the user. So I'll hop into this other one, just grab the lines we used to authenticate with, and just import these free ones right there, and also the redirect. Then I can say await song dot, database, of course, dot song dot update, where ID is song ID and user ID is session dot user dot ID, like that. And we can say data, and then we'll just put in a published status. So whenever you call this, you can set this flag to true or false, and then that is just going to update the status in the database. And then of course, because we're updating something in the database, we would like the dashboard to reflect that instantly. So without the user having to even refresh the page, it should just happen. So we can go ahead and say revalidate path, and we're going to revalidate the create path right here. So it is going to be shown instantly. Good. Going back here, we should be able to call this function now. We'll just say await, and let me just make this async, await, and then set published status, and we'll need to pass in the track.id as well as the published status. So this will be track.published, and then probably just the opposite of that, just to change it around every single time you click it. Now, if I then hop over here and then click one of these, I think we should be able to see it working. So if I click it, it instantly does something in the front end. So that is nice to know. So we can now publish and unpublish as well by simply setting this flag in the database. Then I would like to create a button over here, right to the right of the publish button. So to do this, what I'm going to do is use the drop-down menu from ShadCN, and then inside that drop-down menu, I'll create a couple of items. I'll create one button for downloading the actual file, and then I'll create another button for renaming the song that you just created. So the way we're going to do this is by first hopping into ShadCN, and then finding the drop-down menu. So that is going to be right here. We'll then just take this command and install that. So I'll hop onto our terminal and install the component. And it is done now. So we should be able to scroll down here to right below the button and then put in a drop down menu like that. And I'll then just put in a drop down menu trigger under that, like this. Under this menu trigger, I'll put in a button. This button should say, or actually contain, more horizontal, like that. And that is an icon from Lucid React. So we'll just go ahead and import that and then hop back over here. And then we should be able to see if we save the actual button over here. And then we'll just style this a little bit. So this more horizontal is going to be, actually let me hop up to the button. That should be variant ghosts. And the size should be icon, like that. And then under this button, or even the trigger right here, we're going to create a drop down menu and then content, like that. Inside here, I'll put in, and let me just say align end, and then class name with 40, like that. Then if I click this over here, we can see that we have a menu opening up. So that is what the trigger does. It opens up the content right here. Then inside this drop down menu content, I'll put in a drop down menu item. Then I'll just import that. And then I'll just inside this put in a download icon, like that. And I'll just import this and then say download. So if I open this up, it's going to look like this. I'll make some more spacing though. I'll say class name mr2, So there's a little bit more space in between the icon and the text now. Good. Well, what happens whenever we click the download button? So whenever we click the download button, I want to call the server action we created in here. So that is going to be the get play URL. This will then get the play URL, which we can use to both play the song, but also another thing we can do is that if we redirect the user to that play URL, it is going to automatically download that song. So that is a pretty neat trick which we can use. So hopping back in here, we can go into the drop down menu item. Then we can say on click. In here we can then create an async function because we'll need to await the get play URL. So we'll then say first, let me just get the event, and then say e.stop propagation. Then I'll say const play URL is equal to await get play URL, and then we just pass in the track.id. Then we can go ahead and say window.open play URL, and we can then pass in this blank as well, which will open up the window in a new tab. So what this does is it just redirects the user's browser to this URL right here in a new tab, and then as soon as that happens, it'll start the download and then close down that tab again, so you won't even notice it happening. So let me just try that. If we take this one and then say download, we redirect it instantly, and then it starts downloading up here. So that is exactly what we wanted. Good. Below this, I'll put in another item. So I'll just copy this entire thing, and then I'll call this rename, and I'll then call this pencil right here. And let me just update that import. And the way I want this renaming to work is that whenever I click the rename here, it should open up a modal where I'm able to then rename the song, and then click save, and then it closes down the modal again. So the way I'm going to keep track of what song I want to edit it for is by having a use state up here. So I'll say const track to rename, and then set track to rename is equal to use states, and then I would like this to contain the track, so the track from up here, and then it should just be null per default. So we'll just need to allow null values as well. So I'll say or null. Then going down here, we should be able to set that value. So if we remove this, we can then set the set track to rename and pass in the track whenever you click the rename button. And right now, of course, if I click here, nothing is going to happen. So we'll need to conditionally open up a modal if this value is not null. So now we at least have the menu. That was pretty quick to implement. So now let's go ahead and implement the actual modal. So scrolling down here, right on the outside, I'm going to say track to rename if that has a value and it's not null. Then I'll create a component called rename dialog like this. And then we'll just need to, of course, create this. So I'll just hop under components, and then under create, new file, rename dialog.tsx. Then in here, I'll go ahead and say export function, and then rename dialog. And I would like to pass in the track, what happens on close and what happens on rename. So when you press save, rename like this. And then for the types of these, we'll say track. Well, that is a track. And then I'll just import this, the on close. That should just be a function returning void. And the on rename should just be a function that takes, let me just see, the track ID and the new title. So that is what we need to update it in the database. We need to update this track with this new title, and then it is just going to return void like this. And then over here we can open up the function. Let me just see why it is bugging out. I think we put in a semicolon or something. Maybe that is why it doesn't work. Oh, or actually I need to put in this one right there. Cool. And this one, new title, should of course also just be a string like that. Cool. And then inside this function, and also I'll just make this a client component just because we'll use hooks inside of it. Then I'll just say const and then title and then set title. So this is the new title which we'll enter. And then I'll say use states track.title. or nothing if it is not set. And let me just import this use state here. And then down below we can say const handle submit. So whenever we create this input field down below and we submit that, then we're just going to do a couple of things. We'll receive an event, we know that, of type reacts.form events. And then inside this function, I'll say e.prevent defaults. Then we can say if title.trim, like this. So if the title trim is not nothing, so if it's not an empty string, then we'll say on rename and call the function from the parent that was passed down, pass in the track.id and also title.trim that removes leading spaces, etc. And then we can say on close and then close down the modal again. So that is what is going to happen whenever we click save. Then we just need to actually create the dialog. So we're going to need the dialog component from ShadCN. So dialog is right here. And then I'll just get the installation command, go to terminal, paste it in. And now it is ready. So I'll go ahead and import this. I'll say return dialog from UI dialog. And I'll then say open and we'll just set it to true like this, because this component right here is only being shown if the track to rename is set to anything else than null basically. So it'll just always be open. And then we can say on, open, change. We'll then say on, close. Now let me just hop back in here so we can check it out. Then I'll say rename. And then I think we just need to define a couple of things here before we can actually see it first though. So let me just import this and then we can pass down the different parameters. So the first one is going to be the track obviously, and this will be the track to rename. Whenever we just want to close it, we can just say set track to rename and set that to null. This means that this will be false and therefore it is not going to be shown anymore. And lastly, we just need to say on rename and then create a function that will call a server action and then rename the actual song. So I'll just hop into the song.ts, copy this entire server action, and then call this rename song, like that. And then for the song ID, that is going to be the same, but then we all want to pass in a new title. And then we also want to change this to title and new title. So we obviously pass in the user ID right here because we only want the user to be able to change his own songs. If the user just found the URL of this server action, if that is possible, and then passed in a song ID and then a new title, he wouldn't theoretically be able to just, without this, he wouldn't theoretically be able to just rename anybody's songs. But because we have this auth check right here, the user is only able to rename his own songs. And that is because we have this user ID in the where clause. Good. So now we can just check out the title. That should be a string, of course. And now that should work. So going back to track list, we can then pass this in. We can say rename song, and then we need to pass in the track.id, and we need to pass in the new title. So we'll say title here. Let me just see track ID and new title. So track ID and new title. Then we pass in the track ID and the new title from the dialog. Cool. Then we import this right here and go back into the rename dialog. So if I go ahead and say rename, then I think it is shown right now. We don't really have anything in here though, so we just need to make it visible. So I'll say dialog content. Then I'll say class name is equal to SM, so on larger devices, or so mobile or more basically, max width, and then 425 pixels. Let me just check that out. Close this right here. Then we can put in, and now we're able to see the dialog. Good. Then we can say form, so we want to create a form, and then we can then say on submit. Then we'll handle the submit, which we defined earlier, so this one. And then inside this form, we can put in a dialog header. We can put in a dialog title. This should be rename song, like that. And then for the dialog header, we'll just import that too. Then for the dialog description, like that, we'll say enter a new name for your song. Click save when you're done, like that. So if I just close this, click rename. We're able to see the header and also the description. And then under this dialog header, I'll just put in a div that is a grid. So I'll say grid gap 4, py of 4 as well. Then inside this, I'll put in one more div. This should also be a grid. So I'll just pass this one in right here. Then I'll say grid columns 4, items center. And I'll remove this right there. Good. Now inside this div, I'll put in a label. This label should say title. I'll then just say HTML4, name, class name, text rights, like that. So this HTML4, let me just see why it is bugging out. So this is the Radix UI label. I thought I might be able to actually use that, but apparently it's not 100% compatible with ShadCN. So we'll just go ahead and find it over here and just install the right one. So that is going to be this one. I'll install that. And then let me just see. I think we have the input, but I'm not 100% sure. So I'll just go ahead and install that as well. Then down here, we can then use the correct label. So not the Radix UI one, but instead this one from UI label. This will be title like that, yeah. Hopping back in here, we're now able to see the label. And then for the input field, we'll say ID should be name. And then we'll have something like a value that is going to be the title. And then on change, we're going to have an event and set title either target.value. And then let me just see. We obviously need to just import this, that is why. Then down here, we can just say class name, column, span, free, like that. And now if I just open this up again, let me just see what these issues are, by the way. Button cannot be a descendant of a button. So I just looked into this for a second and I figured out that we need to add an as child here. So I'll say as child. This way we won't have two nested buttons, so that should fix that. Good. So if I refresh over here, let me just see the error is gone. Perfect. Then if I go ahead and open this rename up again, we can see that we can now move on with what we were doing. Good. So right now there are no save or cancel buttons, so we obviously want to just implement that. So I think below this div right here, we can put in a dialog footer. We can put in a dialog, let me just see, close. Yep, like that. In here we can put in a button. This will say close or cancel. So I'll just import the footer and the button. And then the button should be type button. Like that. And we'll then also just say variant outline. And let me just open it back up just so we can see how it looks. So now we have this cancel button. If I click it, it closes like it is supposed to. Good. Then next to the cancel button, I would like and let me just, because right now we have this button and then also a dialog close, which is also a button. And the problem which we encountered before was we had two nested buttons. So what I would like to do is just add this as child up here as well. This way the button becomes the dialog close and we won't really get this error which we just saw down here anymore. Let me just hide this again, it's kind of annoying. Good. So the next thing I would like is an actual save button. So under this dialog close, I'll put in a button again and then say save changes. And then I'll say type submit. And then because this type submit is inside the form where this on submit is defined, this button right here is going to trigger the following and then save the actual song. So let me just say new song name 1 and then save changes. Now we see that it changes right here. If I then refresh the page, it is still changed because it is persisted in the database. And then one more thing is that if we go to this track list, right now we have an empty rag fragment in case, I think it's when there's no more music tracks. So let me just turn this around just to trigger the other case. So yeah, if there are no more tracks, this is what is going to be shown, which obviously isn't optimal. I want some kind of empty state. So therefore I'll put in a div right here and another div. I'll say class name, flex column, items center, justify, center, pt20, text center as well. Then inside this one, I'll put in the music icon. I'll say class name, text, muted, foreground, h10 and width 10. And then under this, I'll just put in an h2, no music yet. And then we'll just style this so it looks a little bit nicer. MT4, text large, font semi-bold, like that. And below this, we'll put in a paragraph. And then depending on whether we have a search query that is the reason for there being no tracks or not, we'll then change the actual contents of the paragraph. So I'll just go ahead and do this. I think I messed up a little bit there. So I'll go ahead and hop into this paragraph and then say if there is a search query, and because we're inside this statement right here, we also know that there are no results. Well, then that is because the user entered a search query that yielded no results. So I'll then say no tracks match your search, like that. Otherwise, we'll say create your first song to get started, like this. And then for this paragraph, we'll say class name, text, muted, foreground, and we'll say mt1 and text small, like that. Now, if I then go over here and just make this uppercase, like that. If I then put something into the search, it says no tracks, or so no tracks match your search. If it's just an empty state, so there's no tracks and also no search, we'll then say create your first song to get started. And then this will obviously only be shown right in the start when the user creates his profile and then starts using the tool. So going down here, I'll just turn this around again. And now it works just like normal. Good. And then we talked about this refresh button earlier. So let me just go ahead and implement that. So we'll create a function down here, maybe right there, and say const handle refresh is equal to an async function. We'll say set refreshing. So we'll need to just create a state for that. Set is refreshing, like that. Set this to true. Then we'll say router, and we'll just need to use this hook, So const router is equal to use router from next navigation. Then we can say router.refresh, and we can then say set timeout and just create a fake timeout for about a second. So this won't immediately just stop loading, but we can actually show the user that something did load. So I'll just go ahead and do this, set refreshing. And we'll set refreshing to false after 1 second, like that. And then we just need to copy this, find the refresh button. I think that is this one right here. And then call the handle refresh whenever we do that. Good. So now if I click refresh here, it loads for a second, and then it stops. And the cool thing about this is that if we take this, describe your song, and then put in dreamy lo-fi, and then say create, and just wait for that to finish. Right now when we refresh, they are still processing. Also over here in the Neon database, let me just refresh this. We can see that they are processing and queued. And in the Inngest dashboard, we can also see running and also queued. But whenever this first one is done, we'll be able to click refresh right here without refreshing the entire page. And then we should be able to see the status change. So I'll just wait for that to finish over here, and then I'll go back and refresh it. So this first one just finished. So let me hop back here, and we can see that it is still processing. So now we can click refresh and then see it appear like this. And then of course the second one is going to finish at any time now. And then we'll be able to do the exact same thing for that. So now this other one should be about done. So I'll click refresh. And now that one is clear, is ready as well. Now I would like to create the soundbar down here, and before we just create the soundbar, I'm going to create something called a store, and a store is kind of like a use state just shared between different components, so a global use state basically. And I would like this store to contain the track that we're currently going to play, and then I would like it to contain a function that we can use to set that track. This means that regardless of the component you are in, you can then set the soundbar down here to play a specific song by calling a specific function. So the thing we're going to use, the library that we'll use to create this store is called Zustand, like this one, and then we'll just go ahead and find the installation command. I think you might be able to find it here. And it's probably just npm install Zustand. So we'll just go ahead and paste it into the terminal. And then we should be good. So what you do is you create a store like this, and a store is basically just a hook that you have defined yourself with some states and then also some variables, some functions that will then allow you to mutate that state. For example, if you call this increase population, you'll count up bears by 1, so this one will increase by 1. So we'll have a state variable containing the track that should currently be played, and then also a function that then takes the track that should be set in the soundbar, and then that will be able to play a track. So going back here, what I'll do is I'll hop under my Explorer, then I'll find the source folder, create a new one called stores. In here I would like to create one called use player store.tsx, or actually it's going to be a .ts file because it won't render any React inside of it. Then I'll first of all create an interface that we can use to tell the store what data it should work with. So I'll say interface player track. So right here, when designing this interface, I'm thinking about what data the soundbar down here is going to need to be able to play a track. So what should it have? Well, of course it should have some ID of a track in case we're going to need that. We also want to show the title of a track down in the soundbar. So we'll just set that as well. I'll say string on null. We're also going to need some kind of URL for where to play the track from. So this is going to be the pre-signed URL from the S3 buckets. We're going to need some kind of artwork. This is going to be the thumbnail that we can show down here in the sidebar for the track. And then we're also going to probably show a prompt. This way we can see which prompt generated the track we're currently listening to in the soundbar itself. And then if we could put in the created by username, this is going to be the name of the user that created the track, and this way we can see both the track name, and then right below this we can show the actual username. Cool. Then we'll go ahead and say interface player state. This is going to be the state of the store itself. We're going to have a track first of all. This can be a player track or null if 0 tracks should currently play. We can then say set track. This should be another function. And then I'll say track, and to start playing a track you'll need to call this function, pass in a player track, and we'll just return void. And then to create the actual store we'll say export const use player store is equal to create, and we'll need to import this from Zustand. So going up here we might need to do this manually actually. So import create from Zustand like this. We can then set the actual Typescript types for the store. So this will just be the player state right here. Then we'll say set and create the store like this. Track should be initialized to null as the first value, and set track is also required. And we can then define what it does. So whenever you call this set track, it should just call sets and then set track to track. So this is just going to be a colon like that. And then this should be enough for creating our store, so the global use state, which we can use across components. Good, so I'll just close this down because now we have it ready. And then I'm going to create a specific component for showing the soundbar down here. So I'll hop under components and then just create one called soundbar.tsx. Then I'll say export, and this will be a client component, so use client, export defaults, soundbar or function, soundbar like this, and we'll just return a React fragment for now. Then we can copy the component, hop into layout if that is open somewhere. So I'll go into layout right here under main, and then right below this main here we can then put in the soundbar like this, and this will then render the soundbar in the layout that we have created. If I put in hello, maybe we will be able to see it. Yep, so we can now see that hello is right here beneath both this list of tracks and also beneath the sound panel. And if I do this, it'll then fill out the full width of the screen like this, so it'll work completely fine. On mobile, it is going to look like this, so it'll still take up the full width of the screen. Cool, so one of the first things we can do is we can actually grab the track that should be played within the soundbar from this player store we just created. So I can say const track is equal to use player store like this. And then now we have access to the actual track. And then if the track is not null, we should probably grab the URL from that track and then play it inside this component. And then I'll slowly start building out the actual soundbar now. So I'll go ahead and put in a div, say class name px4, padding bottom 5, like this. We can then also put on bg background at 60%. We can say relative width full. We can say shrink 0 and border top, py 0 and backdrop blur like this. Then if I just make this a little bit smaller again, or maybe just large enough such that we can see it. If I put something inside of this, like a paragraph that says hello, this is then what it's going to look like. I would like to put in a div. Inside this div, let me just close this up. Inside this div, I'll put on in some classes, space y2, padding of 3 like this. And then inside this one, I'll create a top row, so this will contain track info, controls, and additional controls as well. To do this, I'll put in a div, I'll say class name, flex, items, center, and justify between, like that. Inside this one, I would like to put in some track info, so I'll say class name, flex, minimum width 0, flex 1, items, center, and gap 2, like that. Then we can, inside this one, put in a div more, and then flex age 10, width 10, flex, shrink 0, items, center, justify, center, rounded, medium, bg, gradient, to br, like this. And we can say from purple 500 to pink 500, like this. So this is going to be the background for the thumbnail. Now inside this one, I would like to put in, I'll say track.artwork. So if this is available, then I would like to render out an image. This image tag should have the source track.artwork like this. And we just need to add an else statement too. So in case it is not there, I'll just put in this music logo right here, and then say class name text white, just so it looks a little bit better down here. And then for the image itself, we can go ahead and say class name age full, width full, rounded MD, and object cover like this. And I'll then make this a card actually. So we should be able to import a card from ShadCN if we do not have it, if we have it installed, sorry. So going up, I'll just find the card, install that, hop on the terminal, install the card, like that. And then I should just be able to import it like this. And now we see that we have this card down here. I'll actually just wrap this in a div as well. And then just give this some padding, so px4, which will make it fit a little bit nicer on the x-axis, and then pb2, just to push it up from the bottom a little bit, like that. Then I'll just create the container for containing the title and also the credit by. So down here we can say div, like that, and say class name, max width 24, minimum width 0, flex 1, md, max width full. Inside here we can put in a div, we'll say class name, truncate, text small, font medium. Inside this, we'll say track.title or untitled if it is not the case. So I'll go ahead and put in this one right there. This way we can actually see the title of the track. And then I think I made this look a little bit ugly earlier, so I'll just go ahead and remove this one right there, and also the padding bottom 4, because we did that anyways in this parent container right there. So that should make it look way better now. And I think we actually did set the track title to untitled if a title was not able to be generated. So I'll just keep this as it is right here. Then below that, I'll just put in one more div, and I'll make this a paragraph actually. Then I'll say track.created by username, and I'll just style this a little bit. I'll say class name, text, muted, and then foreground, truncate, and then text extra small, and we'll just make this a paragraph too. So right there, and right here as well, like this. And then right now we obviously aren't able to test it out because you can't really click any of these to play a song. So I'll just hop into the track list and then just implement this part right here that'll then play the song in the play bar. And what I mean by that is that it's going to use the insert the song or the track into the play store. So I'll just go ahead and say up here, const set track is equal to use player store, and I would like to be able to use this set track function right there. So now we should be able to call set track, put in the ID, that is track.id, title is track.title, URL should be the play URL, the artwork should be the track.thumbnail URL, the prompt should then be the track.prompts, and lastly the created by username should be the track dot and then created by username, like that. And then I'll just spell it correctly actually, so I'll just go ahead and fix that inside the store. So if I just rename this, that should work now. And then this should actually set the track. So I'll just go ahead and remove this console.log. And then if we go in here and then just refresh over here just to make sure that it is fresh. If I then click one of these, it then sets the thumbnail, it sets the title, and it sets the created by username, which are the properties that we currently show in the HTML. And then I would like to create some centered controls as well. So some controls right here where you can like pause the track, etc. So what I'll do is I'll just say centered controls, because I feel like it's getting kind of messy up here with all those divs. And then I'll put in one more right there, say class name absolute, and we can use absolute because the parent up here somewhere has a relative on it. So that is this one right here. So this way we can go ahead and go down to absolute again. And then I would like to just say left. Oh, actually let's just implement what is inside of this div. So that is going to be a button. And this way we can actually see what it looks like whenever we change the positioning. So let me just import the button, say variant outline or ghost probably, like this. Then I would like to also put in a size. The size should be an icon. And we can say, and right now actually the button shouldn't really do anything because we haven't implemented the player logic. So I'll just go ahead and put in a play symbol from Lucid Reacts. And now we're able to see that symbol right there. And I would like to position that right here in the middle. So that's why we use this absolute positioning relative to the relative in the card. Then I'll say left 1/2. I'll then put in a minus translate x 1/2, and as you can see over here now, it moves it moves 1/2 of its own width to the left, just such that it is completely centered right here in the card. And then we'll just create a state up here for tracking whether we're currently playing something or not. So we'll say const is playing and set is playing. So even though something is loaded into the store, so a track is set within the player store, it might not be playing down here actually, because you can still pause and play the sound. So we still want to keep track of that specifically in a use state. Therefore we can say use states false, like this, and just import that. Then down here, based on what state it is, we can set a play or a pause button. So I'll go ahead and say is playing, and then we'll set a pause button like that. Otherwise we'll set the play button from before. And then I'll wait with implementing the on click for this button right here because we don't have the player logic implemented in the component yet. So I'll just come back to this. Then we'll create some additional controls over here, such as a volume slider and also a button you can click to open up a menu to download the actual file from the soundbar itself. So I'll hop down here and just say additional controls like that. Then I can put in a div, class name, flex, items, sensor, and a gap of 1. I can put in one more div with the class name, flex, items, sensor, and a gap of 2. In here I'll put in the volume, and I'll take number 2 from Lucid React, save that, and now we can see the volume down here. I'll just go ahead and say class name and then height of 4 and width of 4, so it's a little bit smaller. And then I'll do the same for this one actually. So I think, let me just copy this right here. And then I think it's up at music right there. So if I paste this in and save, now it is the correct size that it should be. Then going down here, I'll just do the exact same for these two components because it's kind of weird that they are more than the height and width of 4. And then for the actual slider itself, so the one you can slide up and down to set the volume with, we'll use the slider component from ShadCN. So hopping in here, we'll just find the slider that is going to be, let me just find it right there. So it's going to look something like this. We'll use this component both for the play bar, but also for the volume knob. So I'll copy this and then just paste it into our terminal here, like this. And now that is installed, so we'll hop under the volume here, import the slider from the correct place, of course. So that is going to be this one. Then I would like to say, value, and we'll then need to create a use state for the value. So we'll say const volume set volume, and this will just be a use state, and the default value will just be 100. So it should be turned all the way up from the starts. So this should be volume right here, and then on change, I think it is. I think it's actually on value change when it is this slider component. Then we'll call the set volume function, and then let me just see what it is complaining about. Type number is not assignable to number. Yeah, so this is kind of weird. We'll have to hop up here and then put this into an array like this, and now it is going to work just fine. But let me just go ahead and continue with this. I'll put in a step. The step should be 1 and a class name of width 16 like this. And now we should be able to slide it like this and then store the value inside the following use state right here. And we'll then also just set a max value to 100. Does it have a min as well? 0 like this. And now if we slide, it should still work again. On mobile too, this soundbar looks pretty decent as well, and we can still slide the slider. And then for the menu next to this one, I'll just go ahead and create a drop down menu like we did before. So early on, I'll then put in a drop down menu trigger, and I'll say schild because remember we got an error last time we didn't do that. I'll then put in a button, and then I'll say more horizontal as the icon, and then we should have this icon right here. Then for the button, I'll say variant ghosts, and I'll say size icon like that. And then for the more horizontal, I'll go ahead and say class name, width of 4 and height of 4 too, just in case it is not. And then right below this trigger, I would like to put in the actual drop down content. This should be a drop down menu item. We'll say download as the icon. So let me just import this and say class name mr2, height of 4 and width of 4. And we'll just put in some text too. We'll just go ahead and say download down here. So whenever we open this up, it should say download. And for the content right here, I'll just say align end, and I'll say class name width of 40 like this. Good. Then for this download button, we're going to implement an on click. So I'll say on click. And in this case, I'm going to go ahead and say window dot and then open, and we'll put in the track.url and open it in a new tab where we say blank like that. And I think that should be it. Let me just see what it is complaining about here. So let me just say if not track.url, then we return and do nothing like that. So let me just try and download this track. So if I just play this one and then I go over here and say download, then it downloads the track like it is supposed to do. Great. Then lastly, down here at the bottom, I would like one big slider that allows us to control how far in the song we are, so we can skip between different parts if we would like to do that. So I'll just say full with progress bar for song like that. Then I would like to put in a div, say class name flex, items center, gap 1. I can put in a span right here and then say class name text, muted foreground. I can say width of 8, text right, text 10 pixels like that. And then the actual progress of the progress bar down here is going to be a single number, probably between 0 and then the end of the song. So we're going to track this number with a use state up here. So let me just copy this and put in 0 right there, and then call this something like current time and then set current time. So current time is the progress in the song. But if we just take current time, it is just going to be a single number. But what I would like to do is to format it something like this, 00, 00. So this is the start of the time, and maybe it plays until, I don't know, 00, and then 15 seconds, for example. So this is a different way of formatting it than just the current time, which is a single number. So I'm going to go ahead and create a function for actually formatting this number to something that we can show the user. So I'll say const format time is equal to time number, and then time right here is going to be seconds, just like current time right here is seconds. So the way we format seconds to the format I showed you just before is to first get the amount of minutes and then the amount of seconds. So I would like to say const minutes is equal to math.floor time divided by 60. Then we can say const seconds is equal to math.floor, and then we'll say time modulus 60 as well. So let's say there is, for example, 125 seconds. So current time is 125. Then the minutes is going to be, minutes is going to be 125 divided by 60. This is going to become 2. So we'll have 2 minutes right here. This should then be formatted as 02. And then the seconds is then going to be 126 modulus 60. So this will be 6. So we can say 6. And therefore the seconds should be 06. And then the final format should be 02, 06, like this. And also the reason we get to 6 right here is because 126 can be divided 2 times by this 60 right here, and then the rest is going to be 6, and the rest is then going to be the seconds. So that is how we are going to get to this format. Now we just need to create the string for actually formatting this. So we'll say return, create a formatted string, and then I would like to put in the minutes first of all, say .toString, and then we will pad the minutes with the character 0 right here. So we'll say pad start, and then we would like to put in 2, and I would like to, so we pad it with this character right here with a max length of 2 of these characters. So let's say there is 6 minutes, for example. Well, then it will be padded up to the length of 2 by zeros, so therefore it's going to look like this. If it, for example, said 12 right here, the max length is already 2, so it is not going to be padded by this. And this is a way to keep the format right here 2 digits. Good. So now I would like to do the same just for the seconds. So I'm going to take this, paste it in right here. then say seconds like that, and then we should be all good. Next, we can scroll all the way down to right below this span. So inside the span, I would like to put in the format time function and then format the current time right here. Then I'll put in the slider right below this span. So I'll say slider, and then we'll say class name flex1. And now the slider is going to take up the full width like this. And then this is the start time. And this down here is then going to be the end time. So here we'll need some duration, and the duration will just store in a use state up here to be determined. So I'll say duration and set duration as well. Good. So going down here, we can now pass in the duration, and the value of this bar right here is then going to be the value of the current time. So we can go ahead and say value is equal to, and then current time, like that. And we can say max should be the duration or 100. We can then say we step 1 second at a time, and on value change. So on value change, whenever you do this, what I would like to do is then seek in the sound. It is called seeking. So seek like this whenever we want to change the place in the sound that we're currently listening to. So we'll say on value change. In this case, we'll call a handle seek function, which we'll just create up here. So I'll just go down here and then just create this handle seek. So const handle seek is equal to, and we'll receive a value, which is a number like that. So a number array. And then in here, whenever we set up all the logic for playing the actual sound, we'll be able to do the seeking. But now we're at least able to go down here and then see the play bar. We aren't able to actually drag this because right now the seeking doesn't work. But if I click right here, it loads in a song, and then we still aren't able to seek anything or play, but we have the entire soundbar working like it should, or at least looking like it should. That's what I mean. And then to play the song in the HTML, we're going to create an audio element. So we'll say const audio ref. So this way, if we create this audio ref right here, we'll be able to set the song in the HTML whenever we click a song like this. So we'll have to say use ref, and this will be an HTML audio element, and we'll set it to null per default. Then going all the way down here to the end, then right inside the card, I'll put in an audio HTML tag. I'll say ref, audio ref, like this. This means that we can control the audio being played from this HTML tag right here. We can then also say source is equal to track.url or nothing, if that is the case. So let me just say, go ahead and do that. And we can say preload metadata as well, like this. And then to get the actual playing working, we'll go up here and then start by creating a use effect. So we'll say use effect, put in a dependency array consisting of the track only, meaning when the track changes within the storm, we're going to do something inside this use effect, aka run the code. So we'll go ahead and say if, and then audio ref and track.url. We can then say set current time, set this to 0. So we'll reset the time and also the duration for the new track, and then I'll say set duration 0. Then we can set the new source and also load it. So we'll grab the track's URL and then load that from the data source. So that is going to be AWS. I'll say audio ref dot current source. Sorry, the current dot source is equal to track.url. Then we can say audio ref dot current dot load, like this. And up here, I'll say dot current, like that. And then whenever you change the track over here, I would like it to just play automatically. So we'll just go ahead and set it up as well. So down here, we can say const play promise is equal to audio ref dot current dot play. And if we then hover this right here, we can see that it is a promise. So we'll need to await this in some way. So I'm going to say if play promise is not undefined, then we'll say play promise dot then Then we can say set is playing to true, because we are playing whenever this has resolved. And then if this for some reason fails, so if we get a catch, what we'll do is just say console.error, and then we can say something like playback failed, and just put in an error description as well. So this will be just comma error, like that. And we can also just set is playing to false, because it shouldn't be playing if an error happened. So let me just try and click one of these now. Good, so as you could hear, it was playing right there. I wasn't able to pause it or seek it or anything, but it was playing because it started playing automatically. So we at least now know that it works as it is supposed to. So that is great. Then down here at this place right there, we pass in this if the URL is null or undefined. So I'll just see if I can get around this by maybe doing this, and then only render this out if the tracked URL is available. So like that. And then if I refresh over here, I think we should be good now. Otherwise we'll come back and then fix this if it doesn't work. Good. Now the first thing I would like to be able to do after just creating this symbol playing is to be able to actually toggle playing. So click this to pause or play. So I'll say const toggle play is equal to a new function where we say if not track.url or not audioref.current, then we'll return first of all. Then we'll say if is playing. Then we'll say audioref.current.pause. And we'll say set is playing to false. Else we'll say audioref.current.play, like that. And we'll say right below this, set is playing to true, like this. So if we are already playing, we start playing via this audioref, and also tell the user that we're playing via our use states. And we do the opposite if we are currently paused, because then we'll just start playing. So let me just try this again and see if it works now. So I just forgot to actually call this method right here. I was a little bit too quick. So going down to the bottom, we can go ahead and just say on click and then pass in this toggle play right here and then try again. So I'll just load in a track now. And now I'm able to pause and play like I wanted to. So that is good. Nice. Next we can implement the seeking mechanism. So that is whenever you drag this this progress bar down here, then it should change the position in the track. So I'm going to say if audioref.current and value 0 is not undefined, then we'll say audioref.current.current time is equal to value 0, because value 0 is what we get out from the progress bar down here as the current value, and we'll say set current time to value 0 as well. So it'll both update the time in the song that we are listening to, but also set the time that we're showing in the UI. And I think we're already using handle seek down here, so we should be good to test it out. So let me just try and do that. I'll just play this one. Actually, I'll just seek straight away, because we are able to, and you can see how it changes right here. And if I then play it too, the music. So the seeking worked just fine as it is supposed to. And now the duration over here still doesn't work, as you'll probably be able to see. We haven't really loaded that metadata into any states yet, so we can go ahead and do that. So I'll create another use effect that handles loading the metadata. So if I just copy this entire use effect right here, paste one over this one, and then I remove all the contents of it, like this, I should be able to say const audio is equal to audioref.current, and I can say if not audio, then we return Then I can say const update time is equal to a new function, and then we say set current time to audio dot current time, like this. And then this function right here that we define, and I think it just started playing automatically because I hit spacebar or something. So I'll just go ahead and refresh to make sure there's no songs inside the stall. And then over here, I'll just call this function whenever we hit a certain event. So we can go ahead and say audio dot add event listener, and then time update. Then we'll say update time. So whenever this time update event is triggered, then it is going to call our function right here and then set the time from where the audio currently is in our use state, just such that we'll be able to show it to the user. And then we'll just need to unsubscribe to these events as well. And we'll do that down here by saying audio dot remove event listener, time update, and update time right there as well. Good. So this was the first event I wanted to listen to. I also wanted to listen to the load metadata event. So we can go ahead and hop up here and then say update duration. That is also going to be a function. Then I'll say if, and then is not, and then we'll say is not a number, audio dot duration. Then we'll set the duration to audio dot duration, like that. And we'll just subscribe to this event down here as well. So we'll say loaded metadata, and let me just copy it down here too. So this should be update duration, and this is how it should look. Lastly, I'll listen to an event so that is called ended. So this is whenever the track finishes playing. So when it reaches the end over here, it is going to trigger an event called ended, and then we'll set the is playing to false and also set the current time to 0 to restart if you want to listen to it again. So I'll just say const handle track end. That is equal to a new function 2, and I'll say set is playing to false, and I'll say set current time to 0, like that. And I'll just subscribe to the event. I'll have to do this above. Then I'll just subscribe to the event down here. It is called ended, and I'll just paste in this handle track end as the function being called, so the callback function. And then if I hop over here and refresh, and then I click one of these, this one for example, we see that we're able to see the actual duration of the song over here. And if I drag it all the way over to right before the end and just let it finish, then we can see that it stops playing and restarts the progress to 0. So that is what we wanted. Good. The next thing I would like to do is to listen to changes in this volume knob over here. So this one, and then actually adjust the volume with this knob, because right now it doesn't do anything. And the way I'm going to do this is by creating another use effect that listens to that one specifically. So I can say use effect, and we can then go ahead and say if audio ref dot current. Then we can say audio ref dot current dot volume is equal to volume 0 divided by 100. And we'll do this every single time volume changes. So every time you change the value right here, we're going to set the volume of the audio ref, so this element down here, and we'll set that to the actual volume now. So let me just try and save this, and then play over here. So now we're able to turn the volume up and down, so that works as well. And now the soundbar is about done basically, so we're able to actually play songs, etc. But I want to do one more thing though, because if we reload over here, we can see that the soundbar is shown even though we aren't really playing anything, and I don't think that makes much sense. So I would like to go down here and say if not track, and then I'll return null, meaning we won't render the soundbar at all. So I can go ahead and do this. And then this means that over here, the soundbar is not shown at all, but if I then play a song, the soundbar pops up and we are able to both see it and also use it. Another thing is that it also works perfectly fine on mobile, as you can see right here. So we are good for responsiveness as well. Next, we can get started with the home page over here. So if I just click the home page, we can see that we still have this default C3 stack background, and that does not look very much like a home page to me. So what I would like to do is just close all of these things down and just keep this page.tsx open. Then we'll copy this one over here, all the contents of this one to the page right there. And if I then save, go to home, we should have the exact same thing on home over here. So I'll just remove this and just return a single div like that. And then let me just see, I think this is called homepage. I'll just call this page, and I'll call this page 2, just for good naming's sake. And then over here, if you press Shift, Option, and then MO, you're going to clean up all the different imports. So it's going to be much cleaner and only import what you need up here. So you can do that to make it look nicer. Good. So over here on the homepage, I would like to have a dashboard full of all the published songs. So I'm going to make one big database query and then get the 100 most recent songs, or at least the 100 most recent public songs. So I'm going to say const, or first I'm going to say const user ID is equal to session.user.id. Now we should be able to use this user ID to query out the songs from the database. So I'll say const songs is equal to awaits database. I'll just import that .song.find many like this. I would like to find songs where published is true. I only want the published songs, otherwise everybody can just listen to everybody's songs, and that is not what we want. Then I'll say include. And I would like to include the user name for each song. So user, select name true. And then I would like to also go ahead and say underscore counts. And then select likes true. So we can get the amount of likes, because remember, this is a many-to-many relation. So we'll get the count of rows of likes for each song. And then we can also say categories true. And then to get the newest one, we'll say order by, and then created at like this. And I'll say descending. And this will just have to be done right outside the include. And right below this, we can say take 100, which means we take the 100 newest. And then we'll get all the pre-signed URLs for these 100 songs for the thumbnails. So to get this, we'll say const songs with URLs. So remember how we did this earlier, where we created a premise.all call. So I await premise.all. Inside here, we'll say songs.map. And then we can say async song. And we can say const thumbnail URL is equal to song.thumbnail is free key. If that is the case, we can say await get pre-signed URL, where we pass in the song.thumbnail is free key. Otherwise, we just say null. Good. Then we can also, let me just finish this correctly. Then we can say return, and then song and thumbnail is free key, thumbnail URL, to add that to the keys in the dictionary as well. So this means we'll have all the same properties as we did up here, but we'll also just have the thumbnail URL, which is the pre-signed URL, to actually show the thumbnail over here in the dashboard. Then in the top of the dashboard over here, I would like to show the trending songs. And obviously you can filter trending songs by many different things. I'm just going to take the 10 most recent songs, but you probably want to do a mixture of recency and also likes. I'll just first of all just get the ones from the last 2 days. So I'll say const 2 days ago is equal to new dates. Then we can say 2 days ago dot set dates, 2 days ago dot get date -2 like this. And then we'll just create a list called trending songs, which contains all the songs after this date right here. So we'll say const trending songs is equal to songs with URLs dot filter song dot created at more than or equal to 2 days ago. And we'll then say dot slice 0 to 10 to only take 10 songs if there are more than 10 songs that are less than 2 days old. And then the trending songs is obviously only going to be a single category up here. And then we're also going to have other categories such as rock, hip hop, etc. And these categories will be based on the actual categories returned from Qwen, the large language model, in the Modal backend. And one thing I would like to do is not include the same songs in multiple different categories, because they might do, especially when we're testing right here, with only a single or maybe a couple of users. So I'll take the IDs of these trending songs and then make sure that those IDs are filtered out from the other songs that we'll categorize later on. So I'll say const trending song IDs is equal to a new set, and I'll say trending songs dot map, and then I can say song, and I'll then get the song.id for each song, creating a list or a set of strings like this. And we can then use these to filter these songs away later on. Now I would like though to create a list of categories where each category has a number of songs within it, so we can show it in the dashboard over here. So each category has a headline such as hip hop, for example, and then also a set of sound within the category. So I can say const categorized like this, songs is equal to songs with URLs dots filter song, if not trending song IDs dot has song dot ID, and then I can say and song dot categories dot length is more than 0, like this. Then we can continue our change statement right below. So each song has a list of categories attached to it. So for example, the large language model, whenever we generated the songs, also generated maybe 3 or 5 different categories for the song, such as hip hop, rock, indie, etc. So this will be a list of those categories, and we want to make sure that this list of categories is actually 0, because otherwise we won't be able to categorize the song. So we'll filter away any songs where this list of categories is 0, even though it in theory probably should never happen. And we'll also filter away songs that have already been identified as trending songs up here, because we don't want to show them again. So right down below we can say dot reduce, and then we can say ACC and song. So reduce right here is used to reduce a full array to a single output value by iterating over every single element inside this list right here. So this categorized or what this filter returns, and then applying a reducer filter to each one of these. And what I ultimately want out is a record or set that then has a string, and this is going to be the name of the category, and then also the different songs as an array, something like this, as the value of this set right here. So this song right here is the current song that we're currently iterating over, and this ACC is an accumulator, and this will then accumulate a series of values over these steps, so over each iteration. This means that this right here is then going to contain the entire record in the end. Good. So what I would like to first do is just find out the category that is primary. So I can say const primary category, and then I'll just say song.categories and just take the first one, quite frankly. Then we can say if, and then primary category, because we do index into a list that we don't really know anything about, so it can be undefined, as you can see right here. Then what we would like to do is say if not accumulator primary category dot name. So if the category isn't existent in the accumulator already, then we'll just go ahead and create it. So we'll say ACC primary category dot name, and then we'll set the list of songs within that category to just be an empty array like this. So this means we can then create the category now, and after this we'll be able to actually push the songs to the category. So we can then say if ACC primary category dot name dot length is less than 10. Then we'll say ACC primary category dot name, and then we'll say dot push song like this. I think we just need to add this exclamation mark right here, and then after this we'll need to return the accumulator. And then the reason we're getting all these errors right here is because we haven't really defined the type of this accumulator, so we'll have to do that as part of the reduce, as one of the reduce parameters as well. So down here we can say the accumulator should be of type dictionary, and it should be s record, and then we can say string, and we can then say array, and the array should contain, so the value of this dictionary right here should contain, so we'll just say type of songs with URLs, and we'll say number like this, and I think we'll just need to make this a right chevron as well. Then right after this we'll put in this one, and it should be working just fine, because now the accumulator has the type that we expect right here. So what this basically does right here, this part that looks a little bit complex, is it basically just makes an array of song objects. That is just what it does. So now this categorized songs variable right here should contain a set of different categories. Each category has its name in the string right here, and then it contains a list of songs within each category, and it is an array, as you can see right there. Good. So right below this we can check whether the category amount of categories and trending songs is 0, because if that is, we'll then show an empty state. So we'll say if trending songs dot length is equal to 0 and object dot keys categorized songs dot length is equal to 0, then we'll return a diff, and I'll just say class name. So first of all, I'll just test this out by just returning true. So I'll say true like this, and then over here I can say class name flex age full flex column items center justify center padding of 4 text center. Inside here I'll just put in the music logo first of all. I'll make this text muted foreground and height of 20 and a width of 20 as well, to make it really large like this. Right below this I'll put in an h1 saying no music here, and I'll then say class name mt4 text 2xl font bold and tracking tight like this. And then right below this I want a description, so I'll put in a paragraph saying there are no published songs available right now, check back later, just so we have some kind of empty state. And remember, nobody's probably going to see this except for maybe the first user of the system, because once this first user has published the song, well, then the empty state will be gone. So this is going to be used maybe only once ever. Cool. So for the paragraph we'll say text muted foreground and mt2 like this, and this should then be enough for the empty state. So I'll go ahead and just remove this and bring back the actual state right here, and then if I just save and refresh, hopefully we shouldn't really see this empty state because we have created songs before. So if I just hop over to create, we are able to see all of these different songs. I think we just need to publish them though, that was where I went wrong. So I'll just publish these ones, jump back into home, and then the empty state is gone because now we suddenly have categorized songs available. So we just need to render those out. So I'll go ahead and say diff class name padding of 4. Inside this I'll put in an h1, say discover music. Inside this h1 I'll put in the class names text 2xl font bold tracking tights, and I'll just say save right there. I think that should be good enough. Cool. Then just let's make this 3xl like this. And then right below this, I would like to put in this section of trending songs. So I'll just say trending songs, and I can then just say trending songs dot length is more than 0. And in that case, we'll create a diff. This diff should have the class name mt6 to space it a little bit apart from the actual headline up here. Then we can put in an h2, say trending. This H2 will just say text Excel to make it a bit smaller than the headline, and font semi-bold, like that. And we can then render out the individual songs. So first we'll create a container for that. So we'll say class name, then we'll say empty form, grid, and then grid columns 2. We'll say gap x of 4. We'll say gap on the y-axis of 6. And then this amount of gaps right here is largely dependent on the screen size. So we can go ahead and say on smaller devices and above, we'll say grid columns is going to be 3. And then on even larger devices, we'll set the grid columns to 4. And on larger devices, and I can just start copying this now so it doesn't get tedious, we'll set the grid columns to 5. And on Excel, we'll set the grid columns to 6, like that. Great. Then inside this, we'll just go ahead and say trending songs, like that, dot map. And we can go ahead and render out each song. So first I'll just put in a paragraph and just say song dot, and then something like the, let me just see, the name right there. And then this will give us the name of the actual songs. Right now this doesn't look very great though, so we'll create a component for rendering out each song such that we can reuse this component both for this category right here, but also for every future category coming after this. So let's get started with the actual song card component now. So I'll hop under components, and then I'll say something like home. I'll just create a new folder first of all. So I'll say home right there. Inside this one, I'll create a song card.csx. This will then be a client component. So I'll say use client, and I'll say export function song card. And I would like to pass in some properties for this component right here. So we'll go ahead and define these actual properties up here. First of all, what we would like to pass in are the properties of, is the song right here. And this is kind of a mixture of a bunch of different things. So we'll go ahead and just recreate that type in here just so we can pass it down and get the types working. So I'll say type, and then I'll say song with relations, because this is a song coming from the database that is equal to the song from Prisma right here. So the client generated song type, and we'll then join that together with, and then we also have the user, that is name, that can be a string or null. There is also the, and we'll just make this curly braces instead, like that. And then we also have the count of likes, count likes number, like this. That is another one. I think we have something weird going on up here. And then below this we also have the categories. This is just an array of category from Prisma client right here. And we also have the thumbnail URL, which is a string or null. So these are the properties we would expect whenever we pass down a song, a track or song to this song card. So we can now say song, that is equal to, that has the type song, song with relation, like this. And I just put it in the completely wrong place. We just gotta put it in right here. Good. And then the next thing we'll do is we can actually use this song card inside the component. So we'll go ahead and just import the song card, and then pass down the song as the song. And then the types should be matching. Let me just see what it is complaining about. So it's just complaining that we aren't returning anything in this component, which is completely fine because we are nuts. So what we're building right here is a full card for showing the song, and I would like to return a div as the root element. So I'll say return div. Inside here I'll put in another div, and this div I'll say class name and then cursor pointer, just so that the user knows that he's able to click the entire card. And then I would like to be able to, make the user able to click the card, and then it should play the actual song just like it did when we clicked a song inside the crate right here. So here, for example, so it should work the exact same way. So therefore I'm going to create a function up here called handle play, const handle play, and we'll just need a loading state. So we'll say const and then is loading and set is loading is equal to a use state like this. And we should then just set this to false by default. And then we can just copy how we used the store in the song panel, I think it was. So under song panel right here, if we hop up to, it was the track list right there. And then we should be able to get this set track and use the same hook, just so we're able to use the set track method from the store. And we also would like to just get this one right here and paste it in under handle play. And I think we pasted in one too many of these. And then this set is loading is just what it's going to be called, with true and with false right here somewhere. So I'll just remove this part and get the awaits working. This should be asynchronous. This should be song.id instead of track.id. And then down here, what we'll do is we'll just call this right in the end. And this will then be song.id. And then song, 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 and song right here. And then we'll need to put in the user.name. And then for the artwork, we have a little problem. This is a string null or undefined over here. We can see that this is not assignable to the type string or null. So let me just go in and make the types match. So artwork should be able to be string, null, or undefined like this. And then the type should work fine. Now, if we then click one of the songs down here, we'll just put on this on click. So we'll say on click, and then we'll pass in this handle play such that if the card is clicked, then it's going to play right away. And then over here, we're just getting an issue where we aren't passing in any key properties to the song card because we're inside a map. So we'll just go ahead and do that. So here I'll put in a key, and the key should just be the song.id, just so it is unique. And then going back in here, we see that the error is gone. Now we can then create a div for the thumbnail. So we'll say div right here, class name, group, relative, aspect, square, and with full, overflow hidden, rounded medium, BG, gray 200, and group, hover, opacity 75 like this. And now we have the different cards. So these are the trending songs basically. Inside this we'll say song.thumbnail URL. So if that is available, then we'll put in the image. And the image will have a source. This will be the song.thumbnail URL. And let me just see what it's complaining about here. It should be a question mark. And then we also need the else statement with if this is not available. And in that case, what we'll do is we'll put in a div. And then inside this, we'll put in the music icon. Just import this if it is not available. And then for this, let me just make this false so we can test it out. So for the div, what we'll do is we'll put in class name bg muted, flex, age full, with full, and then item center and justify center, just to center this music icon right here. And we'll say text muted, foreground, age 12, and with 12 as well, like this. So this is how it is going to look if there is no thumbnail, but obviously the thumbnail is probably going to be there almost every single time. So just so you know that. Good. We also need to put in some class names here, because right now the thumbnail is looking a little bit weird. So we'll put in the age full, we'll put in the width full, object, cover, and object center like this. If I then just refresh over here, we should be able to see the thumbnail popping up like this. And I like how these how these cards are pretty big and take up a lot of space on the screen, because this makes it really cool to look at. And also see how on larger screen sizes we're able to see more columns like this. So that is what we set up a little bit earlier whenever we set the dynamic column count base on the screen size. Good. Then below right here, I would like to put in another div, and this should then be a loader state. So whenever you click one of these, it should bring up that gray opacity background, just like we saw in crate. So if I just hop on the crate and then hover this right here, we're able to see that it brings forth this gray background, dark background, and also the play button. And then whenever I click this, it should then play the actual song and then show the loading state while it is loading. So I want to do the exact kind of same thing in here, just a little bit larger. So what I'll do is I'll create a new div, and then I would like to say class name absolute, and then it is absolute relative to this one right here. And then we can say inset 0, and we can say flex items center, justify center, bg black 50, opacity 0, transition opacity, and we can say group hover opacity 100. And let me just see if it works over here already. Yeah, so now we can bring forward the black background like this, and then inside this we can put in the actual play button, for example. So we'll put in a div first of all, then we'll say class name, then we can go ahead and say flex h12 width 12, items center, justify center, rounded full, bg black at 60, transition transform, group hover, scale 105, like this. And then inside this, let me just make this open up. I'll put in an is loading conditional, and if we are currently loading, I'll just show the loader icon. So I'll just say loader 2 from the seed React. Otherwise, we'll show the play icon also from the seed React. And then each one of these should have the class names width 6 and height 6. And also the loader right here specifically should have animate spin and also text whites. So I'll just copy this class right there, paste it down here, remove the animate spin, and this one should also be fill white actually, because it is the play button. Then if I hover over here, we're able to see the play button as well as this round circle around it, so it looks like an actual play button. And the round circle of course comes from the HTML element right here. Then we should be able to put in the title of the song, and I would like to put it just below the actual image down here. So that should be right here. So I'll go ahead and say h3, put in the song.title, and then I can say class name mt2, truncate, text small, font medium, text gray 900, like this. So now we can see the title of the actual song. And it's going to look like this on the different screen sizes, so it still looks fine. And then we can put in the paragraph with the song.user.name, and then just style that a little bit as well, because we want it to be smaller than the actual song name. So we'll put in text extra small. I'll put in text gray 900 as well, like this, and make it 500, yeah, so now it's a little bit less and prominent right here in the layout. Good. Then we can put in a div with the actual likes for the song. So we'll say class name mt1, flex items center, justify between, and then text extra small, then text gray 900. And then I would like to put in the listens to the left and then the amount of likes to the right, along with the actual like button. Then if I go ahead and add the listens first, this will be a span, and then we'll have the song.listen count, and then listens, like this. Pretty simple stuff. Then for the actual like button, this will be a button like this. Then we can say heart. Inside of that, just import the heart. Then just to the right of the heart, we'll put in the like count, likes. So this will be a use state in our case, just because we want optimistic updates such that when the user clicks this right here, it should immediately just turn red. So therefore we'll just both update it in the backend, but then immediately also set it to true or set it to be liked in the front end. So we'll go ahead and say const is liked, and then set is liked. This will be a use state determined on the amount of likes. So we can say song.count.likes is more than 0, then it's going to be true, otherwise it is going to be false. And then also we can set the likes count and set likes count. This will be equal to a use state with the song.count.likes, like that. And then scrolling down, we can say likes count and then likes. And now we're able to see the actual likes. And then for this heart right here, this is going to be the actual like button. So I would like to put in some class names, make this a conditional, like that. Then we can put in a height for and width for always. And then if it is liked, then we'll put in fill red 50 or 500, sorry, and text red 500 as well. Otherwise we just put in nothing. So if it is liked and right now we can't like it, it is going to look like this. Otherwise it is going to look like this. And then we'll just hop into the button and say flex, cursor, pointer, items, sensor, and gap 1. So it's going to look like this now, where the heart and then the likes is right next to each other instead. And now we're just going to implement the actual method for liking the song, and this is the one we can attach over here to the on click. So we'll hop up here and then implement that. We'll say const handle like is equal to an async function that is going to receive a React mouse event, like this. Then we can first of all say e.stopPropagation. So whenever we do like something, we'll set is liked to the opposite of the current value, and we'll set the like count to, if we did like it, then we'll set like count to +1. So we'll go ahead and do this, likes count plus, if it's already liked and we are removing the like, then we'll deduct 1 from the likes count. Otherwise we'll set the likes count to +1 like this. And then this is only doing it client side. We also need to save this in the database as well. So we'll just hop under the song server action right here, and then just copy this server action. Then down here, we'll say toggle like song, and we'll only pass in the song ID like this because we won't need to set anything specifically. Cool. Then we can just remove this revalidate path and then revalidate the home instead of the creates. Then we'll say const existing like. This will be equal to await database dot like dot find unique, where the user song ID has user ID and song ID like this. So this will then give us whether the user has currently liked this or not. And the user ID is just going to be the session.user.id. So let me just see session up here. .user.id, like that. Cool. Then if the user has already liked this song, we'll go ahead and remove that like. Otherwise, if this is not existent, then we'll go ahead and add a like because the user hasn't liked the song before. Then we'll say if existing like, then we'll await database.like.delete, and then we'll just put in the exact same conditions. So this one right there. And then otherwise, so else, we'll say await db.like.create, and then we'll pass in the data with these conditions right here. And then what I'll do is I'll just save here and then copy the function name, hop back into the song card, and then we should be able to actually toggle this like song in the database as well by awaiting the function or the server action. So we need to pass in the song.id, so we'll say song.id ID like that, and that should toggle it in the database as well. We of course just need to take this handle like though, and then put it down on this button, on the onClick. So in that case, we'll just call the handle like. And now if we click like over here, we should be able to like a song like that. So it seems to be working completely fine. And then if I like these two songs, for example, and then refresh the page, they are still liked whenever the page is refreshed because they were liked in the database as well. Good. And we should also be able to click one of these to play the actual song. So if I click, then it starts loading and the song starts playing. So that works fine as well. Good. So now the song card is basically done, and we can go ahead and use that in the different categories here in the page.tsx. So that is what I'll do. Next, I'll copy this part right there. That is just for showing a category. And then right under this part, I would like to show the different categories. So categories like this. Then we can say object.entries to loop through a set or a list of categories. Then we can say .slice to take the first 5, because I would like to only show 5 right now. And then we can say map. And then for each one of these, we'll get the category, the songs, and we can then show what we just copied right here. So trending should then be the category name. So this will be the actual category name. And for the songs right here, that should be songs, not trending songs, like that. And then if I save over here, let me just see if it does anything. Right now, I don't think we have enough music to be able to actually test out this feature, so that is quite fun. I'll hop under create and then just see if we get enough if I just publish these ones right here. Because remember, I think the trending songs had 10 different songs. And then, okay, now we have enough. So now we have about 13 songs, I think. Sorry, 11 songs. So the first songs are right up here. And then the ones that are not included in the trending category will then be included in the hip hop category down here, because they belong to this hip hop. And then I see we have an issue where it says each child should have a unique key prop, and that is this one. So we'll say key is equal to, and then the category, like that. If I then save, refresh, the error is gone now, and we're still able to see this category view. If I like one of these, that works as well, and I can also play these. So that works completely fine. If you are on mobile, it is going to look like this. You can scroll down through the different categories, so I think that looks just fine as well. And now I would actually argue that this dashboard page is done. Just for now, it is pretty simple and it works just fine. So I'll hop into this layout actually, and then just change a couple of things, because right now it says create T3 app. So I'll just say homepage, and then this should be music generator. And I'll just remove this. And now it says home up here, just like it should. One cool thing I would like to show you as well is that because we're using BetterAuth UI, if you click down here and then click the settings, we'll be taken to some settings for the user's account over here. So we have the account and also security, and then we're able to set both the password, manage our sessions, and then also change the name, email, etc. I'll just go ahead and hop back, and right now I'm using the back buttons on my mouse because we don't have an actual back button up here. So I actually just want to create this back button. So this is under the auth route and then slash something such as settings. So we'll just go ahead and create a back button if we are on the auth slash settings page. So let me just hop under the auth view right here and then go under view. That is the client component that will then wrap the page. And let me just hop under again, right there. And then in here, I would like to, first of all, get the router as a hook. So we can say const router is equal to use router, like this. And this allows us to click a button and then go back or page back to the previous page. And that is exactly what we want to. So then I'll just create a button. So we can say button like this. And then the button should say back. And we should have an arrow left icon just to show that the user is able to go back. If I then hop back into the settings, we now see this back button. And then I'll say class name self starts, like this because we're inside flex, and we can then also say variance is equal to outline, like that, and now it matches the design a little bit better. And we can say on click, and when we do click it, we'll say router.back. So let me just click this button now. It'll then take us back to this page. And one more thing I would like to do is to only show this actual button on this route right here, so settings, because right now if you go into sign in, for example, we also see this button, and that does not make sense. It is only when we're already logged in and we navigate to this page via that user button, for example. So the way we can do this is by copying this button or just clipping it out. Then we can say settings, and then probably also security. So if you hop under security right here, we're able to see that this is another page of itself. So account is one settings, and then security is another one right here. So both of these should be covered. So if that array includes the path name, like this, then we'll render out the button. Like that. So now if I hop under settings, we can then see the back button like we were last time, or were able to last time. But if we go to the sign in page, the back button is gone. So now it works completely fine. Cool. So let's just close back down view, because now that part is done. And then also the page here. I also just want to test out the music feature, or sorry, the publish feature right here. So if I publish a song, it should be visible to other users, but my current songs that are not published should, for example, not be visible to other users. So I'll just hop in here to create, then unpublish a couple of my songs. So let me just unpublish these ones. So right now I have 5 songs published. So we can see 5 different songs right here. So if we log in with another user, only 5 songs should be published as well. So what I'll do is I'll just open up a new incognito pane like this. Then we can go to localhost 3000 again, and then sign in, or actually sign up. So we'll say test like that. And then we can say test maybe 1@gmail.com, and we can put in a password. And now we are able to see the 5 published songs right here. One thing that is a little bit weird though is that even though we have a new account, it looks like we are the ones who actually like these songs, while it is not us, it is the other user. So in this case, the red should be gone because we haven't liked the song personally, but it should still say 1 likes right here. So I'll just hop back into the code and then try and figure out why that is. So I just went into the page.tsx for this dashboard page right here. And then first of all, we aren't really using this user ID. So I can just go ahead and remove that first of all. And then second of all, we only get out the count of actual likes. We don't get out who liked the people, or sorry, who liked the songs, but I would like to do that as well. So down here, I'll say we'll include the likes as well. And then we can say if the user ID is available, otherwise false, like this. So if the, let me just grab this again, user session.user.id, if that is available, then we'll say where user ID matches the user ID. So user ID right here. And this means that we get the user's own likes out because we have this where clause right there. Otherwise, we don't include this right here because we set it to false. So no likes are fetched as well. Then down in the song card, we need to also enable being able to pass this down. Because right now, let me just scroll up and just see. Let's just go here. If we then hover this categorized songs right now, we have the likes right here. So we just need to allow the likes being passed down. So right here, I'll say likes. The likes should be of type like from Prisma as an array. And then whether the song is liked or not, so whether we show the red status or not, depends on not the total amount of likes, but the amount of user likes. So if the user liked it or not. So we'll say song.likes, and then if that is the case, we can go ahead and say song.likes.length, is more than 0, otherwise we'll set it to false. So if I now hop back into the incognito pane right here, and then just refresh, we're even able to see it now. We can see that the song is actually liked, but we aren't the ones liking it. So if I then click like right here, then hop back into this other one and refresh, now it says 2 likes right here, but we also liked it. So if I just remove mine again, then hop back in here, we still liked it, but it only says 1 like now. So now this mechanism actually works as it should. Then the last thing I would like to test is just creating some songs with this new user, the test user. So I'll just say something like a rap song about water bottles, like that. And then I'll just click create. And then in a couple of minutes, I'll just come back whenever this is done. So it should be finished up over here. So I'll go ahead and click refresh, and then I'll publish these 2 songs. And then right now in the home page, we can see that the songs are published. And then if I go back and refresh my homepage over here, we then are able to see the songs that aren't mine. We can see test down here, and we can also see our own songs. So now we know that the publishing functionality works as it should, which is good to know as well. So I'll just go ahead and close down this song card and also paste the TSX. I'll now set up the payments with Polar, and that integrates very well with BetterAuth, so it should be pretty simple to set up. Let me just close down all the different folders and then hop under, I think it's right here, Auth.ts. And then in here we should be able to set a couple of things that will then set up Polar.sh for us. First, I'll just search for Polar.sh, Polar and then BetterAuth, like this. Then I can go into the guide from BetterAuth about how to set up Polar as well. So first we need to just add the following installs. So I'll open up my terminal right there, and then I'll put in npm and then install BetterAuth. We already have that actually, so we'll just go ahead and remove that package. And then we'll say Polar.sh, BetterAuth, and Polar.sh /SDK. So these are the 2 libraries which we'll install. And then we have this Polar access token right here, which we'll need to set inside our environment variables. So I'll put it in, and then just also add it under my typed environment variables. So down here, I'll put in the Polar access token, and I'll add it down here as well, like this. And now we should be able to get this from the Polar dashboard, or at least the settings page from it. Good. Next, I'll just scroll down a little bit down here. So I'll just get the actual access token before we move on. So I'll just search for Polar.sh, hop under here and just create an account quickly. I'll just continue with GitHub. And I immediately want to go to sandbox mode down here. So you can click go to sandbox. This will allow you to test everything without having to actually pay with real money. It's just a testing environment, but it works just like it normally does. So we'll have to continue with GitHub and log in again. And then I would like to create a new organization here. I'll call this music generator for me. You can call it whatever you would like, whatever you want your business to be called. I'll then confirm and click create and just wait for the creation to work. Then I can click skip, and we can go under products and then set up 3 products. I would like 3 different credit packs, a medium, small and large, each giving a specific amount of credits. So the first one should be the large credit pack. This should give 50 credits for creating songs like this. And I can then make sure that this is a fixed price of $20. I'll then create this product and just press accept right there, and then call this a medium credit pack. This should contain 25 credits, and this will also be a fixed price of $15 instead. And I'll create that. Then I would like to create a small credit pack too of 10 credits, and this should be fixed price of $10. So the more you pay, the more credits you get, but you get like way more credits if you pay just a little bit more. That is the basics of how this pricing here, right? It works. Then if we go under settings and then go down, we can then create this new token here. So this will be the token for the Next.js application. It'll have no expiration and have all the benefits. I'll copy this, put it into this one right here. And now we should be able to continue with the actual tutorial. So hopping back to right up here, if we then go into Auth.ts, we can create this Polar client. So I'll have to paste this in and then import Polar. So that is going to be the following import right here. Then I'll just remove all of these comments. And because we're in the sandbox environment, we'll need to set the server to sandbox. I'll then just remove this process.env and then use our typed environment variables like that. And then we can scroll down a little bit more and then define this plugin. So right here, if I copy, I think it's right there, copy the plugins and then go down to right there, we should be able to paste that plugin in and then import Polar as well. So that is going to be this one. Then we are able to set up Polar here. So first of all, we have the Polar client and we have then set the create customer on sign up to true. This means that whenever a user is created within BetterAuth, it is also going to automatically create a customer within the Polar database. So it is also automatically going to go in here and then create a customer. Normally we would have to do this manually with Stripe, but we don't have to do that anymore now, which is pretty neat. Then we can just input the products that should be shown during checkout right here. And then we can also set the success URL. So I'll just set the success URL to this right here, just so it takes us to the dashboard. And we can only check out if we authenticated. So that is why this is set to true. Then hopping into Polar, going under products, let me just copy the product IDs. So this is going to be for the small credit pack. And I'll call this small. And just remove these comments. And then the second product, so I can just copy it twice actually. The second product is going to be the medium one and will then also have large like that. The medium products will be this one and the large credit pack will be this one right here. Then down here, we also enable a couple of things. Let me just go down. Oh, and then Polar. I'll just scroll down again. And then we don't want this usage enabled because we don't use the usage feature, but we do want the portal enabled and also checkout and also webhooks. So portal is then a portal that the user can use to manage their auto subscription and granted benefits. So that is just a user portal basically, or a customer portal. And then we can just define our webhooks straight away inside this auth.ts file as well. So I'll go ahead and just remove this just because it's very messy. And then I would like to define the one I want. So the secret, I'll set to env.polaraccess_token, or this will actually be a webhook secret. So if I hop into Polar, we just need to generate a webhook secret. So under webhooks, we can add an endpoint, and we want to listen to on order paid specifically, because when an order is paid, we can then grant the user his tokens or his credits. And then we would like the payload to be raw, so just JSON. And then the URL will need to do a little workaround to get working. So because we're testing locally right here, BetterAuth Polar.sh is not going to be able to send a request or a webhook back to our local host server because it doesn't really work that way. So we're going to need a middleman that can accept the webhooks and then redirect those or forward those to our local server. So we're going to use something called ngrok to do that. So we'll go into ngrok and then I'll just say sign in like this. And we should then be able to just log in with GitHub here. So I'll just go ahead and log in. And then we'll just need to install this locally as well so that we can receive these endpoint requests. So first we'll need to just hop into our terminal here. So that is this one. And then just install install ngrok. I already have it installed, so it shouldn't really take very long. But just go ahead and paste this command in to install it. And then you can also run the following command. This will create this ngrok.yml file so we can interact with the actual ngrok from our local computer. It'll just authenticate our PC basically. So I'll go ahead and paste this in as well. And now we should be able to just run this command basically, which will then forward requests to specific endpoints. So I actually think if we search for Polar.sh and then ngrok, they recommend this themselves. So down here we can see developing locally. Use a tool like ngrok to tunnel webhook events from your local development environment. This will allow you to test webhook handlers without deploying them to a live server. Once you have ngrok, you can easily start a tunnel. So we need to run the following command right here. So I'll just go ahead and hop into npm scripts and then add another script under def, and that will be the command. And then I'll say Polar webhooks. And then that command should then allow forwarding requests from Polar.sh to our local environment. So let me just run this. I'll just say Polar webhooks. And then we can see that it's currently running. So let me just get the full URL right here. That is this one. So we'll need to send our Polar webhooks to right here. We'll need to send it to the following URL. So that is the URL right here. And then I think I closed it now. So raw and then order paid. And then we'll need to forward it to /API/auth/polar/webhooks like this. And then that should then be able let us be able to receive these webhooks. So then I'll click create. And then whenever we create a webhook, whenever a webhook is sent, we should then be able to see it both down here, but also we should be able to see something happening within our development server. So I'll just close back down the terminal and then hop into this guide again. So next up, if we scroll down, we can implement the specific webhook that is called onOrderPaid. So down here we can say onOrderPaid, and then we can define the function that should execute whenever that happens. So we can go ahead and do this. Now inside here, whenever we receive this webhook, it is because a user has bought something and paid for it. So first I would like to get the external customer ID. So we can say const external customer ID. And an external customer ID is the ID of the user in our database, because remember, the user is also going to be in the Polar.sh database. So that is the internal ID, but our database ID is the external customer ID. And this is then stored on the order as data like this, that customer.external ID. Then we can say, let me just hover here. It can't be null, so we can say if, and then not external customer ID. Then I'll go ahead and say console.error, and then no external customer ID found. And we can say throw new error, no external customer ID found. Like that. So now we know which user bought something, and now we need to figure out what the user actually bought. So we can say const product ID. So remember, we have the product IDs up here. So we know that this, for example, is the large pack. So we can give the user 50 credits if this is the product ID that he bought. So we can go ahead and say order.data.product ID. Then we can say let credits to add be equal to 0. And then depending on which product ID it is, we can go ahead and add a different amount than 0. So we'll say switch and then product ID. Then we can say case and then put in, first of all, the small credit pack up here. So if it is a small pack, we'll set the credits to add to become 10 and then break this case. And I'll just repeat this 3 times. And then for the medium pack right here, it was 25. And for the large pack, it was then 50 credits, like that. Cool. Then right below this, I'll say awaits database.user.update. And then I would like to give the user where the user's ID matches the external custom ID, the actual credits. So I'll say credits, and then I would like to increment the user's credits with the amount of credits to add. And that should be what we need to actually give the user the credits that he actually pays for. Good. So scrolling down further here, we can see that we need a BetterAuth client where we also register this plugin. So we have this, I think it's within the following folder, Auth client. In here, we'll just need to add the following line, plugins. And then we'll need to import this Polar client right here. Then scrolling down, we also have some other configuration options, but I think this that we've done right here is what we actually need. So we can start by redirecting the user now to an actual checkout. So if we, for example, start with this button, the upgrade button, right now it doesn't do anything, but we can make this redirect to an actual checkout. So going down here to upgrade, I'll go ahead and say const upgrade, make this a function we can call. And I'll then say await auth client dot checkout. And then I would like to check out and have the user be able to pick between the 3 different products. So that is going to be these 3 again. So we have the first one here. We have the second one. And we have the third one as well. That is this one. And whenever we call this, we then get a URL, and I also think it redirects automatically. We can actually just go ahead and put it into the on click here, and then paste in the upgrade. Now, if we then click the upgrade button over here, then just refresh to make sure it's fresh. Then I'll click upgrade. Then we're taken to the actual checkout page now, and we see that we are in sandbox mode, so everything is fine, no payments are processed. And we can pick between these 3 products that we just defined. So that is perfectly fine. And then right now, if I just click upgrade again, actually, you see that we're able to input the email right here. And the reason is that if we go under Polar and then under customers, right now no customer has been created, even though we have a user. So inside this auth, we say that create customers on sign up needs to be true. Is set to true, but because we created a user before setting up Polar, this is not going to be the case. So I'm just going to delete my user. So I'll say sign out, hop under Polar, hop under Neon. Then I would like to find the user table, that is this one. Then take my 2 users and just delete those. And then if I hop back in here, then I can create a new account again. So I'll say Andreas, and put in the password. And now I have 100 credits again. But then if you go into Polar, we can then see that the user was created, or the customer was created automatically. So that is us. And then if I click upgrade now, we can then see that this email is automatically set. So we won't be able to just put in another email. So now it works like it should. Then for the card number, we'll put in the card number like this. Put in an expiration date, a security code, and you'll just put in 4242, and this has to be in the future, and this doesn't matter at all. And then we'll put in the country. I'll just put in Denmark, and then I'll click pay. And then we can actually open up our terminal here and just see if we receive anything. So under dev, we can see that we get an error right here with BetterAuth. API auth Polar webhooks, no matching signature. So one thing I definitely know that I forgot now is that we have forgot to take this Polar webhook secret and then set it in here. So under Auth.js, we have the Polar webhook secret. We use the Polar access token right here, but we need to use the webhook secret. So hopping under the tutorial again, we can see that under the webhooks, we're able to find the Polar webhook secret and not the access token. So let me just paste this in under Polar webhook secret here. And then let me just create this webhook secret under my environment again. So right there, and up here as well, like that. And now I should be able to reference the correct one, Polar webhook secret. And then let me just try again over here. So if I just refresh, and then also if I make this larger, we're able to see that we get this bad request. So let me just see if the environment variables reloaded over here. So I'll just take this and actually restart it. I'll say dev. And then if I click upgrade again, and then I try and pay, so I'll just click pay. Then we can see whether we get the same bad request, because then it is not that problem. But at least I know that this was a problem, because we totally cannot just forget to set this right here. Then it's definitely not going to work. Okay, so I see that we get 110 credits now. So that seems to be working just fine with Polar. Also in the end grok, we can see right here that we get a 200 OK, which also lets us know that the request was successfully forwarded and also got a 200 back. Good. So that is that for the payments with the upgrade button right here. We also want to just create a customer portal. So down here, if I click this customer portal, remember how we just didn't implement this in the start? Well, we'll just need to go ahead and do this. So if I hover this customer portal, we can see that the link becomes /customer portal. So we'll just go ahead and implement a redirect from that page to an actual customer portal. So let me just hop in and then create a page for the customer portal. So under app, main, then I would like to create a folder, customer portal. In here, I'll create a new file, page.tsx. And then I would like to just say, let me just grab something from another page. This one, for example. And then I would like to paste this in. Then we can import the auth, we can import the headers, and we can import the redirect right there. So this just checks whether the user is logged in or not, because we only want the customer portal to work if the user is logged in, otherwise we won't even do the redirect. But we're also going to need a client component, and then we'll create a session for the customer portal and then redirect the user to that, and then that will happen as soon as the user enters this page. So if I hop under components, and then I go to, let me just say new folder. Actually, I'll just make a new file, call this customer portal redirect.tsx. In here we'll say export defaults function, and then customer portal redirect. And then we can create a use effect. And then this means that this is going to be executed as soon as the component loads. So as soon as the component loads, and we'll just need to make this a client component too, because we are using a hook, the use effect. As soon as this loads, we'll go ahead and create a customer portal. So we'll say const portal is equal to async, and then await auth client from lib auth client dot customer dot portal. This will create a session for the portal and also redirect the user to that. And then we'll call this function, up here whenever this loads, so whenever the page loads. And then just so the user can actually see something and know what is going on, we'll just create a small loading state that says loading customer portal. So I'll say class name, flex, age, screen, with full items center, and justify center like that as well. And then inside this, I'll put in one more div. Then I'll say class name, flex, items center, gap 2. In here, I would like to put in a loader 2 and make this height 5 with 5, animate spin. So this one, and I'll then also put in a span saying loading customer portal dot dot dot. And I'll just put in some class names, text, muted, foreground, like that. So now if I just take this component, hop into the customer portal and return this customer portal redirect. If I then go down here, click customer portal, we are redirected to this page, and then we can see customer portal loading. And then we're taken to the actual customer portal here, where we can see both our previous orders. And then if we had usage enabled, we would be able to see usage, and we also have payments, settings with payment methods, and our billing address, etc. So this is pretty useful for the user to see as well. Now I am back here on the home page, and I can see that we have 10 credits more. And the reason we have 10 credits more is because we created this, we paid for 10 credits earlier, and then the webhook failed. So we see these 400 with the webhook failed because we had an error, and then webhooks are then retried a couple of times until Polar gets a status 200 back. And this is why it was a little bit delayed, but we did get our credits in the end. And with this out of the way as well, I think we're ready to go ahead and deploy the application, because now we are basically done with the application logic. So let's get started with that. I'll go ahead and close all of my different tabs here. And then what I would like to do is open up the npm scripts, and then I'll hop up to the linter. So this one right here, lint. And then I'll just run this, because whenever this build step runs on the cell, it is going to automatically also run this lint step. And if the linting fails because of any because of any errors, the build step on the cell is going to fail as well. So we'll just have to fix these errors right here, and then we should be good. So first of all, we see the following right here: prefer knowledge coalescing operators instead of assignment expressions, as it's simpler to read. So instead of first checking if the category doesn't exist and then adding the category if it does exist, what is possible to do is that we can remove this entire if statement right here, and then we can say, do what they do here, 2 question marks and then a single equal sign right there. And that should then in theory do the same. Then if we go into the rename dialog, and I'll just hold down Control or Command and then click this to navigate, then we just need to escape some apostrophe. I think it's down, let me just see if I can find this. Right here, there is an apostrophe. So we'll just need to escape that apostrophe with the following symbol right there. Then going further down, we have this null coalescing operator. So we'll just go ahead and do this in this case. Then we can go down, promises must be awaited. Here I'll just prefix the portal with void, and then I'll just make sure that it still actually works. If I hop over here and refresh, like this, and then I just click custom portal, I just want to make sure that it still redirects, and it does. So that fix was perfectly fine. And then scrolling down to the next ones, we have this one. So we can replace these lines right here with URL, and then push to URL, and we'll just do the exact same just for replace down here, like this. And then scrolling down further, we can see that we have this one, promises must be awaited again. So the play right here should be awaited, and I can see that this is not a promise, so I'll say await for this one, make this asynchronous, and then the toggle play is just called from an onClick, so that is going to be fine. Then going down here, we have unsafe assignment of any value. So this I would like to fix by saying, and I just had to spend a little time looking into this, but I found out that we can put on a type where we say s song ID string. And so I'll take this entire thing, and then I'll call this s song ID string, like this. And we can then say dot song ID right outside of this. Cool. So now if I run the linter, I should be able to get one that is clean. So I'll just wait for this to finish now. And I don't see any more errors now in the linter, so that is perfectly good. So this should allow us to actually go ahead and deploy the application. First, I would like to create a repository for on GitHub. So I'll go into File, Open Folder, and then I would like to open up the front end specifically. In here, I'll say initialize repository, and then I would like to, just say initial. And we'll just check that we don't have anything that shouldn't be here. And it seems like we do not. So that is perfectly fine. Then I would like to say commits and publish branch. In here we'll just say music generator frontend, like that. Then we can publish to a private repo and just let this happen. Then we can open it up on GitHub over here. And now we can see the repo on GitHub. Then we'll head over to the cell and do the deployment on the cell. So I'll say login, and I'll just log in with GitHub. And now we are on the page, on the dashboard page. Then we'll create a new project. And I would like to just take this music generator frontend and then import this project from GitHub. Then we can say environment variables, just hop into right here. And then let me just take all of these different ones and then copy them in like that. This should paste in all the different environment variables. Now we need to make a couple of changes. First of all, we have the Postgres database right here. That is the development database. So if I just hop into Neon and then find the actual, let me just make this larger again, and then find the production database right here. Then we should be able to connect to that one. So I'll say connect, and then I'll say show password, And I'll just take this entire string and then paste this into the visual deployment under the database URL. Now for this BetterAuth URL, I'm actually just going to remove that because I think we aren't using it. So I'll say BetterAuth URL, and it seems like we aren't using it, so I'll remove it both here and also in our environment.js file, and all the way up here. We also have the same one. Good. And then for the rest of the environment variables, the secret will just keep as it is. It's just a secret. You should probably generate a new one. So I'll just take these first three, and then just say something else like this. And then the modal key and the secret is going to be the same for the AWS keys, the S3 bucket name, and the generate from description endpoints will be the same as well. And for the Polar access token and webhook secret, we still want to connect to the sandbox environment, just because even though I do a production deployment now, I don't want to actually use my real credit card whenever I try it out. But if you were to actually deploy this and have it working with payments, you would like to use not the sandbox mode, but the real server mode. But luckily the entire setup is exactly the same as this one. We might need to hop into Polar in a second though, and then just change up this actual endpoint URL that we hit. Because we won't be routing it through ngrok anymore, we'll just send the webhook straight to the Vercel deployment. So I'll hop back into Vercel now, and then I would like to go ahead and say deploy, and then we can see if we get any errors right here in a second. So I'll just wait for this to do something, and then I'll return back. And we got a deployment error down here, and it's because I just forgot to push our code changes to Vercel, to GitHub. So I'll just go ahead and push this change right here, and then say removed, and then BetterAuth URL like that. So I'll just go ahead and push this up now. And then if I go back over here, we should be able to deploy this again now. So I'll go ahead and say deploy again. And then hopefully it should take our new push to GitHub. So if I refresh, we can then see that we have a push right here, remove BetterAuth URL, a commit. So hopefully it takes that commit right here. Otherwise we'll just have to refresh the page maybe. So it just finished over here and we got an error in create.tsx. So I'll go ahead and hop into create.tsx. And this is just a button we used initially just to test something out. So we don't really need this anymore. So I'll just go ahead and delete this component. But if we then hop under problems, we can see that we have another problem right here as well under sidebar.tsx. So we'll just say control and then dot. And then we can say use type and just fix that as well. And then I think this one we won't really do anything about. But now if we just say fixed broken create.tsx, we'll just say commit, push this, and then it should be visible over in GitHub right here. And now we have fixed broken create.tsx. Then I'll just try and redeploy again, just to see if that fixes all errors now. Good, so it just deployed over here, and now I would like to change a couple of things before it actually works. So first of all, we need to make sure that the database schema is actually also the one applied in the production database. So I'll hop into Neon, and then I would like to find the following URL right here. And then I'll just hop under tables. And then right now we can see that there are 0 tables in the public schema. But then if we hop under environment variables, and then we just insert the production one in right here, I'm just going to push the schema that we currently have in development to production, because right now production is just an empty database. So now that should be pushed. And then if I refresh over here, we see all the different schemas in the production database. So the database should then be ready to use. Remember to revert this to the actual development connection string, because otherwise you'll be working with the production data while you develop, and that is really bad. But that was the first thing that I wanted to do. Now, I also would like to add the actual endpoint to Polar over here. So if I just, close a lot of these tabs right here, I got way too many right now. This one. And then I would like to use the correct URL over here for the webhooks. So I'll just continue to the dashboard for now. And then I would like to find the actual deployment name. That is this domain right here, music generator frontend. So I'll take this one, and then I'll hop over here to the webhooks, and then I'll just replace the URL with the correct one. So right there. So now we have music generator frontend Vercel app, and then /API auth Polar webhooks, and then I'll say save, and then we'll be able to test this out in just a second. And then before doing more, we can just set up Inngest as well. We'll need to deploy that too. So I'll search for Vercel, Inngest, And then there's a guide right here, which I'll just follow. So this is going to be a plugin on Vercel for Inngest. So I'll just try and click install and then see where it takes me. So right now I already have an Inngest account, but if you do not, you can just go ahead and create one. So I'll just say link existing Inngest account and press continue. Then I would like to say specific projects and then give it access to the music generator here. Then I'll say create account, connect account. And then we'll just see what happens. So this one we'll say selected, and then we can say save configuration. Then I'll try and click continue here. Then hopefully it should set something up for us. Good. So now we have this installed, it looks like. So if I hop back into overview, music generator frontend, and then settings, I should be able to see under environment variables that I have the ingest event key and signing keys set up. And this was done automatically by the installation, which we just did. And then I would like to hop into the real ingest dashboard as well. So if I search for ingest and then for sign in, you can also sign up if you do not have an account. Please use the link in the description though, because it will attribute it to me, which is something I would really appreciate. And then click GitHub. And in here, we should then be able to find our active app. So I'll just try and say sync new app, sync with the cell, go to the cell configuration. And then it says that this is enabled, but I would like to just click configure. And then I see that we have this Vercel deployment protection that might be blocking synchronization. So I'll actually just hop into Vercel and disable this, because we won't really need that whenever we have the app deployed. Or at least in this case we won't. So I'll go under settings and then deployment protection. And then it says ensures visitors to your deployments are logged into Vercel and are a member of your team. But this also means that if you're not logged in as a user, you won't be able to see this. And because any of our users would never be able to be logged into our Vercel, they would never be able to visit our application. So I'm just going to disable this deployment protection and press save. And then let's see if anything changes over here. Maybe if I refresh, we can see that the warning/error is gone. Let me just try and hop back into production and then see if we can see our application now. So now it says unattached synchronizations. So this is at least different than before, so that is great. If I click view details, we're able to see that we could not reach your URL. Please verify that your URL is correct and check your server logs. So I think we might need to actually redeploy the entire application. Luckily, you can pretty easily do this here in Vercel. So I'll just hop under my projects. And then if we go under deployments, let me just take the newest one right here and then just say redeploy. And then I'll just say redeploy and wait for this to finish. So the deployment just completed right here. And we can also see if we click this that the deployment protection is disabled. So now let me just hop back into Inngest and see if anything is different from last time. So I just waited for 5 minutes and then refreshed again, and now we can see that the music generator is active over here. And if we go under functions, we're then also able to see our generate song function right here. And we'll then also be able to see our runs up here like we were whenever we were developing. So I think that this looks like it is working. We'll be able to test it out in just a second when we test out the application. So if I hop into the following domain right here, that is the domain of the deployed application. Let me just zoom in. I'll then say sign up. And under name, I'll say Andreas, and I'll put in an email. I can also put in a password. And then right now in the Neon database, we can see that we have no users. One very important thing though is that we actually share the Polar environment right here with both the development and also production right now. In reality, this right here would not be pointing to the sandbox, so the production deployment should not point to the sandbox, and therefore you wouldn't run into this issue that I'm about to explain. But because we're just testing out with the sandbox, you just need to be aware of this. So we have a customer right here that already has the email andreas@gmail.com, and it then has a user attached to that inside the development database. We then have the production database over here as well, and then we have this new user that we're trying to create with the same email. So this is most likely going to fail because BetterAuth and Polar associate this user with a specific external ID from the development database. So things are probably just going to break if we create a user with the same same email. So let's try and do that just to see what happens. So we'll say password 123, and then just put in the same email. And then if we go ahead and click create, we get the following error message: Polar customer creation failed. And then it says customer external ID can be updated. And that is probably because we have an external ID matching the development database, whereas the external ID from our database, so a user was just created probably up here. This is the production database, whereas the production database has another external ID than the development database. And this is only a problem because we are testing with the sandbox mode in production, and that's not what we want to do. It is just so you're aware of that. So let's just try and make an actual user that has another email. So I'll just say Andreas123 and then put in a correct password again and say create an account. And now this actually works. So if we go into Polar here, we see that we now have a user or customer called Andreas123 at Gmail. And in the Neon database, we also have a user that it has the same email and then also an external ID. Cool. So now we know that we are able to create a user. Next, I would like to actually try and upgrade by some credits. So I'll click upgrade right here. And we are then taken to the sandbox environment again. I'll buy this one with 25 credits. Then I'll put in the fake credit card details. And I'll then put in Denmark and say pay. And then something should hopefully happen whenever this pays. Like this. Let me just try and refresh. Yeah, so now we see that the webhook is working as well. We got 125 credits. And then if we hop under the Polar right here and then go under settings and webhooks, then let me just try and say details, and then we can see if the webhook was sent. So the webhook right here was sent with 25 credits, and it was sent to the production URL right here. And that is also why we got our 25 credits right here as well. So the payments works as well. If we then hop under the customer portal, we should be able to probably see our purchase. So under orders, we can then see this purchase that we made, and we can view the order, download the invoice, and we can also see our information here. Then let me just hop back again to right there. Then the next thing I would like to check out is the settings. So the settings work fine as well, it looks like. Let me just see security, and I can then say Andreas T, save that, go back, and we then see Andreas T right here, so that works fine as well. If I then go ahead and say create, and then put in a dreamy lo-fi rap hit, if that is even a thing, then I would like to put in create. And now if this works as it should, it'll put a queue, an event into the Inngest queue. So hopping into app.inngest.com, so the production deployment of Inngest, we should be able to see it working over here. So under runs, actually, we can now see running and queued, so that all works perfectly fine. Then let me just add some other different variations. If I go into auto, then I say heavy bass and orchestral, and then I say lyrics about, or I'll say something beautiful about water bottles. Then I'll go ahead and say create. Then I'll also make another one with write. I'll say electronic beats. And then I would like to up here say bus. And then this is the best water bottle ever. Something like that. And then I'll just try and say create again. And lastly, we can just check out the instrumental option. So if I put in instrumental rave, for example, and then say instrumental right here, and then I say create, then it creates those queues as well. Then now inside we can see that the first one finished. So if I hop into the Inngest queue, refresh the runs, we can see that the first one completed, and then the next one runs, and then all of the other ones are queued because every user can only have one running at the same time. So let's just try out the first one that was created up here. So it seems that everything is working end to end. Let me just try and play this.
the quietude of the night.
So a sound is at least being generated, so that is pretty cool. Let me try and say download. We can download it as well. And if I say publish, go to home, we can then see the hit being published over here. And we can play it from the Discover Music dashboard as well. Let me just try and play this other one up here.
Search without a band, it travels with you, it travels with you. Of nature's art.
And then if I say rename, for example, and then I say the water bottle song, save the changes, and then just publish this one as well as these other ones, and then hop back into home. We then are able to see the water bottle song, the dreamy lo-fi rap hit, so I can just play this one as well.
A new story unfolds in this loving world. I find a new feat.
Then I can just try and like some of these, like this one for example. Then if I refresh, I should be able to see that it has one listen now, and they do. Then if I hop under create, I can then also see the rest of the songs slowly finishing up. And this is very different from the other ones. This does not sound very great. Let me just try this other one as well.
This is the best water bottle.
So something about water bottles, it sounds terrible though. Let me just try and publish this one. And then that name is going to be untitled as well. So we might as well just try and change that. I'll say rename and then water bottle, terrible song. Save that. Then if we hop over here, we can then see the name being changed. Now I would like to just take this URL and then just create a new incognito mode. And then in here, I'll just create another user as well. This will be testing. And I'll just create this account too. And then we can now see these published hits from Andreas T. Then if I create one myself, so I say rap battle and then just create. Let me just try and wait for this to finish. Then we can publish these and then see if they are available to be seen over here on the other user's profile as well. So I'll just come back whenever these are done. So the songs just finished up here, and I can just try and play one of these.
I'll flow so fast, it'll make your head spin. Running through the flame with a fire, lightning, the thunderstorm in the brain.
So that sounds decent, but not very good. We'll try and publish these two. And as you can see, both from this account right here and also the other ones, there is a large variety in how the songs actually sound. Some sound pretty bad, while others sound alright. And that is also the reason that I wanted to generate 2 songs at a time whenever you click create, and then use these different parameters, so the garden scale, to try and create some variety in the tracks. So now that these 2 are published, if I go to home, they should be visible over here. So we have rap battle and rap battle. Then going into our other deployment, other user over here, going into the home page, we can then see the rap battle and rap battle as well. And if I then like this, go back over here and refresh, we're then able to see that it has been liked. So it seems to be working just fine in production as well. So now there isn't much else to do than just walk through the exercises that I've prepared in Excalibur. So if we hop into Excalibur again, and then I'll just make this full screen now. This is what you can do to become even better with at developing this application. So first of all, you can go ahead and try and create an input field where users can set how many songs they want generated before clicking create. Because right now, when you click, you have 2 of these songs generated, regardless of what you do. And this is nice because it creates some variety in the songs for the user. But maybe if you create an input field where the user can input, for example, 5 different songs, it will then create 5 different songs with different varieties. And you would then have to take these 5 different songs and add those as events to the ingest queue. This would also allow the user to create a single song at a time in case they wanted to spend as little credits as possible. Another thing you can do that is a little bit harder is to create a public account page for each account. This means that you can navigate to an account and then see the user's public songs. Right now you can only see the create page and then also the actual dashboard page where you can see all the public songs. But let's say that you go into home right here and then you click on testing or you click on Andreas T. Well, in that case, it would be pretty cool if you could go to an actual account page for that user and then see the songs that that user has published. So that is another thing you can do that is a little bit more challenging. With this also comes another kind of page where you can create a song page where the users can both see the lyrics of the songs, but maybe also the prompts that you used to generate the song. And then on the song page, you can then also create a way for users to comment on songs. And then all of these comments would be visible to other users on this song page, which you previously created. You could also let users create playlists where they can take music songs that are published from other users and then create full playlists where you can then play all the songs. Or maybe you can create a playlist called something like hip hop songs and then you add 10 of your favorite hip hop songs that are AI generated to your playlist. And then you could also create a feature where playlists can even be made public too. And then on this user page up here, you should be able to see a user's public playlist as well. Another cool thing you can do is that you could let users upload and also set a profile photo. So we already have the S3 bucket set up. So you might use that one with a folder or another one if you would like to. And then you can let a user upload their profile photo. And this will then get uploaded to an S3 bucket and then shown in the profile page whenever you navigate to the user's profile page or just for their own sake. So if you want to build around with the UI features and also just the Next.js application, these are the features I would recommend you building out because they're pretty cool and something that you would expect for a software as a service application like this. If you just want to play around a little bit more, you can play around with the model generation parameters. We have already set up the APIs such that we can provide the info steps and guidance scales and also the audio duration. So you can try and play around with these ones and then find out what they do and then also how the model output changes whenever these change. But there are also other parameters that we can pass into the model to change the output of what it generates. So try and hop into the GitHub of the A-step model and then look through both what they support in the documentation, but also look about what people are talking in the issues. So maybe some person found that if you tune a specific parameter, it makes really good rap songs, for example. So that is one thing that you can try if you just want to play around a bit. Then if you've created some of these features up here, what you can then do is that you can create a search functionality for searching both through all public songs, but also different genres and also different users' profiles and maybe even different users' playlists. So for example, if you use Spotify, you can put in a search query and then you are searching among all of these different things. So this I would say is a little bit more difficult than just creating a UI feature up here, but it's a pretty cool task as well if you have set these other ones up. Also, you can create a feature where users can follow other users. So if you create this feature where users can have an account page, you should be able to have a follow button. And then if I, for example, follow another user, I should get a notification every time that that user makes a song public. So how you can do this in practice is that you can use something like an Inngest function that runs in the background. So whenever you publish or make a song public, then you run this background Inngest function that notifies all subscribers to your profile. And this is then run in the background every time a song is published. So in case you want to work even more with the above or with the SaaS that we've created in this video, these are the exercises that you can take a look at. Otherwise, I hope you enjoyed the build of this SaaS. And now that you have built the entire infrastructure and also all the pages around this A-step model, whenever a better model comes out, maybe in a couple of months or in the future, you will pretty easily be able to go into Modal and then change out the A-step model with that new model, or even create a feature where users can switch between models, such as you are able to in software products such as Suno.ai, for example. Because these music generation AI models are pretty big at the moment, so a lot of people in the world are trying to create these. So if you just watch the space on Twitter or on GitHub, you'll be able to find other models that come out every maybe 2 months or so, that then improves a little bit upon the previously created music generation models. So thank you for following this video, and then I'll see you in the next one.